Now it's time to download and install an IDE, and throughout this course I'm going to use an IDE called IntelliJ IDE, which is an IDE made by a company called JetBrains. Now you may be wondering, what is an IDE? An IDE stands for an Integrated Development Environment, and it's basically the tool that you're going to use to write a code in. And IntelliJ IDE is like a text editor, but a very sophisticated one because it has a lot of features like highlighting our code, showing real-time errors and suggestions. You can run and compile your code just by a few clicks. In other words, it's making the process of writing code easier and better. Therefore, let's download IntelliJ IDE. So I'm going to open my browser, and in the search bar we type IntelliJ IDE, press enter, and we click on this download link. And on the downloading page, you're going to see two options: Ultimate, which is paid, so you need to pay in order to download it, and Community, which is free. And the difference is that the Ultimate has more features and Community has less features, but Community is not for our purposes. Also, pay attention on the left hand side. When I'm currently recording this video, the latest version is 2021.1.2, which was released on the 1st June of 2022. And if you look at the system requirements here, if you click on that, you will see that this IntelliJ IDE only works for a 64-bit version of Windows. So if you have a 32-bit version of Windows, this will not work for you. Now, if you have macOS or Linux, you should download the particular version for your system. And if you don't know how, just tell me in the comments and I will make two separate videos and I'll show you how to do. Now, I'm going to download the community version for Windows. So click to download the community. Now our downloading is starting on the right hand side on the top. And if you have a different browser, you will see this in a different place. So once the downloading is finished, just open this file. I'm going to close the browser now because I don't need the browser, and the installation will start immediately. Now it's asking us if you allow this app to make changes to our device. Click yes. Here we need to click on next. This is the folder location where IntelliJ IDE is going to be installed. You can keep the default location or you can change it if you want. I'm going to keep the default location, so I'm going to click on next. And here I'm going to check this box to have a desktop shortcut. I'm going to click on next. Now I'm going to click on install, and IntelliJ IDE is going to be installed on my computer. As you can see on the left hand side, IntelliJ already appeared. Now let's wait until the installation finishes. When the installation finishes, just check this Run IntelliJ IDE Community Edition and click on Finish. Now IntelliJ IDE is going to open. Now it's asking us if you want to import IntelliJ settings. So if you have the previous version of IntelliJ IDE, you can import the settings here. But I'm going to click Do Not Import Settings and click on OK. Now IntelliJ IDE is going to open. And this is the welcome window of IntelliJ IDE. And here on the left hand side, click on Customize. Go here where it says Color Theme. So you can change this theme because the default theme is this dark theme. I'm going to change it to light because the IntelliJ Light theme is better for tutorials, but you can keep the dark theme if you want. And in a separate video, I'm going to show you how to add more themes, not just the ones provided by IntelliJ IDE. Now click back on projects, click on this plus button where it says new project, because we need to configure the JDK now. And now here we have JDK, and we have in red in angle brackets, we have no SDK. And now here we need to add the JDK, and JDK stands for Java Development Kit, SDK stands for Software Development Kit. So Software Development Kit is the Java Development Kit, no matter how you call it. This thing contains the tools that IntelliJ IDE needs in order to be able to compile and run our programs, because without them IntelliJ IDE it's like an empty text editor. So it needs those tools in order to be able to work with our particular programming language, which is Kotlin. Now, to download the JDK, and we use Java Development Kit because Kotlin and Java are interoperable, and that means that we can use the existing tools and library which Java already has in our Kotlin project. So we click here on this No SDK and click here where it says Download JDK. Now, on this window, we select version 17, not version 18, because this is the latest version 18. We choose version 17 because this is the version which has the long-term support. And that means that it will receive bug fixes and updates for several years to come without you needing to switch to a new version when that new version is released. For the vendor, we choose Amazon Corrector, and I'm going to let the default location. So I'm going to click download to download the JDK. Now the JDK is going to be downloaded. Now the JDK has been installed, and it's installed on our IntelliJ IDE. And now we can create our projects, but I'm not going to create a project, so I'm not going to click on create. I'm going to click on cancel, and in the next video we're going to create our first project. And we're also going to talk about a little bit the JDK and the JVM. So see you in the next video. Now it's time to download and install an IDE. And throughout this course I'm going to use an IDE called IntelliJ IDE, which is an IDE made by a company called JetBrains. This is the same company behind the programming language that we're going to study throughout this course called Kotlin. Now you may be wondering, what is an IDE? An IDE stands for an integrated development environment, and it's basically the tool that you're going to use to write our code in. And IntelliJ IDE is like a text editor, but a very sophisticated one, because it has a lot of features like highlighting our code, showing real-time errors and suggestions. You can run and compile your code just by a few clicks. In other words, it's making the process of writing code easier and better. So to download IntelliJ IDE, just open the Ubuntu software program. You go to search. We type IntelliJ IDE, and we choose the community one. So we choose this one. We click on install, and now IntelliJ IDE is going to be installed on my computer. Now IntelliJ IDE has been installed on my computer. I can close this, and as you can see on the left hand side, it appears. So let's click on IntelliJ IDE to open now IntelliJ IDE. So we have IntelliJ IDE Community 21.1, and this is the default theme, the light theme. You can change this theme by going to customize and click here to choose another theme, but I'm going to keep the light theme because this is better for tutorials. I'm going to click to create a new project. I'm not going to create a new project, but I need to configure something, and only from here I can. So here we have in red no SDK, and what is this SDK? SDK stands for Software Development Kit, and JDK stands for Java Development Kit. And this thing basically contains the tools that the IntelliJ IDE needs in order to be able to compile and run our programs, because without the JDK it's like an empty text editor. So you need to provide those tools in order to be able to work with our particular programming language. Now, JDK stands for Java Development Kit, and this thing, Java Development Kit, contains the tools that we need to develop and run our programs, because IntelliJ IDE, it's empty. It needs the tools to run, and it needs the tools to compile and run our programs. And here we need to add those tools, and you click here where it says download JDK, and we select the version 17. We select version 17, and for the vendor Amazon Corretto, we choose version 17 because this is the version which has long-term support. And that means that it will receive bug fixes and updates without you needing to switch every time they release a new version, without you needing to switch to that new version. We can choose the version 17 because this has the long-term support. Click on download, and now the JDK, the Java Development Kit, is going to be added to our project. It's going to be added to IntelliJ IDE. So now it's downloading, it's installing. Alright, so now IntelliJ IDE has been installed to our computer, and we can create now a project, but I'm not going to do that. I'm going to click on cancel because we're going to create a project in the next video. So see you in the next video. Now it's time to create our first project, and there is a tradition in programming that our first program should be to output the text hello world to the console, and this is what we're gonna do in this video. Therefore, I'm gonna open IntelliJ IDE. You should open your IntelliJ IDE. On the left hand side, make sure to have project selected, then click on this plus button to create a new project. And here we have a few options. The first is the name, and here we need to name our project. We need to give a name to our project, and the name of the project should start with a capital letter, and if it has multiple words, every word should start with a capital letter. So I'm gonna call this and this way of naming is called the Pascal case. So I'm gonna call this this project hello world, and also you should not have white spaces in your name. Next we have the location, and this is where the project is going to be created. You can change this location if you want, but I'm going to keep the default location. Next we have language, and here you need to select the language on which this project is going to be created. So we select Kotlin. If Java is selected, just select Kotlin. For the build system, we select IntelliJ. and next we have the JDK, the Java Development Kit. And if for whatever reason it says here in angle brackets no JDK, just click on that and go down here down of two options. It should say detect JDKs, and you will see the JDK down there. You're gonna see Amazon Corretto version 17. Just click on that and it's gonna be added here. Next we have this add sample code, and what this is gonna do, as the name implies, is gonna generate some code for us, but I don't want to have that code generated now, because I want to type that code myself, and I want to explain that code, and in the next video we're gonna check that to generate the code for us. So I'm gonna click on create now to create the project. And here you have the tips. You can keep the tips activated because it's useful information, but I'm gonna check this. Actually, I'm gonna just close it. Here we have those windows which says there is a plugin update installed. I'm gonna close this. So what we have now on the left hand side is called the project pane, and here we have some folders which IntelliJ IDE generated for us. But now I want to show you how to check for IntelliJ updates, because in this way we'll have the latest features throughout this course. And to check for IntelliJ updates, you go to help and you go down here where it says check for updates, and here you can check for IntelliJ updates, and you'll see a window down here, and if there is an update, it's gonna say that there is an update and you can install that update. But now it's saying that you already have the latest version of IntelliJ IDE and plugins installed, because we have the latest updates. But it's good to check for this, because in this way we'll have the latest updates throughout this course. Next, check if you want to check for Kotlin updates. So for the programming language Kotlin, you go to Tools, Kotlin, and go here where it says Configure Kotlin plugin updates. And if there is a new update, you'll see it here, and you click on install, and that update is gonna be installed on IntelliJ IDE. So there is no update because we have the latest updates. I'm gonna click on OK. Now let's focus on the left hand side, and if you see something like this and you don't see this in this expanded form, just click on this greater sign in front of SRC. SRC stands for source. This is where our source code is gonna go. Then click on this greater sign in front of main and make sure to have the folder Kotlin selected. On this folder Kotlin, this is where we're gonna add our code, but first we need to create a file, and the file is the thing where we're gonna put our code. So we right click on this, go to new, and here we select on the right hand side, we select Kotlin class file. Now we need to give a name to our file, and I'm gonna call this file main. You'll see the reason for this later. So I'm gonna call this file main. The name also should be in Pascal case, so it should start with a capital letter, and if it has multiple words, every word should start with a capital letter. And from these options that we have here, we select file, because we're gonna create, as I said, the file. Now press enter. Now the file was created for us, as you can see in the folder Kotlin. Now we have main.kt, we have the file, and also it opened the file for us. Let's click there. Now if you don't have the file opened, and if you have something like this, just double click on the file and the file is going to be opened for you. Now we're going to type some code. Now you need to type exactly what I typed. So type fun. So while I am typing, as you can see, IntelliJ is trying to help us and is giving us some suggestions. So he's saying, do you mean fun? That and if you want to fill in that for you, just press enter, because I want to type that fun keyword, fun, and it also added the space. So fun space, then you type main, and next we need to put parentheses, and as you can see, this play button now appeared. I'm gonna explain immediately why. And we put left parenthesis, and when we put the left parenthesis, the right parenthesis is gonna be added automatically. So we put the left parenthesis and the right parenthesis was added automatically. Then we get outside of the parentheses, we press space. Now I'm gonna add curly braces, and again we put the left curly brace and the right curly brace is gonna be added automatically because IntelliJ is helping us. Now we're inside the curly braces, and now we press enter. and it added the curly brace on the third line and also indented this line for us. Now let's talk about what we have here. Now what we have here is what is called the main function, and the main function is the entry point of our program. So every program that you create, it first needs this entry point in order to be able to compile your code. But let's take each part of this main function individually to talk about. So first we have this fun, and fun is the keyword for creating a function. And you can use fun keyword to create your own functions, but we're gonna see that in future videos. Next we have main, and main is the name of this function. Functions can have different names, but main is a special one, as I said, because main is the entry point of our program. Every program that you create needs a main function in order to be able to run your code. And in fact, if I change the name of this function to fun main, let's say A, the play button immediately disappears, because now we don't have an entry point and our program can't run. So this is a special function, and functions can have different names, as I said, and as you'll see when you're gonna create your own functions, that you can create, you can give different names to your functions. Now, next we have parentheses, and we have parentheses because functions can take parameters and can do some work with those parameters, but our function doesn't take any parameter. But we still need to provide the parentheses because they are part of the syntax. And you can think of the syntax like the grammar rules that you need to respect in a specific language in order to be understood. And in the same way, this is the syntax in the programming sense. It's like the grammar rules in which the compiler, as you will see what is the compiler later. The compiler enforces you to respect those syntactical rules, which is to have parentheses for a function, in order to be able to understand your code. Because if I delete the parentheses here, now we have an underline which says expecting parentheses. So you need to respect the syntactical rules in order for your code to be understood. Next we have curly braces, and we have left curly brace and right curly brace, and this is called the body of the function. So this is where our code goes. So this is also called the code block because it's the block of code. This is where our logic, our lines of code go. We define them inside the curly braces. So this represents the body of the function. And let's add some code, and I'm gonna type print line here, so because we need to output something in the console. So we type here print line, so we type print, and while I'm typing, you should see a suggestion, and we have the suggestion print line, and we select the first one to fill in for us. And now we go inside the parentheses of the print line, and we put double quotation marks, and inside the double quotation marks we type hello world. Now we need to run this code, and in order to run this code, to compile this code, we can do it in two ways. First, you can click on this play button that we have here, or you can right click and you can go here where it says run main.kt, and the code is gonna be compiled. And let's do it from here first. So I'm gonna click on this play button to run our code, and I'm gonna see the console opening down, and you're gonna see the text hello world outputted. So the console opened, and we have hello world. We have the text that we type inside this thing that we have here. This is also a function, and we have this code outputted now in the console. The console opened. Now I'm gonna close the console to explain what this print line is. This print line that we have here is a function also, but it's a function which takes which takes input, and the input is this text. And this function, its job is to take whatever you pass as the input and to output that in the console. So this is what this print line is doing, and this is a function that we didn't create. We didn't type fun print line and then you call it. This is a function which is built into Kotlin. This is a function which is already built by the Kotlin programmers. So we just call that function inside our code and you can use it. You don't need to create this function. So this is what this print line is doing. So it's taking whatever you pass inside the parentheses and it's outputting that in the console. So this is our discussion about the first program, which is to output some text in the console, hello world. And now I'm gonna show you that. Now I'm gonna show you an illustration to understand what is the JDK, the JVM, and how Kotlin and Java achieves this interoperability, because Kotlin and Java are fully interoperable, and that means that you can have a Java project to which you can add Kotlin code and you can compile that code and everything will work fine. And also I'm going to explain what the word compile means. And for that I'm going to bring an illustration here. So this is the illustration, and let's talk about what we have here. First we have Kotlin source code, and Kotlin source code is the code that we wrote, is this code that is meant to be human readable. So this code is the code that we as humans can understand. We can write this code, we can read this code, but the computer doesn't understand this high level code that we wrote. It needs something, it needs machine code, it needs binary code in order to be able to understand. And this is where the JDK comes into action. So our Kotlin source code, again, this code, which is meant to be human readable, then it's when we press on that play button on that, and when we press on that play button on this button and the code is compiled, what happens under the hood is that Kotlin source code is taken by the Java development kit, the JDK, and through the Kotlin compiler. So the Kotlin compiler acts like a translator. It takes that high-level human readable and writable code. It converts that code then into what is called Java bytecode. And this is not the final step, as you can see in this illustration. This is just the intermediary step. This is not converted into machine code. Then this Java bytecode, it's taken by the JVM, so it's sent to the JVM, and the JVM then takes that Java bytecode and converts that Java bytecode into something which a specific machine can understand. But let's first explain why Kotlin, why the JDK takes this Kotlin source code and then it converts this Kotlin source code into Java bytecode. And this is doing this because different processors and different operating systems need different instructions in order to understand your code. So if we will not have this Java bytecode, so if we will compile our code on a specific platform, that code can run only on that specific platform. But because our Kotlin source code is taken by the JDK and through the Kotlin compiler and is converted into Java bytecode, and the Java bytecode then it's sent it to the JVM, and JVM stands for Java Virtual Machine. And the JVM then, because different platforms and different different platforms and different processors need different instructions, the JVM is the one which is doing the hard work of figuring out what kind of instruction that specific platform needs. So it converts that Java bytecode into machine code, let's say, which a Windows platform can understand. Then the same thing happens to Linux. The JVM receives the same Java bytecode, and then it converts that Java bytecode into machine code, which a Linux platform can understand. And then it's doing the same thing to a macOS. So the macOS the JVM is gonna receive the same Java bytecode, and it's gonna convert that Java bytecode into machine code which macOS can understand. So this is how Kotlin and Java can achieve this thing called write once and run everywhere. This is because the work of converting that machine code which a specific platform can understand has shifted from the programmer to the platform which implements that JVM. So we just wrote our code, we run our code through the JDK. The JDK converted that code in Java bytecode, and then the platform which has the JVM installed, it's doing the work of converting that Java bytecode that we wrote into something which that specific platform can understand. So, and this is why Java and Kotlin are fully interoperable. So you can add Java code to an existing Kotlin program, and vice versa. You can add Kotlin code to an existing Java program, and that is possible because the JDK is gonna convert through the compiler all of that code into the same Java bytecode, and then that code is gonna be run on the JVM, and the JVM is gonna convert that into machine code, and that code is gonna run on a specific platform. So this is how Java and Kotlin, and this is why Java and Kotlin are fully interoperable, because they are ultimately converted into the same Java bytecode, and you can also achieve this write once, run everywhere, because that code then runs on the JVM, Java Virtual Machine, which is doing the hard work of figuring out what kind of instructions specific platform needs in order to understand that code that we wrote. And in this way, that hard working has shifted from us to the people who implement the JVM. So this is how the JDK and the JVM works under the hood. And if you find this confusing, don't be. This is just a relaxed discussion about how the JDK, what is the JDK, and what is the Kotlin compiler. Because I said our Kotlin, I said previously that our code is compiled. When I said that, this is actually what was happening. Our code was taken by the JDK, and through the JDK was converted to Java bytecode. Then it was sent to the JVM of which is on my Windows, and then that is converted into machine code, and then we see in the output hello world. So this is our discussion about the first program, how to create the first program, hello world, and this is the additional discussion about how the JDK, how the Kotlin compiler, and how the JVM works. So see you in the next video. So in the previous video we created our first program, and even though it was a simple program, you should celebrate because you created your first program. But if you want to make your program to do something useful, you need to store data. And in order to store data, we need to use variables. And this is what we're gonna talk about in this video. Therefore, I'm gonna open IntelliJ IDE. I'm gonna create a new project. So make sure that on the left hand side you have project selected. Click on this plus button to create a new project. I'm gonna call it variables. It should be in Pascal case if it has multiple words. Language, we have already Kotlin selected for the build system IntelliJ. And also make sure to have the JDK selected here. And now I'm gonna check this add sample code, because this is gonna generate the code that we typed previously, respectively the main function and the print line and the hello world. Text is gonna be now auto-generated for us because we check this box, add sample code, and it's gonna add the code automatically for us. So I'm gonna click on create. Now our project is ready to go, and as you can see here, it generated some code for us, and this is similar to what we did in the previous video where we created our code ourselves, but we have some additional code, and I'm gonna delete this additional code because it will make things confusing. So I'm gonna delete this part. Sorry, I'm gonna delete this part. And also you may have noticed that here in inside this parentheses now we have this args, array, and string. We can delete this too because it will make things confusing, and we're gonna talk about what are arrays and all of that in the next videos. Now I'm gonna alright, now we're ready. Now let's run this code to see what is happening. It's gonna output that text like it did in the previous video. You should open the console in a short moment. And indeed it opened the console and it outputted the text hello world like it did in the previous video. So I'm gonna close the console now. Also, let's expand this src to see the file that it was created automatically for us this time. And let's change this hello world text to print another text. Let's print type your name there. In my case it's Alex. So I'm gonna run this code and it will output my name in the console. Alright, so it outputted hello Alex like we typed here, but it's what we have here is pretty inflexible. A better way to do that it will be to have something to store this name and then refer that thing here, to call that thing here. In this way it will be a bit more dynamic. And to do that we need to use variables, and variables are like some containers which can hold data values. And let's see how to create a variable. Okay, let's put the code below above our print ln statement. And if you don't know what a statement is a complete instruction of execution. Now, to create a variable, we just type the keyword var, which stands for variable. Alright. Next, we need to give a name to our variable to be able to refer it later, to call it later. And the naming convention around naming a variable is called camel case, and that means that the first letter in the name, if it has multiple words, should start with a lowercase letter. So I'm gonna type user, and the next word name with a capital letter. Alright, next we need to provide the type of the variable. And that means what kind of data this variable is gonna hold, is gonna store. To do that we need to put colon, and next we need to say what type of data is gonna store, what data is gonna store. And we want to store text, and to store text we need to type here string. And string means that this variable is gonna store a sequence of characters or text. Now we need to assign a value to this variable, and to do that we put here equals space, and because we explicitly said here that we're gonna put text or string, we put a double pair of quotation marks, and we type Alex. Alright, so now we create our variable, we give it a name, a type, and we've also assigned a value to this variable. Next we need to refer this variable down here, and to refer that variable, I'm gonna delete this text first, and to refer the variable we put $, and after the $, we start typing the name of the variable, user, and as I'm typing, the IntelliJ is giving us some suggestions, and it says, do you mean this username variable? And it also has this v here for variable. So I'm gonna press enter to fill in that for me, and if I run this code, you'll see the exact thing happening here. It outputted the text hello Alex, but this time we didn't type the text directly here. We stored that text in a variable and we call that variable in our println. I'm gonna add a space here to make things more clear. Now what we can do is to change the value of this variable by adding below of our variable, typing the name of the variable again, user name equals, and now we can assign a new value to this variable, and let's put John here. Right, let's run this code to see what happens now. Now this time when this instruction is going to be called, it's going to print the new value of the variable, which is John. So as you can see down here, it outputted the text hello John. So we can change the value of the variable after we assign a value to it. But what you can't do is to type here username equals 5. And if you hover over here, it says integer literal does not conform to the expected type string. And in other words, it's saying that we said explicitly up here that is gonna store only text, and down here we try to put a whole number, an integer, and that is not gonna work because Kotlin is a language which is called statically typed, and that means that it will check the types of the variable at compile time, not at run time. And that means you cannot run your code if you assign a value to a variable which has a different type than the type that you specified when you declare the variable. This is why we get this warning here. And if I delete this, now let's delete this. All right. Okay. The next type of variable that also actually not the next type the next way of declaring a variable is using the keyword val. So if you declare a variable as val means that we cannot change its value after we assign a value to it. So if you try to assign a new value to our variable like we did here up here, it will not work. So let's actually just change here. Let's put val. Okay, and after I did that, it immediately underline in red username, and it says val cannot be reassigned, and that is because if you declare a variable as val, you cannot change its value later. It will you can put a value to that variable only once, and that's all. You cannot change the value of the variable later. So let's change this back to var to have the ability to change the value. Now let's look at another type of variable. So I'm gonna type var again. I'm gonna call it age. I'm gonna put colon to specify a type here, and now we're gonna use another type, which is int, and int stands for integer or for whole numbers. Now I need to assign a value to it. I'm gonna put I don't know, 10 or I don't know, 20, 22. All right. So what we have now is a different type. Up here we have string, and that means that we're gonna store a sequence of characters, and down here we have integers, and that means that we can store only numbers, only whole numbers, and there are different type of numbers which we're gonna look in the next video. And if I try here to change this first let's actually print this hello Alex. Let's type your age is, and here you put $, and we call the name of the variable. We type the name of the variable age. So we press enter to fill in that for us. And if you run this code, now it says, hello John, your age is 22. So it's using the values of this variable in our println, and we can change for the variable also its value, because it's declared as a var, not a val. So we can put here age equals, let's say, 25, and if you run this code, the change is reflected immediately in our code. So now we see, hello John, your age is 25. What we can't do, like in the previous example with the username, here we cannot put a string. We cannot put here Alex, because we said explicitly here that this is gonna hold only integers, only whole numbers. So I'm gonna delete this. Let's put it again to 25, and the error disappeared. All right, now let's look at what we have here, because we have these underlines, this gray light out of our types, and every time you see something like this, that means that IntelliJ is trying to say something to you. And if you hover over here, actually let's hover over the type. It says explicitly given type. It's redundant here, and that means that it does not need to. We don't need to say explicitly here that is gonna hold a sequence of characters. It's gonna hold string, because it knows this. It can, because Kotlin has something which is called type inference, and that means that it can infer the type of the variable by the value we assign to it. In our case, we assign some text. So if I delete the type here, now it's still working. And if I, as you can see, if I put here, let's say if I try to put here username equals to 3, it's still treated as a string, because it inferred the type by the value you assign to it. And similarly, this thing applies to our int type. So if I delete this, it's still working. It's still treating this as an int. So if you try to put here age equals to a text, I don't know, again we have this error, and if however it says type mismatch, require int and found string, and that means that it's still treating this variable as an int, because as I said, it has something which is called type inference, and it can infer the type of the variable by the value you assign to it. Alright, this is our discussion about variables. There are more types of variables, and we're going to look at that other types in the next videos, and collectively they are called data types. Okay, you can remove this space if you want. So I'm going to end this video now, and see you in the next video. So while I was recording this course, JetBrains have released a new version of IntelliJ IDE, and you will see in the course, when I create a new project, you will see a different window. It's not that different, it's slightly different than this window, than the window that you will see when you download IntelliJ IDE, which is this version now, which has this window. And when you see this window, here you just need to specify a name. Here you specify the location. For the language, select Kotlin here. You select for the build system IntelliJ, and you make sure to have the JDK here, and you also check this add sample code, and that is going to generate the main function for you. And you click on create, and the project is going to be created for you. So I thought that it's good to tell you about this, and if you will see this window, and if this window changes in the future, I'm going to release a new video in which I'm going to show you how to, if they change specifically the window of creating a new project, how to create a new project with that window. But for now, this is the window of the latest version. Alright, so in the last video we talked about variables, and we seen there that we can store different data in our variables, and we looked at two different data types, or types in short, and that was the string type and the int type. And the string type was used for storing sequence of characters or text, and the int type was used for storing whole numbers. And in this video, we're gonna take a deeper look at the integer data type, and we're also gonna extend our understanding to more types for storing whole numbers, and that is the byte, the short, and the long data types for storing whole numbers. And you're gonna see what is the difference between these types. Now let's open IntelliJ IDE. I'm gonna open my IntelliJ IDE. On the left hand side, make sure that project is selected. Click on new project. On the left hand side, make sure the Kotlin is selected. And here you need to give a name to our project. Again, it should be in Pascal case. I'm gonna type byte, short, int, and long. Now go down here and it's gonna select IntelliJ and make sure that the JDK is selected. Click on next to create a new project and click on finish. Now our project is gonna be created. And down here again is IntelliJ is setting up our project. On the left hand side we have our project pane. I can expand this SRC to see our file, our main file that we created first. Now it was generated for us automatically. I'm gonna delete this code, and here we have something which is called comments or a comment, but we're gonna look at comments in a separate video. So I'm gonna delete this. Sorry. Okay, I'm gonna add a space here. I'm gonna delete this. You can keep the args there. It is not gonna affect your code in any way, but I want to make it consistent with my previous videos. But you can keep the args there. It will make no difference in the way your code is compiled. Now, let's add the code that we had previously. And previously we had a variable of type string for storing text. Specifically, we store our name there. So I'm gonna type the var keyword because in the last video we established that we want to change this value later, var, and here we need to give a name to our variable. I'm gonna call it name like in the previous video. For the type I'm gonna choose string, and I'm gonna put equals, and now it's time to assign a value to it. I'm gonna put again our text. Alright, and down here I'm gonna declare a variable, but this time I'm gonna declare it as a val. I'm gonna type for the name age, and for the type I'm gonna put int for storing the whole numbers. I'm gonna put 22, and we see in there that we can delete the type here because Kotlin has something which is called type inference, and that means that it can infer the type of the variable by the value we assign to it. So we can delete this type here, and our code is gonna still be valid. And if I hover over here, if you look at here, it's still treating this variable as type of string. So, but in this video, I'm gonna leave the string type. I'm gonna delete this because we're gonna look at the integer more closely. And here, let's change this value. Let's change its name to number, and it's also gonna be an int. And let's take a deeper look. First, let's see what is an integer. We know that it's a whole number, so you can store whole numbers. But what is it has a range. You can put whatever value you want. Actually, there is a range. There is a minimum and maximum value that we can put in an integer data type. So, and to get that minimum and maximum value, we type. I'm gonna put a space here to make the code more clear. I'm gonna type val, and I'm gonna type max integer value, and for the type I'm gonna choose int, or you can let it infer the type. You can, I'm gonna actually put the type here, but you can let it infer the type if you want. Equals, and now we type int dot, and IntelliJ is giving us some suggestions here. I'm gonna choose max value. And this code on the right here is gonna give us, actually the entire code is gonna give us the maximum value in a integer. And if you don't, if this seems confusing, int, that, and this uppercase, you know, you don't need to worry about that for now. You just need to know that in this way you can get the maximum value to be outputted in our console. And for the minimum value, we're gonna type val min integer value. For the type, I'm gonna choose int. Now I'm gonna type again int that, and again I'm gonna choose from here min value. Now to print these two values, I'm gonna just delete this text here, and I'm gonna type int integer or int maximum value is, and I'm gonna put $sign to get the value max integer value, right? And below this code, we're gonna type another println, and here we're gonna put a pair of quotation marks again, and we're gonna type int minimum value is $sign. Again, IntelliJ is giving us suggestions. We're gonna choose minimum integer value. Now let's print this. Let's output this code to see what is the minimum or maximum value which can be stored in an integer data type. And if you want, you can add a space here to make things more clear. Alright, and as you can see down here when the console opened, that the maximum value is 2,147,000,000 and so on, and the minimum value is 2,147,000,000 and so on, and these are the minimum and maximum values which can be stored in an int. So that means that you cannot put a value which is bigger than this maximum value, or the value which is bigger than the minimum values. And so if you try to assign, and to confirm that, if you try to assign here a value which is bigger than the maximum integer value, so let's type number, and now we maybe spotted the problem here. If I try to put here equals, it says val cannot be reassigned. So let's declare this as a var, because I want to change this value now. I'm gonna put equals, and I'm just gonna copy this. I'm gonna put it here. Now if I increase this number by 1, let's say that I put 8 here, now it immediately shows an warning. And if I hover over here, it says that the integer literal does not conform to the expected type int. And you may be wondering how this makes any sense, because up here we said explicitly that this variable is going to store integers or whole numbers, and down here we have a whole number, but the problem now is that this whole number is bigger than the maximum integer value which can be stored in an int, which is 2,147,048,3,647. But now we have a bigger number, and to store this number, we need to use a different data type or a different type, and we're gonna see in the next videos precisely what type we need to use and what type we gonna use for storing a bigger number than the integer maximum value. All right. Also, it's important to know, because it says here now the integer literal. So you may be wondering, what is this literal? The literal is the value that we assign to our variable, and it's called the literal because we assign the value directly here. So you don't have a what is called a symbolic name here, and we're gonna see what is a symbolic name in the next videos. Now I'm gonna edit this video now. I'm gonna change it back to 7. And also you can delete the types here. The code is gonna still work. The code is gonna still be valid. And if you delete the type up here also, because the type can be inferred, like we've talked about. Now, I'm gonna end this video now and see you in the next video. Alright, so in the last video we looked at the integer data type, and we saw there that you can store a minimum and a maximum value in an integer. And in this video we're gonna look at the next 3 data types or types for storing whole numbers, and those are the byte, the short, and the long. And let's start with the byte to see what is the minimum and maximum value which can be stored in a byte. So I'm gonna type val my max byte value. For the type I'm gonna choose byte equals byte dot max value. Below I'm gonna type again val. This time I'm gonna call it my min byte value. For the type I'm gonna choose byte. I'm gonna put equals. I'm gonna type byte dot min value. And now to print this, to print the value of those variables, I'm gonna copy this to println statements. I'm gonna paste it below here. I'm gonna change the text to byte. And here we need to call our variables. We need to refer our variables. So I'm gonna type my max byte value. Just press enter to fill that for you. And below here I'm gonna type my min byte value. Now let's print these 2 values to the console to see what is the minimum and maximum value which can be stored in a byte data type. So I'm gonna run this code. Now the console should open in a short moment. Alright, as you can see, the byte maximum value is 127 and the byte minimum value is minus 128. And in contrast with those minimum and maximum values for the integer type, you can see that these two are very, very small compared to that. Now let's look at the next type, which is the short, and I'm gonna do the same. I'm gonna type the same code as the same code that you had previously, but so I'm gonna put a space to make it more clear. I'm gonna close the console. So let's see the short type, right? So I'm gonna type val my max short value. I'm gonna put equals. Actually, let's choose short here for the type. Equals short dot max value. All right. I'm gonna press enter. I'm gonna type again val my min short value, and for the type again short equals short dot min value. Now let's copy this. Actually we have already copied that, so I'm gonna paste that here to print our minimum and maximum values. So I'm gonna change this to short, this text. I'm gonna change it here too. And now we need to call those variables, because as you can see right now they are gray out, and if you hover over, it says the variable my max short value is never used, and that's a clever way to see when a variable is used or not. Alright, let's change it. Let's change the name here because we want to refer those variables. My max short value, and here we're gonna type my min short value. Right? Let's print this to see now what is the minimum and maximum value can be stored in a short. Alright, as you can see down here, it outputted that the short maximum value is minus 32,767, and for the short minimum value is minus 32,768. Alright, and if you look at the previous data types, you can see that the integer is the biggest, is the type which can store the biggest number, but there is one actually which is bigger than the integer. So I'm gonna type now the next data type which you're gonna look at, and that is the long, which is much bigger than the integer. So I'm gonna close the console. I'm gonna type the same code. I'm gonna type val my max long value. For the type, I'm gonna choose long. We're gonna put equals long. I'm gonna put dot max value. Again, val my min long value. For the type, I'm gonna choose long. Equals again. I'm gonna choose. Now I'm gonna type again long. Dot minimum value. Now I'm gonna paste that code below here to output our variables, to output the minimum and maximum value which can be stored in a long data type. So I'm gonna change this to long. I'm gonna change this text also to long. Now I need to refer those two variables up here from up here. So I'm gonna delete this. I'm gonna type my max long value. So I'm gonna choose that, press enter, and here I'm gonna choose I'm gonna type my min long value. Let's output this code to see. Let's run actually our code to see what is the minimum and maximum value can be stored in a long data type. And as you can see, the range for the long is much bigger. Contrast that with the integer data type. You can see that it's a lot bigger, this number. So the long has a more has a range which is much bigger than the integer. And I'm gonna end this video now, and in the next video we're gonna look at how we can use those types and what are the relationships between them, right? So I'm gonna end this video now and see you in the next. Alright, now it's time to use those for data types for storing whole numbers in our code. So I'm gonna type some code below of those println statements. I'm gonna type val, because I want this variable to be immutable. I don't want to change this value later. I'm gonna call it my number. It should be in camel case like our last names. And for the type, I'm not define explicitly a type here. I'm gonna put equals, and I'm gonna put the literal value 28. And if I hover over my number, you can see that the type which was inferred is an int. Now you might be wondering how this makes any sense, because this 28 can easily fit in a byte or in a short or in a long. And that is because the default data type which is automatically inferred is the integer. So actually let's confirm that this can fit easily in other data types by running our code to see what are the minimum. And you can see that that number can easily fit in any of those data types from this list. And that is not happening because automatically, as I said, the default type which is inferred is the integer. And if you want this type to be a byte, you need to explicitly say here byte. Now if I hover over here, you can see that now it's a byte. And if I want to be a short, we need to type explicitly here short. So if I hover over here, now this is a short. And if I want this to be a long, I just type again here long. And for the long there are two ways. This is the first way to type the type explicitly here. Sorry, hover over here. It's a long. Or we can put a L suffix at the end of our number. But if I put a lowercase letter, it immediately shows this warning which says use an uppercase L instead of L, and that is because this can easily be confused with 1. So I'm gonna put an uppercase L, and if I hover over here, now this is a long, even though this can easily fit in any other data type. And if I delete this cell, and if I exceed the maximum value which can be stored in an integer, let's say that I put 28 or something here, and if I hover over here, you can see that now it inferred the type to be as a long, because now this number that we have here exceeds the maximum value which can be stored in an int. And you may be wondering now when to use one or the other, when to use the byte, when to use the short, when to use the long. And you will find the answer with the practice, with the working with them. But if I run this code, the byte and the short will be used in very specific cases, and most of the time you'll be working with the integer data type, right? Now I'm gonna end this video and see you in the next video. We're gonna talk about the next data types, which are the floating data types, and those are types which can hold numbers which have a fractional part or decimals. So see you in the next video. Alright, before we start our discussion about the floating point numbers, respectively about the float and double data type, it's important to know what are the difference between the data types for storing whole numbers under the hood, because we know now that there is a minimum maximum value which can be stored in those data types, and also we need to know what amount of space they occupy under the hood. And let's start with a byte. And a byte occupy 8 bits, right? So a byte occupy bits, and we say that a byte has a width of 8, and a short can store a large range of numbers and occupy 16 bits and has a width of 16. An int has a much larger range, as you know, and occupies 32 bits and has a width of 32. The point here that each data type occupies a different amount of memory. We can see that an int needs 4 times the amount of space than a byte does, for example. It's not particularly relevant to you to know these numbers, but it comes up as an interview question, and it's useful to know that a certain type takes up more space than others. Alright, now let's close our project, because I'm going to create a new project. Now I'm going to click here on new project, because we have our previous project here. Alright. On the left hand side, again, Kotlin should be selected. For the name, I'm gonna call it, it should be in Pascal case, float and double. Alright, here is select for the build system IntelliJ, and for the project JDK, select the JDK there. I'm gonna click on next, and I'm gonna click on finish. Now our project is gonna be created. Right, let's delete this code. We can keep the args and the array string here. I'm gonna keep it to see that there is no, is not making any difference in our code. I'm gonna delete the print ln statement, and I'm gonna expand this to the left because we don't really need the project pane. Actually, I'm gonna expand it full. It's not working full. I'm gonna then click here to hide the project pane. Alright. Floating point numbers are used for storing numbers which have a fractional part, which have decimals. So floating point numbers are used when you need more precision in your calculations, and as you'll see in the next video, this has a practicality. Now, to declare a floating point number, just type val, because I want this variable to be immutable. I'm gonna call it my number. Again, should be in camel case now. First letter, first word should start with a lowercase letter, and the following words should start with capital letters. And for the type, I'm gonna choose. Let's actually not choose any type. Let's just put equals and try here to assign a value. Let's put 2.5. Okay. Now, if you hover over here, and if you look at what type this value has, what type this variable has, you can see that the type which was inferred is the double. So if we want to change the type, we can put here float. Let's say to be a float. But look what happens when we do this. It says that the floating point literal does not conform to the safety type float, and that is because, like in our example with the integer, the type which is inferred, which is automatically assumed by Kotlin, is double in this case. So even though we said here explicitly that we're gonna store a float, because it typed here a literal value, it considers this to be a double. So to solve this, you need to delete this from here and put here at the end of our number an F. Now, if I hover over here, now the variable has the type float. So this is how you declare a float variable. You need to put a F at the end of the number, a suffix. And for declaring a double, you can just type val. Let's call it my second number equals, and if I put 2.5 here, 2.5. Now if I hover over here, like I said previously, it automatically inferred the type to be a double. So if you don't specify a type, the automatically inferred type will be a double, because this is the type which is inferred for the floating point numbers. And this is similar to the integer type, because there we've seen that the type which is automatically inferred is an int. So here we have the same thing. So this is how we can declare a floating point number, and this is how we can declare a double. Now, what is the difference between this? They differ in the precision in which they have, and we'll see in the next example, in the next video, when we're going to be talking about operators and operations, what is the precision of a float and what is the precision of a double. And float comes from a floating precision number, and double comes from double precision number. And as the name implies, the double data type has more precision in our calculation. And you're gonna see an example of this in the next video, because we need to first learn about operators and operations before we introduce any kind of operator here, even though we've already used an operator, which is the assignment operator, which is this operator here. But we're going to talk about this in the next video. So I'm going to end this video now, and see you in the next video. We're going to start our discussion about operators, and also in that video we're going to see that the float has a smaller precision than the double, and the double is assumed to be the default type because has a bigger precision. So I'm gonna end this video now. See you in the next video. But before we end our video, actually let's print let's output those values in our console. Let's output the values of the variables in our console. So I'm going to type println statement below of our code, below the declaration of our variables, and inside the parentheses I'm going to put a double pair of quotation marks. I'm going to type my number equals $sign to get the value, the content of my number, and my second number we put equals again $sign, not here, my second number. Now let's print those values in our console. And as you can see, output is 2.5 and 2.5. But if I hover over here, you can see that the type because it's explicitly given here, is the float. And if I hover over here, this is the double. But let's see what happens if I delete the fractional part and I just actually you can put a lowercase f here or an uppercase f, like this. If you run this code again, you'll have the same output. Again, now let's delete the fractional part and just let an f there, and here let's also delete the fractional part, and let's run our code, and you may know what is going to happen now. It printed 2.0 for my number because we said explicitly here that this is a float, so it prints the fractional part. But in the case of my number, it only outputted 2 because now this is inferred, if you hover over here, as an int. So one solution to this may be to type here double and try to see what happens. And if I hover over here, it says the integer literal does not conform to the expected type double, and it's correct because this is assumed to be an int. So you cannot even though we said explicitly here that this is gonna store doubles, here we put an int, an integer value. So if I delete the type here, let's say if I try to put a d here, actually there is no d for the double. There is no, like in the case of the float, even if I try to put a uppercase d, there is no way to add a suffix to our variable. The only way is to put directly here 2.0, and now this is inferred as a double, as you can see here. And if I run this, now it outputted 2.0 and 2.0 in both of our variables. Alright, I'm gonna end this video now, and see you in the next video. Alright, so far in our course we've only dealt with data types which can store numbers, but there are two different data types which we're gonna look at in this video, which you can use for storing a different type of data, and we're gonna see what kind of data you can store. But those data types are called the char data type and the boolean data type. But first, let's create our project. Let's create a new project. I'm gonna give it a name. I'm gonna call it char and boolean. Again, it should be in Pascal case. Make sure for the build system that you select IntelliJ, and make sure that you have the project JDK selected. So I'm gonna click on next to create our project. I'm gonna click on finish. Now our project is going to be created. On the left hand side you have the project pane. You have our code auto-generated for us, even though this code we're gonna delete this code which is inside the curly braces because you don't need this code. So I'm gonna delete this code, and let's also hide the project pane because you don't need the project pane. And let's see how we can declare a char data type, and after that we're gonna talk about where you can use the char data type in a specific case and what specific cases you can use. So I'm gonna type val because I want this variable to be immutable. I don't want to change its value later. I'm gonna call it my char value. Again, it should be in camel case. And for the type, I'm gonna put colon. I'm gonna choose char. Press enter. Let's put equals, and let's now assign a value to this variable. So this time I'm gonna type a single pair of quotation marks, not a double pair of quotation marks like we did in our string data type. And in a char data type, we can store only a single symbol, and that symbol can be a letter, a number, or an exclamation point or mark. So I'm gonna put here a D, a single letter D. And you may be wondering now, what is this? What is a specific case where you can use a char value? A specific case can be, let's say, if you want to store the last key pressed by a user. So this is a specific case where you can use the char data type. Now let's print this value in our console to see that it should be in lowercase letters. Print ln, and you can print it by the usual way where you put here a double pair of quotation marks and we type a $, and here we type the name of our variable, my char value. Press enter. I messed up the code. Let's delete this. Now if I run this, the console will start in a short moment, and you're gonna see the output of the letter D. Right, so the console opened, and now we have outputted down here the letter D. So this is the usual way of referring a variable. But you can refer the variable even like this, by not putting the $, deleted the $, and also the quotation mark at the beginning. Now if I run this, it's gonna still output the letter D. So we see that we have now also the letter D. So this is another way of printing the value in a variable, but this is not really the usual way to do it. Now let's take a look at the next data type, and that is the Boolean data type. And to declare a Boolean data type, we type again val, because again I want this to be immutable, and I'm gonna call it my, in camel case it should be Boolean value, and for the type choose Boolean. And a Boolean data type can only store a true or a false value. So you can only assign here true or false. So if you type now let's print those values, but this time I'm gonna put the parentheses, and I'm gonna put the quotation marks. I'm gonna type my char, my char value equals $, my char value, and my, let's type the name here, Boolean value equals, and let's put here the $, my Boolean value. Now if you run this code, now you can see that my char value, which is this text here, has this value, which is the content of this variable that we're referring here, and my Boolean value, which is our variable, the name of our variable, has the content of false, so it printed here false. Now Boolean data types, the Boolean data types are going to be used in our code a lot, because the Boolean data types can be used for controlling the flow of the program. So you can you're gonna see that in combination with the if statement, at which you're gonna look at in the next video, and the next videos. You can actually control the flow of the program, because usually the flow of the program is from top to bottom, and with the Boolean data type and with an if statement, as you'll see, you can control what parts of the code are compiled or not, based on a certain condition, if that condition is false or if that condition is true. So Boolean data types are going to be used, as you'll see, a lot in our code and in your coding career, as you'll see. So these are the two data types that can be used for storing either a single character or a character, and this is the data type which can be used for storing true or false, which is called the Boolean data type. Also, you may saw already here that you can delete the types here, because as we talked about, Kotlin has what is called the type inference. So can infer the type by looking at what value assigned to it. So in this case, it knows that this is a type of char. So here you can see that the type is a Boolean. Alright, but before we end our video, let's do a little recap about the 8 data types that we looked at throughout these videos. And the 8 data types are the byte, short, int, and long. Those are for storing the whole numbers. And the next 2 data types are the float and double, for storing floating point numbers, or numbers which have a fractional part, decimals. And the next 2 ones are the ones that we looked at in this video, and those are the char and the Boolean. And those data types are also called primitive data types, because it has to do with, they are called like that because it has to do with how they are stored in memory. And a string data type is not really a primitive data type, because it's stored a little differently. Also, as you're gonna see, the string data type has special language support. So you can consider these 8 primitive data types as the building blocks for data manipulation. And in the next video, I'm gonna look at this data manipulation, but by looking specifically at what operations we can do with those data types, because throughout this video we only looked at how we can store values and how we can output those values, but in a real app you'll need to manipulate that data to add or to subtract something, and we're gonna look at all of this in the next video. See you next. Alright, so far in our videos we only looked at how we can store different values in our variables, how to output them to the console, but in a real app you'll need to do some mathematical calculations. So in this video I'm gonna learn about that. We're gonna look at operators. So first, let's create a new project. I'm gonna click on new project. I'm gonna speed up the process now a little bit, because we did this already a few times. So I'm gonna call it operators. I'm gonna select IntelliJ, click on next, and click on finish. Now a project is gonna be created in a short moment. Again, on the left hand side we have the project pane, and we have the main function and the code auto-generated for us. Now we're gonna delete the code inside the curly braces, of main function, because we don't need this code. And also I'm gonna hide the project pane, because I don't need the project pane. And first, let's declare 2 variables. I'm gonna declare the first variable as a var, because I want to reassign its value later. I'm gonna call it let's say x. And in a real app you should use more descriptive names, because the name of the variable should say what the variable is doing. Anyway, I'm gonna put equals, I'm gonna assign a value of 5, and the next variable I'm gonna declare it as a val, because I don't want to change its value later. I'm gonna call it I. I'm gonna put a value of 3 here. And next, I'm gonna declare another variable. This is gonna be also a val. I'm gonna call it result. And we're gonna store the sum of 5 and 3 here. And to do that, we type here x, and this is the first operator that we're gonna look at, and that is the add or the plus operator. So I'm gonna put here x plus I. Now let's print this result. I'm gonna type println. I'm gonna put double pair of quotation marks. I'm gonna type result, the text equals $sign to get the value of the variable here. I'm gonna press enter to fill that suggestion for me. And now let's run this code to see what is gonna output. You're gonna see the output 8 here because 5 plus 3 is 8. The console should open in a short moment. Right, so it outputted the result equals to 8 because 5 plus 3 is 8. Now, what we have differently here, and we didn't have previously, is that now we're using the variables here, and we're not using literals like we have here 5 and 3 typed directly. And it's important to clarify some names here. And first is the name operand. An operand is any object which is affected by an operator. In our case, the operands are x and I because those variables are affected by the operator plus, because it sums their values and then it puts these values in the variable result. So those two variables x and I are called operand. Also, if you had here literal values, if we put it here, let's say 5 and 3 directly, these two are also called operands. So literals or variables are called operands. Any object which is affected by an operator is called an operand. Because you're gonna see also 8 here. But let's change this back to I and x. And there is another way to output the value of x plus I by using a placeholder, what is called a placeholder. And to do that, let's first delete this line of code. And this now is red because we don't have the variable declared. I'm gonna delete what is inside the quotation marks, and I'm gonna type here x plus I, the text equals, and now I'm gonna put here $sign, and I'm gonna put curly braces, and inside the curly braces I'm gonna type, let's click here to make it clear, x plus I. So this is called a placeholder, and we can use this, and in a placeholder we can only put expressions, and an expression is a construct which evaluates to a single value. So in our case, x plus I evaluates to a single value because it returns the value 8. So this is why we can put here x plus I. And even though if you put something which will not be an expression here, IntelliJ is gonna warn you, and I'm gonna see in the following minutes an example of that. Now let's output this, and you're gonna see the same result, but now we have the different text here. We're gonna have x plus I. So now I have x plus I equals 8, which is the correct result. Now let's copy this 4 times, and to make that easier, we can press Ctrl D or Command D on Mac. So I'm gonna press Ctrl D 4 times. Now let's change this to minus because we're gonna look at the subtraction. Now here we're gonna look at the multiplication operator, which is an asterisk operator. So I need to put here inside the curly braces the asterisk because this is where the expression is evaluated. And the next is the division. So you're gonna put here a forward slash. So I'm gonna put here also forward slash, right? And you know this operators for a Masterclass, this one, but one that is not so well known outside the programming is it's called the modulus operator. And the modulus operator is the operator which gives us the remainder of a division. So the modulus operator is a percent sign. So put percent sign here and percent sign here. Right? Now, if you run this code, alright, so now we have the output down here, and we have x plus I is 8 because 5 plus 3 is 8, x minus y is 2 because 5 minus 3 is 2, x times y is 15 because 5 times 3 is 15, x divided by y, and this is interesting, is 1, but because those variables are of type int, they're inferred automatically to be of type int, it dropped completely the fractional part here. So you don't have here 1.6 or something, you have only the integer part, which is 1. And here we have the modulus operator, and this gives us a remainder of 5 divided by 3, which is 1, and has a remainder of 2. Now, if you want to have here the fractional part, you need to declare one of the variable as a type, as a floating point number, and that can be or either a float or a double. So I'm gonna declare the I variable as a double, so I'm gonna put 3.0 here, and now all the variables, all the results here are gonna be of type double. So if you run this, you're gonna see the fractional part for all the variables here. Now you can see now we have 8.0, 2.0, 15.0, and here we have 1.66666 and 7. Now it shows also the fractional part, and for the remainder we've also have the fractional part here. So now the type of the, if you want, the type of the expression is a double, because we declare here as a double this variable I as a double, and the next one is widen automatically. You don't need to declare also the x as a double. It will be if you want, widen automatically by the fact that we declare the I variable as a double. Alright, and let's continue. And often in programming you'll want to increase a variable by a certain number, and to do that, let's first let's declare again the variable result down here. Let's declare it as a var because I want to reassign it. Let's call it result, and let's put again x plus I here. Now, if you want to increase, let's say, the value of this variable by 2, we can type something like result equals result. Let's say that I want to increase this variable by 2. I'm gonna put result equals result plus 2. And this equals operator is different from a mathematical equals, because this equals operator is not saying that result equals result plus 2, because it's incorrect. What this equals operator is, it's also called this an assignment operator, and what it's doing is that it assigns, first it adds 2 to our variable result, and then it stores that result of that expression in our variable result. All right, so let's print this value to see what we have here. So if I print this, you should see 10 here. Print ln, not print. And I'm gonna put here result equals $, result. And if you run this code, you're gonna see 10. Right, so you have 10, but let's delete the fractional part here to have the type of the variable as integers. So let's run this code again. So now we have 10 here, result equals 10. And let's copy this code again 4 times. Let's add a space. So now I messed up the code, and if you mess up the code like I did here, you can undo this thing by going to edit and click on undo paste, or the shortcut is Control Z, and you'll see the corresponding shortcut in a Mac here on the right. So please press here, and now our code is restored here, as you can see. So let's copy this again. Let's press enter, and let's paste this down. So 1, 2, 3, 4. Alright, now let's change this one to minus. Let's change this to multiplication, which is the asterisk operator. Let's change this to division, which is the /. And let's change this to modulus, which is the percentage sign. Now, if you run this code, let's run it from the top right hand side now. What you're gonna see is that first we have 10, because now the result has a value of 8, because x plus I is 5 plus 3, we have 8. And now here we're adding 2 to our result, and then we print that value in that variable in our console, and that is gonna output 10. The next we decrement that variable by 2, and we have 8. Next we multiply that variable by 2, so we have 8 times 2, which is 16, which is the result here. Next we have a result divided by 2, and 16 divided by 2 is 8, so we have 8 here. Now we have result modulus 2, and 8 modulus 2 is 0, because 8 divided by 2 has no remainder, right? Next, you can see that we have all of those underlines here, and if you hover over one of them, it's gonna say replaceable with operator assignment. So there is a shorter way to write the same thing that we have here, or there is an abbreviation to write the same thing that we have here and here and here and here, because they are so often used in programming. There is a abbreviation for all of them. So let's click on replace with plus and equals, replace with minus and equals, replace with multiplication and equals, with division and equals, and with modulus and equals here. Alright, so this is the abbreviation of what we had previously, of a shorter way to write the same thing. So if you run this code now, you're gonna see that it's gonna output the exact values that we had previously. So we have 10, 8, 16, 8 again, and 0. So this is a shorter way of abbreviating, or actually this is a way of abbreviating what we had previously, because as I said, they are very, very often used in programming. Alright, now another important thing to know is operator precedence. So first let's type again a println statement, and I'm gonna put a double pair of quotation marks, and inside the quotation marks I'm gonna put the text 3. So this is the text 3 plus 3 times, let's say 4. Now also inside the quotation marks, let's put a dollar, let's put equals here, the text, and let's put a $sign here, and now let's put curly braces, and inside the curly braces I'm gonna put 3 plus 3 times 4. Let's click here to make it clear, times 4. Now if you run this code, now you see that it outputted 15 because multiplication has precedence over addition. So it first multiplies 3 times 4, which is 12, and then it adds 3 to our result. So we have 15. But like in a math class, you can control which expression is evaluated first by putting parentheses. So if I put parentheses here, now this will be evaluated first, 3 plus 3, and then it will multiply the result by 4. So if you run this code, you're gonna see 3 plus 3 is 6 times 4 is 24. So you're gonna see 24 here now. So you can see that operators have precedence, but you can control that precedence using parentheses like you did here. So multiplication and division have precedence over addition and subtraction. Alright, there are 2 other operators which can be used for increasing or decreasing the value of a variable exactly by 1. And let's look at this operator. But first, let's use our variable x that we declare above, and let's assign a value of 0 to it. And to use the increment and decrement operator, this is how they are called, let's use the println statement first to let's put a double pair of quotation marks here, and let's type x equals, and let's put $sign, and let's type here x, and to use the increment operator we type plus plus, right? And what this is gonna do is gonna increment the value of our variable, which now is 0, by 1. And there is another way to increment the value of our variable by putting the increment operator or the plus plus operator in front of our variable, not at the end of our variable. So we can type again println down here. Let's put quotation marks, and I'm gonna put x equals, and now I'm gonna put $sign plus plus x. But this now is not working because $sign only works if you refer a variable. So to solve that, we're gonna put this in parentheses, actually in curly braces. So let's put this in curly braces, and let's put the above one also in curly braces. Not here. All right, and both of these increment the value of x by 1. They differ in what value they return. So the first returns the value of x, which is 0, and then it increments it. And the next increment operator, which is before the name of before the variable, it increments the variable and then return its value. So what you're gonna see if you output this code is gonna be interesting. So if you output this code, let's bring it down, you're gonna see 0 and 2, and you may be wondering how this makes any sense, because you have incremented the value here. And this happens because this first returns the value of x, so it returns the value of x, and then it prints the value of x, which is 0, and then it increments. So now the x has the value of 1. When the next println statement is executed, now the variable x it's incremented by 1, so it has a value of 1. And now it will be incremented again, but it will also be returned, not like in the previous increment operator, which is at the end. So now it will have the value of 2, okay? And there is the same operator is available for decrementing. So if I want to decrement a variable exactly by 1, I can put here x, let's put equals, let's put curly braces, actually the $sign, curly braces, and you can put x minus minus, and let's call the println function again. I'm gonna put x equals $sign again, curly braces, and let's put now the decrement operator, which is the minus minus, in front of our variable. Now you're gonna see something similar, but in the inverse way. So now we have 2 and 0, and let's explain this also. So again, this println statement is executed. Now the x has the value 2, and it returns 2, and then it decrements. So it prints the value of 2, and then it decrements the value of our variable x by 1. So now we have 1. When the next println statement is executed or function is called, now the value is 1, so and it first decrements the value, and then it returns the value of the variable. So now we have 0 because it was decremented. This is why you have 0 and 2 and 2 and 0 here. Alright? So you see above here that I declare the variable as a var, so I can reassign its value down here to 0. Right, this is our discussion about operators. There are more operators, but in order to talk about the next operators, we need to first talk about an if statement. So now it's time to look at comments, and comments are notes that you can add to your code, and they are ignored by the compiler. And usually they are used when you want to add some description about the code. So what you want to indicate what the code is doing, because you may wrote some code and you come to that code a few weeks later and forgot what it's doing. And by putting comments, you can see specifically what that code is doing. And in Kotlin we have two types of comments. The first is so-called end of line comment, and to add an end of line comment we put 2 slashes, and here we put our comment. Let's say here we are doing operations. So this is an end of line comment, and this is a text which simply says here we are doing operations. And this is, as I said, an end of line comment. The next comment that you can use is so-called the block comment. And to use a block comment, we put slash asterisk, and now you can press enter, or you can put asterisk and slash to add the next to close this comment, and you press enter, and as you can see it added automatically this asterisk and slash, or you can type this yourself. And here you can put some text, which can be some it can be something which is going to say what the code is doing. So those are the two types of comments that you can use in Kotlin: the end of line comment and the block comment. And you can also use comments to disable some code. So if I put 2 slashes here, now that line of code is going to be ignored by the compiler. So this is our discussion about comments. See you in the next video. Alright, before we continue discussion about operators, let's first introduce the if then else statement. And let's first start talking about how usually our code is executed. And usually our code is executed from top to bottom, and that means that our code is executed line by line, and that is the flow of the program. But with an if then else statement, you can break the flow of the program by imposing a condition, and you can say to the computer to execute a particular section of code only if a condition is true. So let's see how we can do that. So let's first declare a variable. I'm gonna type val. This is gonna be immutable. Not gonna reassign its value. I'm gonna call it its active, and I'm gonna put equals, and I'm gonna assign a value of true to it. So it's gonna be of type boolean. On the next line, I'm gonna type the if keyword, and now IntelliJ is giving us some hints here. I'm gonna press enter, and inside the parentheses we put our condition. So here I'm gonna type is active, the variable, and now I'm gonna type equals equals. Notice that here now we have two equals, and here we type true. Next, we put a left curly brace, and now we can add the right curly brace, or you can press enter, and the right curly brace is gonna be added automatically by IntelliJ for you. So if I press enter now, you can see that on the line 40, the right curly brace was added automatically. Now, let's type here a println statement. So I'm gonna type println, press enter, and quotation marks, and here we're gonna type the text, the user is active, right? And if you run this code, let's see what happens. And we get the output, the user is active, which is the text that we typed here. And let's first talk about what we have here. And the if statement checks to see, as I said, to see if this condition inside the parentheses is true, if this expression returns true. And it does that by checking to see if the operands are identical or if they are the same. So it checks to see if the content of the variable it's active, which is true, it's equal to true. And that sounds confusing, but it's true because our variable it's active has a value of true, and here we're checking to see if our if those two are equal or if they are the same, and that is true, and this expression returns true. And in effect, the code inside the curly braces is executed. But if I change this to false, so if I change this value and if I run this code now, this condition inside the parentheses is going to be false, and the code is not going to be executed. So you can see now that we don't see any output because this condition is false, and because the condition is false, the code inside the curly braces is not going to be executed. But if you want to cover the part where the condition is false, so if you want to execute some code even though the condition is false, you can type here else. And here you also need to put curly braces. So I'm going to put the left curly brace, I'm going to press enter, and the right curly brace was added automatically for me. Now I'm going to type println, and inside the parentheses I'm going to put the user is not active. So now what is going to happen is that this condition is going to fail, it's going to be false because the two operands are not equal, respectively is active and true. And it's going to be executed the else part in this case. It's going to be executed the code which is inside the curly braces of the else. So if you run this code, you're going to see the output, the user is not active. So as you can see, now it says the user is not active because this condition was false, this Boolean expression returns false, and it jumps to the else part. So this is how we can use the else part. Now, what we can also do is to add another if statement below our if statement to chain more if statements to check for more conditions. But to do that, we need to use another operator, which is called the greater than operator, which is an operator which you may know from your math class. And to do that, let's change first the variable. So I'm going to type here a value of 100 to make it an integer. And also I'm going to change its name. And to change the name of the variable, go right click on the variable, go to rename, to refactor, and go to rename. And now if you change the name of the variable, here is going to be change everywhere where the variable is called. So if I look what happens if I delete the name here, it's changed also on the line 38 where we're referring the variable. And now I'm going to call the variable my number, and I'm going to press enter. Now the name of the variable is updated. And now this condition is not correct. Here you need to put a greater than sign. So I'm going to put a greater than sign, and let's check for let's say if my number is greater than 150, and this is false now because my number has a value of 100, so this is going to evaluate to false, this condition, this expression. Now let's add here another if statement. So we're going to put here else if, and inside the parenthesis we're going to put the condition, and now I'm going to type again my number, my variable, our variable. Now here we're going to put let's say greater than 90. Now this condition is true, so let's add also the curly braces because we need to put our code inside there. Let's put here a println also. Let's type here greater than 90. And here let's also change the test to greater than 150. And here you can put all the conditions here you can put all the condition failed, because the else part is going to be executed only if all the condition that we have here, which is for that my number is greater than 150, and this is false, my number has a value of 100, and if our else if condition also evaluates to false, only then the else part is going to be executed. So let's run our code to see what if statement is going to be executed, what part. So you can see that we get greater than 90, and that means that this condition is true, because it's true that my number has a value of 100, and it checks to see if my number is greater than 90, which is true. So it executes the code which is inside the else if part, right? Now the next operator that you can use is greater than or equal to. So you can put here greater than or equal. Now what is gonna check to see is what is gonna check is to see if the number that we're comparing to, respectively my number, is greater than 100 or equal to greater than 150 or equal to 150. So let's change this to, let's say 149. So look what happens now. So now it's executed this part, the else if part, because this is greater, the number greater than 90. But if I put here greater, let's change the value of my number to 150 to see what happens. And now we get the output greater than 150. And this is correct because now this condition is true. My number is greater than equals to 150. And my number has the value of 150. It's not greater than 150, but it's greater than or equal to. So it's equal to 150. So now this condition is satisfied, and the code inside this curly brace is executed, which is greater than 150. All right. Now I'm gonna end this video, and in the next video we're going to continue our discussion about those operators. Right, so now let's continue our discussion about the next operators that you can use in Kotlin. And let's start with the less than operator. And to do that, let's first change the value of the variable my number to 100. And to use the less than operator, we put here a less than sign, which you probably know from your math class. Now, if you run this code, I should change here the text to make it consistent. Let's type here so now if you run this, now get the output less than 150, and this is true because the value of the variable my number is less than 150, so this condition now evaluates to true. The next operator that you can use is less than or equal to, similar to greater than or equal to operator. And to use the less than or equal to operator, we put here a less sign and the equal sign, right? And let's change the value here to 150 to make it clear. Now let's change also the value of the variable to 150, and let's also change the text here. Now if you run this code, you're gonna see the output less than or equal to 150, because now the else if part and the condition of the else if statement evaluates to true, because now the value of my number, it's not less than 150 because it's 150, but it's less than or equal to 150. So this condition evaluates to true. All right. The next operator that you can use is called the logical not equal operator, and that operator is used to check if two operands, respectively, if my number, let's say, and 150, are not the same. And let's see how we can do that. And to do that, to type here an exclamation mark and an equal sign. And this operator here, which is the 𝐥𝐞𝐬𝐭 mark, is gonna check to see if those two operands, respectively my number and 150, are not the same, and only then the condition is gonna evaluate to true. So let's run this code to see what happens. So now we get the output less than or equal to 150 because we still have the value 150, so it jumps to the else if part. But if I change this to, let's say, 100, now look what happens. Now it executes the if. Now this condition evaluates to true because now this operator is checking to see if the two operands, if the value of my number, the variable my number, is not equal to 150, and that is true, they're not equal, and this is why you get here the output. But let's change the output to make it clear. Let's type here they are not equal. So if you run this code, you're gonna see the output they are not equal because that condition now evaluates to true. So this is how you can use the logical not equal operator. Also, with the logical not operator, we can change the value of a Boolean expression from true to false and from false to true. In other words, we can negate its value. And to do that, let's first declare the code that we had previously. So I'm going to declare again the val variable it's active. I'm going to assign a value of true. I'm going to type the if statement again. I'm going to put the same condition, equals true. Here you can put the left curly brace and press enter, or you can add the right curly brace if you want, but it will be added automatically for you. I'm going to type else, also the left curly brace, press enter. I'm going to put the text that we had previously. Alright, now if you run this code, you're gonna see the output, the user is active, because this is gonna evaluate to true. They are equal, they're the same. Let's expand this. So you see the output, the user is active, because this condition evaluates to true. And before we look at the logical NOT operator and how we can negate the value, let's first see how we can write the same expression that we have here in a shorter way by abbreviating. So because you have noticed probably that we have an underline here, and if you hover over here, it says that the Boolean expression can be simplified. So let's click here, simplify Boolean expression, to see what happens. So now we get if it's active, and then print then execute the code inside the curly braces. So this thing now does the exact same thing that we did previously. So it checks to see if the value of its active is equal to true. So it's a shorter way of writing the same thing. And now you get the output, the user is active. But with the equal NOT operator, you can put the exclamation mark in front of our its active expression, and it's now it's gonna negate its value. Now it's gonna change its value from true to false. So now if you run this code, now you're gonna see the output, the user is not active, because now this logical NOT operator is switching its value to false. So now this will evaluate to false, and it's gonna execute the else part that we have here, the user is not active. And you can do the same for false. So if you put here false, now let's actually execute this without the logical NOT operator to see what happens. Now this will not execute, so it will execute the else part. So you see the user is not active. But if I put the logical NOT operator in front of its active, now it's gonna change its value from false to true, and now this will evaluate to true, and it will execute the code inside the curly brace of the if. So now you see that it says the user is active. So this is how you can use the logical NOT operator to flip a value from false to true or from true to false. And you can do this for every Boolean expression that you use. So you can put the logical NOT operator in front of this. Actually, not in front of this. You can put the logical NOT operator, generally speaking, in front of any Boolean expression, right? So this is our discussion about operators. So in the next video, we're gonna look how we can combine multiple expressions to create a bigger expression, which itself returns true or false value. See you in the next. Alright, so I deleted the code that we had previously. You can keep the code that we had previously if you want, but I deleted to make things more clear. And in this video, we're gonna look at how we can combine multiple expressions, which in themselves can return a Boolean value, which can be either true or false. And let's start with the first operator, which is called the logical AND operator. But let's first declare two variables. I'm gonna declare a val variable. I'm gonna call it it's playing. I'm gonna assign a value of true to it, so it's gonna be of type Boolean. And on the next line, I'm gonna declare another variable, also a val, and it's gonna be called score, and it's gonna have a value of 80. Now, down here we type if, and inside the parentheses we type is playing equals true. So this is the equals to operator. I didn't talk really a lot about the equals to operator, but the equals to operator checks to see if the two operands are the same. So it, in contrast to the one equal operator, the one equal operator assigns what's on the right to our variable which is on the left. So in this case, assign true to our variable is playing, so, or it's assigned 80 to our variable score. The two equals or the equals to operator is different because it checks to see if what you have on the left or what you have on the left and on the right are the same or are identical. Next, and we know from the previous video that we can abbreviate this. We can write this in a shorter way by putting just is playing. This is going to be equivalent to what we had previously, because as you can see it says that you can simplify the Boolean expression. And now gonna use the logical AND operator, and use the logical AND operator. We type two ampersand signs, and here we type score. Now we're gonna use again the equals operator. This time we need to use it. There is not a short way to check for and we type if score equals to 100, right? So this expression inside the parenthesis is gonna evaluate to true only if both expressions, respectively is playing and score equals to 100, evaluates to true. So only if those two conditions are true, only then the code inside the parentheses, inside the curly braces actually, is going to be executed. So let's say that in a real app here you can add the logic to open the next level, but here we're just going to output some text. So I'm going to type here next level opened, right? And also I'm gonna add the else part here, and here we're gonna put also println statement, and inside the parentheses we're gonna type still at the same level. Now if you run this code, you're gonna see the output still at the same level, because not those conditions are not both true. It's playing is true, but it's playing is equal to true, but our score is not equal to 100. So this is going to evaluate to false, and the entire expression inside the parenthesis is going to return false. So it's going to execute the else part. Now, if we change the value of our variable score to 100, now both expressions are true. It's playing equals to true, and score and the score is equal to 100. So now both of our expressions are true, and you're gonna see the text next level opened, and now you see that it output the next level opened. So this is the logical AND operator, and you're gonna be using the logical AND operator a lot in your code. Alright, so now it's time to continue our discussion about operators, and I'm gonna look at the next operator which can be used to combine multiple expression, and that is the logical OR operator. And the logical OR operator evaluates an expression or multiple expression, in this case to true, if one of the condition is true or if both conditions are true. So let's see an example of this, but first let's comment the code that we have here, because it will make things confusing. So go to code and select comment with line comment, or you can press the shortcut control /. Now let's declare two variables down here. The first is going to be a val. I'm going to call it num1. I'm going to assign a value of 5 to it. Second is going to be also a val. It's going to be called num2, and I'm going to assign a value of 3 to it, or 4. Now I'm going to type the if then else statement. I'm going to type the if keyword. Inside the parentheses I'm going to put the condition. First is if num1 is greater than 0. And now to use the logical OR operator, we type two vertical bars here. Now we put our next condition, or our next expression, and that if num2 is also greater than 0. And we put a curly brace. Press enter to add the right curly brace. And we put also the else part. And inside the curly braces of the if, let's print some text. Let's say the condition is true. Alright, now if you run this code, you're gonna see the output, the condition is true, because now both conditions are true, and the logical operator returns true if both conditions are true, or if one of the condition is true. So let's see if we change this to -3, and now our second condition, num2 greater than 0, is false. So now this is also going to evaluate to true, because the logical OR operator returns true if one of the conditions is true, or if both conditions are true. So now we get condition is true. But if you change this to also to -5, now our both conditions are false. Now you're gonna see that it's gonna be executed the else part, because this condition now is gonna be false, because both conditions, both expressions, num1 greater than 0 and num2 greater than 0 are false. Alright, so let's change it back to 5. Now if you run this code, you're gonna see the condition is true, because at least one of the condition is true, which is this one, num1 greater than 0, even though the num2 condition is false. Alright, and this is how you can use the logical OR operator. Alright, now it's time to see how you can use the if then else statement as an expression. And that means that the if then else statement can return a value which can be stored in a variable. So let's see how you can do that. But first, actually let's keep this code that we have here. And to use the if then else statement as an expression, we declare a variable first. So I'm going to declare a val, and let's give it a name. I'm going to call it let's say text. And to use the if then else statement as an expression, we put equals, and after the equals we put our if then else statement. Now we need to assign a value to our variable text to use it as an expression, and the value is going to be the last expression in the curly braces. So here if I type the text, let's say this is text 1, and down here if I type in quotation marks this is text 2. Now if I add a println here at the end, and if I print the value of the variable text that we declare above, let's put a $sign, and if I type text here, now you can see our variable, it says that it's of type string. So if I run this code now, you're gonna see first this println inside the curly braces, which says the condition is true, and after that you're gonna see this text being assigned to our variable text, and it will be outputted down here by the println statement. So you see this is text 2. Actually I was wrong, that condition is false, because here you have -5 and -3, and this condition value is to false. And the last expression in the curly braces is assigned as a value to our variable. Now what you can also do is to remove the curly braces, but it's recommended to not use the curly braces if you have only one statement in your if then else statement. So let's delete the println here, let's delete the curly brace here, let's also delete the curly brace here, let's delete the println statement here, and let's also delete the curly brace here. So now this will work the same, it will work like previously, but so now you'll see the same output without the condition, without this text. The condition is false because now we don't have the println statement. So now we get this is text 2, because this condition evaluates to false, and it assigns this value to our variable text, then down here it prints it. So also you see that this they are not aligned here, this our variable, and to format your code, just go to code and click reformat code, or press Ctrl-Alt-L on Windows, or you can use another shot. You can use the corresponding shortcut on Linux or Mac. So click on code, and now you're gonna see that our code is formatted. If you run this, now see this is text 2, but let's change this to 5. Now this condition will evaluate to true, and this expression is gonna be assigned to our variable text. So if we run this, you're gonna see this now our variable text is assigned the value of this is text 1, because this condition is true, and assign this value. To make things more clear, you can use you can type your code something like this. Now this does the exact same thing as previously. So if you run this code now, you're gonna see that now it says the same thing. This is text1. Now you may be wondering what type this variable is. So if you hover over it, it says that it is of type string. But look, what can I do? I can put here a number. So if this condition evaluates to false, this is going to be assigned to our variable test. So if I run this now, now I get this is text1, and let's put here -5 for the condition to be false. And if you run this code now, you're going to see 5. And you may be wondering how this makes any sense, because previously our variable was of type string. But if you hover over here, now it says val text, and the type is this thing, comparable anyway. But what is simply doing here is looking at the condition. It's looking first at the if statement, and if this condition is true, then it assigns our text to our variable, and then it infers the type to be a string, right? If this condition is false, then this part is skipped, and then it assigns this value of 5 to our variable text, and then our variable is going to be of type int. So there is no case in which both values going to be assigned to our variable. So this is why you can use here text and here an integer, even though. But if you declare explicitly here that this variable is going to store only strings, only sequence of characters or text, now here you get an warning, because it says the integer liter does not conform to the expected type stream. So in other words, we cannot put here a number, because we said that explicitly here that this is going to store only strings. But if you omit the type, that is going to work. So you can decide what, depending on the context, what to choose. So this way of writing the if then else statement in one single line like we have here, it's okay as long as we use the if then else statement as an expression, or in other words, if you're assigning a value to a variable, like in our case. But if you have multiple instruction in your also if you have a single instruction, you can also omit the curly braces. But most of the time it's recommended to use the curly braces, because that allows us to execute more than one instruction or a statement in your code, and it also makes the code more clear. So let's change this code from an expression to just an if then else statement to see why. So I'm gonna change this. I'm gonna add the curly braces. Let's format the code. Press Ctrl Alt L. Alright. And also let's change this. Let's delete this text. Let's add two println statements here. Alright. Now if you run this code, you're gonna see this part execute, the else part, because this condition is false. Both of our condition, respectively num1 is not greater than 0, and also num2 is also not greater than 0. So this is gonna return false, and it's gonna execute the else part. Right, but now if you change this to 5, and now one of the conditions is gonna be true, and as you know, this entire expression is gonna evaluate to true now, because at least one of the expression is true. So if you run this code, now you see this condition is true, and also we see our second println statement, this condition is true, and some text. But look what happens if I let's say if I delete the else part, right? And if I delete the curly braces here, alright? And now if I run this code, you see that now both statements are executed. But as I said, if you don't use curly braces, just only one of the statements is going to be executed. So why you have both of these? Because the first is executed as part of the if statement, because this condition is true, and the next one is executed because it's part of the code, because it's read from top to bottom. But if I change this to false, and now I want both statements, respectively with this one and this one, to not be executed, look what happens. Now get this condition is true and some text. So the first instruction in our if then statement is omitted because it's part of the if then statement, but the second one it's executed because it's part of the code, so it's going to be read anyway. So this is why you need to always use curly braces. In this way the entire code is going to be either executed or omitted. So this is our discussion about the if then else statement, and you should always use the curly braces, and for the else part you should use the curly braces, and only omit the curly braces if you have only one single statement or one single expression. If you want to use the if then else statement as an expression to assign a value to a variable. But if you have just one single statement, let's say you have something like this, you can omit the curly braces like this. So now you can see that everything works fine. So you can use it like this. If you have one single statement like we have here, you just print some text to our console, or if you use it as an expression, so if you store a value in a variable. So see you in the next video. Alright, now it's time to look at the next control flow statement that we can use in Kotlin besides the if then else statement, and that is the when statement or the when expression. But first let's create a new project. I'm going to call it control flow. It should be in Pascal case. Select IntelliJ, click on next and finish. Right, now let's delete the code inside the curly braces. Let's hide the project pane, and let's first declare a variable. It's going to be a val. It's going to be called alarm, and I'm going to assign a value of 12 to it. Now to declare a when statement, we type here when, we put parentheses, and inside the parentheses we put our argument. In this case it's our variable alarm. Next we put space and we put the curly braces. Press enter, and now we put the expression here. So here I'm gonna put the value, let's say 12. Now I'm gonna put a minus sign and a greater than sign, so we have this arrow, and here I'm gonna type print ln. This is the code that is gonna be executed, and I'm gonna type the time is $sign alarm. Let's press Ctrl D to duplicate this 2 times or 3 times. And let's change the last one to an else. Alright, let's change those values here to 7 and 14. Now let's run this code to see what to get in the output, and after that we're going to discuss our code. So get in the output the time is 12, and we get that because what the when statement is doing, it's using this argument that we passed here. In this case, is our variable called alarm, and it's comparing this the value of this argument with all the branches that we have here. Respectively, it's going to compare it with the expression that we have on the left, because on the left we have the expression. This arrow sign is saying execute this code on the right if this expression on the left is true. In this case, if our alarm equals 12, and it's true, we have a value of 12, so this branch is executed, and it executes the code on the right, which is the alarm is 12. But if I change this to 7 now, and if I run this code, now I'm gonna see the time is 7. And if I change this to, let's say, 13, and here we have no 13, the else part is gonna be executed, similar to our if then else statement. And we get the time is 13, so it was executed the else part now. And we can combine those expressions by putting a colon, and we can combine them and putting them on one single line. So I can put here colon, I can type here 7 and 14. Now I'm gonna delete those two. Now it will check to see if our alarm argument has the value either 12 or 7 or 14. So let's change it to 14 to see. So now if you run this code, you're gonna see that this will evaluate to true, and this code on the right is gonna be executed. So now again the time is 14, and if I change this to 7, again this will evaluate true because one of those expression is true. So again the time is 7. Alright, what you can do next is we can check to see if a number is in a certain range. So we can put another expression here, and here I can type in, and the in keyword is used to check to see if a number is in a certain range. And to declare a range, we type the range. Let's say that I want to check from let's say 1 from 1 to 10. We put 2 dots, dot 10. Now what this is gonna do is gonna check to see if our alarm argument, and in this case our alarm variable, is in the range from 1 to 10. Now I'm gonna put a minus sign and a greater than sign to have the arrow, and here I'm gonna type the code that I want to be executed. In this case it's just a println statement, and I'm gonna type the number is in the range 1.7. Now if you run this, let's run it from here, we get the time is 7 because the first branch is checked and this branch is true, and in effect it executes the code on the right, and the next branches are left off, are not executed. To change that, let's put this first. So let's copy this. Now if you run this code, now get the number is in range 1 to 10, and it's true, our 7 is in the range from 1 to 10. What you can do is also you can use the logical NOT operator. So I can put here the logical NOT operator, which is an exclamation mark, and this now will negate this value. So if you run this code now, you'll get the output 7. The time is 7. So now you get the output. The time is 7 because this switches this value from true to false and executes this part. Now let's delete this. what we can also do is that we can put curly braces. So I can put curly braces, press enter, the same here, and here also. And it's recommended to use the curly braces only if you have multiple statements in your code. In our case, we have one single statement, which is this println, which outputs some text to the console. And the when statement, as I said, can be used as an expression. So I can type here a val, let's say text, and I can assign the when expression to our text variable. Now we need to give back a value to our text. So instead of printing this text, I can delete this. Let's put it like this. Now the last expression in our block of code, which is now we have a single expression, but if we have multiple expressions, say that we have here another println, let's say some text. So similar to our if then else expression, the last line of code, the last expression, is going to be assigned to our variable text. Now let's print this down here to our console. So let's type println, and let's put directly here text. Now if you run this code, now you're gonna see the text, the number is in the range 1 to 10, because it checks to see if this expression on the left is true. Then it executes the code inside the curly braces, which is this expression. And because now we're using the when as an expression, it assigns this expression, this text, to our variable text. Then it outputs that value with the println down here in our console. So we get the number is in the range 1 to 10. All right. Now, but what if I want to put here a less than sign? So what if I want to put here if it's less than 7, our alarm argument? I can do that. The only way to do that is by, let's delete this now. Let's put 7, not here. Let's press Ctrl Alt L to format the code. All right. Now, the only way to put a greater than sign or a less than sign or a greater than equal or greater or a less than equal sign is to delete the argument here. But let's first delete the curly braces to make things more clear. So let's delete the curly braces. Let's delete this now because here we have 2 lines of code, so we need to use curly braces. This is why I deleted the println there. And again, you should always use curly braces if you have multiple lines of code. But in our case, we have a simple line of code, which is the text on the right, which is going to be assigned to our variable text, and it's going to be output in the console. So always use curly braces if you have multiple lines of code. All right. Now this is more concise and more clear. And let's say that I want to check to see if our alarm is less than, say, 10. To do that, we need to delete the argument here. All right. And now what can I do is I can put here our alarm variable, and here I can put less than or equal to 10. So now here we have a Boolean expression on the left. Sorry. So now I have a Boolean expression here on the left, and this will check to see if our alarm, our variable alarm has a value which is less than or equal to 10, which is true. We have a 7 here. So now if you run this code, but let's delete this because we need to have now Boolean expression here, because here we cannot, here we have just literal types. So here I need to put, let's say, if, let's type alarm equals 8 or 2 vertical bars alarm equals 7. So now if you run this code, now you get the output, the numbers in the range 1 to 10, because now this expression on the left is true, and it executes this text. It assigns this expression to our variable text, and it prints down here that value. So you get here the number is in the range 1 to 10. But this condition is also true. So if I swap those two, so if I put this one below, because as I said, if one of the expression evaluates to true, the next ones, the ones which are below, so this, in this case this one is true, are not gonna be executed, are skipped. It only executes this code, and the subsequent ones are omitted. So let's put this below. It's good to remember this. So now if you run this code, now get the time is 7, because now this evaluates true, even though this below is also true, because our alarm is less than 7, but because this evaluates to true, it executes the code which is on the right, which is assigning this expression to our text, and then it leaves the when expression. It's not going down to execute the next one. So it breaks right there, and it stops right there, and it's not executing the next branch. So this is our discussion about the when statement and the when expression. See you in the next video. Now it's time to start a discussion about nullability in Kotlin, but first I'm going to create a new project. I'm going to call it null. Make sure to have the language Kotlin selected, and for the build system IntelliJ, also make sure to have the JDK selected here, and I'm going to check this little box to generate the main function for us, and that code that comes with the main function. So I'm going to click on create to create a new project. Now our project is going to be created in a short moment. So we got our project created, and we got our main function auto-generated here for us because we checked that box. So I'm going to delete this because I don't need this code. And I'm going to hide the project pane. So what is a null value? A null value is basically when you assign to a variable nothing. Syntactically speaking, you assign null to it, but what that means is that you have a variable which has no value, which has no memory reference. And if you try to do some arithmetic operation with that variable, you will get in an impossible scenario where you have nothing trying to do some work, and that will throw a null pointer exception. And this is particularly bad because the null pointer exceptions are only thrown at runtime and not at compile time. So you could have your program working well and having no problems, and at some point you try to, I don't know, press a button, and somehow that pressing of the button is using that variable which has a null value, and then it's gonna throw a null pointer exception, and your app will crash. And Kotlin aims to avoid and to eliminate null pointer exceptions and null values. That is not to say that we can't have a null value in Kotlin, but it's very hard to have one. So let's see why. So what Kotlin has done to make null values and implicitly null pointer exceptions very hard to get, it first made all its types by default non-nullable, and that means that you cannot assign null to it. So if I declare here a variable called text, I'm going to declare the type explicitly, so it's going to be a string. And if I assign null, so to assign null to a variable, just type the null, and we have the null keyword. We can't, because this variable by default and all the variables by default are non-nullable, and that means that you cannot assign a value. So if you hover over this underline, it says null cannot be a value of a non-null type string. But what if I want to assign null to it? What if I want to have null for some reason? In that case, you go at the end of the type and you put question mark, and that means that now you have a nullable type. That means that you can assign null to this variable. So if I put question mark here, now I can assign null to this variable. So this is how we can assign null to a variable, by putting the question mark at the end of the type, because that is saying to the compiler, hey, I'm gonna let me to assign null to this variable, so to avoid that underline in red. Now if I try to print this, so if I put here print line and I put here text, what do you think we'll get in the output? In the output you get null, you don't get null pointer exception. So now if I hide this, and let's say that I want to get the length of let's say of the text. So let's say that I assign here some text, well, actually let's put a name here, name, and if I try to get the length here, so if I put here dot length, I have an underline which says only safe, and we have this question mark dot on non-null or asserted, and we have this this operator, calls are allowed on a nullable receiver of type string. So it's saying that we can only get, because this variable can have a null value, but we know that it doesn't. But the compiler is saying to us, because we said that this can have null, is saying to check first that this variable is not equal to null, and then try to get its length. And let's do that in the long way first. So let's delete this. So let's actually just copy this. And we type if, we put parentheses, if text not equal to null, then we're gonna output its then we're gonna get its length. So we're gonna type here text dot length. So now the compiler is happy, because it's ensured that it's not gonna have null, because we checked here especially that this variable should not have null in order to get the length. So now if I run this, I get 4. So this is the length. So we have 4 letters here, and I can also add the else part, which is gonna say the variable is null. So if the variable is null, the else part is gonna be called. So now if you run this, we'll get also 4, but I'm gonna reassign this variable, so I'm gonna change it to var first. So we put here var, and put here text equals null. So now our variable is null, and this check is gonna fail, and it's gonna execute the else part. So if I run this code, so we get the variable is null, because now on the third line we assign null to it. So this if fails, and is executed the else part. But as you can see, it's a lot of code just to check to check. And imagine if you have multiple variables to check, to always check for this that the variable is not null, then print its length. And there is a shorter way in Kotlin to do that, and we saw as a suggestion how to do that previously. So if I press Ctrl Z to undo our code, so if I still pressing, now if I hover over this error that we had previously, which says only safe call, so, and we have this operator, and this is called the safe call operator. And if I put here just a question mark, this is equivalent to having a if, which is checking to see if the length is null, and if the length is null, then it's gonna say null, and if it's not null, it's gonna just output 4. So now if I run this, so this is equivalent to the if the if statement that we had previously. So we have 4. So But if I assign null, so if I type here, let's change it to var first. So if I assign here text equals null, we'll simply get null. We get null. But what if I want to get that null pointer exception for whatever reason? What can I do? Also, the compiler is helping us also there. So because if I delete that safe call operator, which is just a question mark dot, and that is basically saying, hey, if this text is not null, then output in the console, then get the length and then output that in the console. If it's null, just say null. So this is how the safe call operator works. But if I delete this, as you can see, there is another operator, and is this operator, which is 2 exclamation marks. And this operator is basically saying, hey, if this variable has null, then throw that exception, but if it's not null, just output the length. So if I put 2 exclamation marks here, but for whatever reason it's not our text dot length is not getting the length, and I think this is because we assign to our text variable here null. It has a problem with inferring what type this variable is, even though here is saying that it's a string, so we should be able to call that length. And to avoid this, you just put null at when we declare the variable. So we assign here null. So we put here null. Now if you run this, because you have the 2 exclamation mark operator, now this will throw that null pointer exception that I talked about. So we get exception in thread main, so it doesn't matter what thread main is now. For now, you get java.lang the null pointer exception. So this is the null pointer exception. But if we assign down here this variable text equals some text, and now if we run this code, you get 9, because this is the length of this. So this is how we can use this operator. The next operator that you can use is the else operator. And to show you how that works, I'm gonna delete this code. Now I'm gonna declare another variable up here. So I'm gonna call it text2. We put equals and we type text. Now to use the else operator, we put a question mark and a colon. And now we need to type something on the right of the else operator. So we put here some text. I'm going to explain immediately how this works. So I'm going to type here some text. Now what the else operator is doing is saying, if this variable text is null, then assign what is on the right to this variable text2. If this variable text is not null, then assign what is to this variable to our variable text text2. And now let's type here text2, and let's delete the length. So now if you run this code, let's actually put something more discrete, like the variable is null. So if you run this code now, we get the variable is null because it checked to see if this variable on the left is null, and if it is null, it's gonna it assign this to a variable text2, and then we output that in the console. But if this is not null, then it's gonna assign what is on this, whatever value this variable has to our variable text2. So if now I put here text equals this variable is not null. Now if I run this, now this will evaluate to true, so it's gonna assign whatever value is on the left to our variable text to our variable text2, and we're gonna see in the output the variable is not null. So on a variable text2 has now the value assigned for this variable. So this is the shorter way of writing. Let me show you how we will write this in the longer way. So in the longer way you will have something like this. So let's delete this code. Actually, yeah, let's delete this code. We'll have a variable called text2, and it's gonna have an empty string. So what we would have to do without the else operator, we have to first check if text not equal to is not equal to null. Then we're gonna call our variable text2, and we're gonna assign text to it. Else we're gonna assign to our text2 variable the text this variable is null. So this is the longer way we're doing of what we did previously. So if I press Ctrl L to format the code, now if you run this, you will see the same output. The variable is not null. So we get the variable is not null, and this is the longer way of doing the same thing. So if I assign here, if I delete this, and the variable will have null. Let's press Ctrl Z. If I run this, now the else part is executed. So our variable text2, it will have this variable is null, the text assigned to it, and then it's gonna output that in the console. So this is the longer way of doing what we had previously. So if I press Ctrl Z to have the else operator back, so that was the longer way of doing what we're doing here in one simple line of code. So this is our discussion about nullable types, and I hope that you got a lot from this video, and see you in the next video. Right, now it's time to start a discussion about functions, but first let's create a new project, and I'm gonna speed up the process now a little bit because we already did this a few times. So I'm gonna call it functions, should be in Pascal case. Select IntelliJ, click on next and click finish. Alright, let's delete the code inside the curly braces. Let's hide the project pane, and let's start by saying that until now we have written our code only inside the main function, and occasionally we have called the println function to output some code to the console. But as I said at the beginning of our videos, you can create your own functions in Kotlin. So let's see how we can do that. So go down here at the end of our main function, at the end of our enclosing curly brace, and to declare a function we type the keyword fun, we put space, next we need to give a name to our function, and the name of the function should say what the function is doing, and generally it's a verb. I'm gonna call this function say hello, and it should be in camel case. Next we put parentheses because functions can take input to work with it, and next we put curly braces because this is where we're going to put our instructions for our statements. This is going to put our logic. Now let's add the println statement here. Let's type the text hello, and now let's run this code. Now, as the input, we don't see nothing here because if you hover over this say hello function, it says function say hello is never used, because in order for this function to be used, you need to call it from main function, and to call it from main function, we type here the name of the function. You can type it entirely you, or you can start typing, and IntelliJ is gonna give you some suggestions. So press enter to fill in that for you, and also press Ctrl Alt L to format the code. Now let's run our code. Now you're gonna see that it says in the output hello, because the main function executes what's inside the curly braces, and on the line 2 it sees that we have a function that we're calling here a function. It executes the say hello function, the code inside the say hello function. In this case it's a simple println statement, and then it outputs that to the console, and it exits the code. It finishes the process because we don't have anything else below for say hello. But what we can do is put another say hello here to call our function again, and now we're gonna see the output hello 2 times, because now we're calling the say hello function first on the line 2 and second on the line 3, so it will be executed 2 times. So you can see that in this way functions are reusable and are separate chunks of code which can be reused, and you'll see that they can be reused in specific cases. Now, as I said, functions can take input, and to make a function to receive some input, we need to define what is called a parameter. And to define a parameter, we type the name of the variable first. I'm gonna call it name, and we need to explicitly provide a type here. So for the type, I'm going to choose string, and we need to explicitly provide a type here, because there is no way for the type to be inferred here, because the value that you're going to pass to this say hello function is going to be here, so it's impossible to know to what kind of value we're going to pass to it. So this is why you need to explicitly say what data this parameter or this variable is going to store. So let's delete this second say hello. Now let's change the text that we have here in the println. Let's refer the parameter name. So put a $sign and start typing name, and you can see that it has this P for parameter, and press enter. Now what is going to happen now is that this say hello function is going to be called, is going to be executed from our main function, and the code inside the say hello function is also going to be executed, and specifically is going to execute this text that we type here to be outputted. It's going to execute the hello, and then it's going to execute what value if we have passed as an argument for this parameter. And if you don't know what an argument is, the argument is the value that you pass to the function. So in this case, up here we need to pass some text. So I'm gonna put a name here, not here. It should be in double quotation marks, and we see that we have a hint here which says the name of the name of the parameter, which is name. Now what is gonna happen now is this say hello function is gonna be called, and this value that we passed here is gonna be used in our println statement where we're referring now, which is here we're using the name, and it's gonna use that value, and that value is gonna be outputted down here. And let's run the code to see. Now get hello Alex, because now it's using the value that we passed here as an argument to the parameter name, and it's using that value down here where we type the println statement or function. Now functions can take multiple arguments, and to do that we need to define I should say that you can define more parameters for the function, and a function can take multiple arguments. And to define another parameter, we put a comma here, and we type the name of our parameter. It's gonna be age, and we need to provide the type. And I'm gonna provide the type as an integer, because it's gonna store whole numbers. And here we're gonna put an exclamation mark, and I'm gonna type your age is. Now we need to refer the parameter age, and also need to provide the value for that parameter. Now if you go up here, now it says that you need to provide a value for the parameter has age. It says no value passed for the parameter age. So here you need to type a value for our parameter that we define. So let's say 22. Alright, now if you run this code, now those parameters that we define here are gonna use the values, the arguments that we type here inside our curly braces, or how it's often called, the body of the function, or the code block. So it's gonna use the values here and here. Now another important thing to know is that you cannot change the value of a parameter. So if you type here age equals, let's say 30, now if you hover over here, because you have an underline, it says val cannot be reassigned, because those parameters are declared as vals, as variable vals. So that means that they are immutable. You cannot change their values. The only way to use a variable which can have his value change is to declare one. So if you declare here a variable, I'm going to declare it as a var to change its value. I'm going to call it number, and if I assign here a value of 50, now as you know, you can change now his value to, let's say, 70. And you can also assign the parameter here to our variable number, and now we can change his value. Also you can put number, and you can put another value here. Alright, another important thing to know is that this variable that we define here, also the parameters, are scoped inside the function say hello. In other words, they cannot be referred or accessed outside of the curly braces of the say hello function. So if I try to access that number variable here, it's not working. If I try to access here on the main function, let's say type number, I can't, because it's scoped inside the say hello function. It exists only inside the say hello function. The same thing with the parameters, age or name. So in this way you can see that functions can be very useful, because they are chunks of code which are reusable and flexible. And to see an example with this, let's declare another function down here. Let's call it let's type the fun keyword. Let's call it getData, and this function is gonna mimic a real function in a real app, which can get some data from the internet. Of course that we're not gonna get some data from the internet, but we're gonna mimic that behavior. So here I'm gonna define a parameter. Let's call it data, and for the type let's choose string. Right, let's put the curly braces, and here let's add the print ln statements, and here we're gonna print your data is, and I'm gonna refer the parameter data. Alright, now what I can do up here is to define a boolean variable. It's gonna be a val. I'm gonna call it has internet connection. I'm gonna assign a value of true to it. Now I can put an if statement here. Now I can check to see if that expression is true. So I can put equals true, or use the shortcut because it's better. Here I'm gonna put the curly braces. Now I'm gonna call the get data function only if this condition is true. So in our case it's true, but in a real app that can be false. So in that case you can do something else. As you're gonna see, let's also add the else part here. And here we're gonna call another function, which is gonna be called in the case that there is no internet connection. All right. So above here you can put some logic to get the data from the internet, but because this is a simple example, we're gonna type here directly some text. Let's put some data, and for the else part, in the case that there is no internet connection, that variable is false, we can declare another function down here. And I'm gonna call it fun show message, and this is not gonna have any parameters. It's gonna have only simple println statement, and it's gonna say that there is no internet connection. All right, so now let's go up here now, and now you're gonna call the show message function in the else part. Now if you run this code, you're gonna see hello Alex, which is our first function up here on the line 2. Your age is 22, and next to see your data is some data, because it executes the say hello function, then it declares this variable, and it checks to see if this condition is true, and this condition is true, and it executes this function get data. So this is why you get your data is some data. But if for whatever reason the user has no internet connection, let's say you assign a value of false to this, now this function is going to be called show message. So this function show message now is called, and the code inside the show message function is called, which is println, this println statement which says there is no internet connection. In a real app you can have some logic to show dialogue that there is no internet connection, and you can see that in this way with functions you can divide your code in different chunks of different chunks of code, which can be called in very specific cases. So in this case we only call our functions only in the case that we have internet connection, or in the case that we don't have internet connection. So in this way we have divided our code in different chunks of code, which can be called in different specific scenarios. And in this way we can write a program, because if you just put your code, all of your code in the main function, and you execute that code from top to bottom, you cannot create a program like that. So this was an additional discussion with the get data and show message, and I hope that I not confused you a lot. So see you in the next video. Alright, so in the last video we've seen how we can create functions, how we can call our functions, how we can define parameters to our functions, how we can send data to our function as arguments. Now it's time to see how we can return some data from a function. But let's first read the code that we have here to make things more clear. And the code inside the function, the main function. Alright, now let's define another function. I'm gonna type the fun keyword space, and it's gonna be called getMax. And this function is gonna return the maximum of 2 integers. So I'm gonna define here a parameter. I'm gonna call it a. In a real app you should use more descriptive names. It's gonna be of type int, and the next one is gonna be called b, and it's gonna be also of type int. I'm gonna put the curly braces, and I'm gonna press enter. Now to get the maximum value between these two numbers, we type here val max, and here we type an if expression. So we type if a greater than b, then we're gonna assign a to our max variable, else we're gonna assign b, and in the case that the two numbers are equal, b is gonna be assigned to our max variable. Now, in order to return this value to our function, we need first to say to the function what kind of data is gonna return. And to do that, we go here at the enclosing parentheses, and if you don't have spaces here, or you wondering about how to have the proper formatting, you just press Ctrl Alt L and the code is going to be formatted. Alright, and here we put a colon, and here we define what type of data this function is going to return, and in this case it's going to be an integer, so we put int here. And this is similar to the way we declare a type for a variable. Now, if you go down here, now you see that it says a return expression is required in a function to block body. So now we need to return this. Now we need to return some data that we define here. In this case, we need to return an integer, and to return the maximum value to our function, we type here return, the keyword return, and our value, which is our variable max, and press enter. Now, if you call this function in our main function, get max, and now let's also press Ctrl Alt L to format the code. And here let's say that we type two arguments for our parameters. Let's say that we put 5 and 9. Now if you run this code, now you're gonna see in the output nothing, because in order to get this value, we need to retain this value, to capture this value in a variable. And to do that, we define a variable in front of our getMax function. This also be a val. I'm gonna call it max, and we're gonna assign the getMax function to our variable, and that is gonna return our maximum number. Now, you may see here that you have two names. We have the same name here and the same name, and that is not a problem, because this variable max that we have inside the getMax function exists only inside the getMax function. It's scoped only here. This is why you can use the same name here. So if I try to type here also max to declare the variable which is going to be called max, I can't, because it says completed declaration, because the compiler doesn't know, if you assign a value, let's say, to this, it will not know what variable to call, because you have the same name. But up here is not a problem, because this is in the block of the main function, so it exists only here, and this exists only here. Now we have called our getMax function, and this function is going to return the maximum of these two values, which is 9. Now we need to print this value in our console, and to print this value, you just type here println, and we're referring our max variable. Now if you run this code, you're gonna get 9, because our getMax function is called. The two arguments are passed to our function. Then the code inside our getMax function, it's executed. It compares these two numbers, and if a is greater than b, then it assigns a to our max variable, or it's gonna, if that is not true, it's gonna assign the value of b, and then it returns that max value to the function which is called. So this function returns that value here, and here we capture that value which is returned from the getMax function in our max variable, and then we print that max variable with our println function or statement, and then we see the output in our console 9, right? Another important thing to know is that after we type the return call or the return keyword, the function is left. The function is stopped there. So if we add other text here, let's say we add here a println, and we type here some text, you see that this is highlighted and it says that this is a reachable code, because after we typed our return max, our function is stopped, is left, and it's not executing any code below of that return call or of that return keyword, right? Another important thing that you can do with return keyword is that you can return from a function without returning any kind of value, and in that case it will have the same effect, and that means that it will leave the function right there even though we don't return any kind of value. So I can type here return, but let's delete here the type, because now it's expecting a value to be returned, and now this will have the same effect. It will leave the function right there, and it will not execute any line of code below of our return keyword. So if I type here a println statement, and I put some text here, as you can see, this has the same effect. If you type the return keyword in your function, it will stop the execution of the function, and every line of code below of the return keyword is not going to be executed. So it's very good to know this also. Another important thing to know is that we can only return a single value with the return keyword. So we cannot return here two integers, let's say. And also we cannot have two returns in the same function. Let's say if I put here also return max, I can't, because this is also a reachable code. But I can have two returns calls if they are reaching different branches. So if I change this if expression to an if statement, so if I type something like this, if let's say a greater than b, let's add the curly braces now, we type here return a, else return b. So now we have two returns, but they are never reached together. They are always reached separately. So this is why I can use here two returns, because as I said, they are reached always separately. So if you run this code, you're gonna see the same output. So you see 9. So this is another way to write the same thing that we had previously. But it's recommended to use what we had previously, because with specifically it's better to have an if expression. Another way to write the same thing but in a more concise way, and let's undo the code that we have that we had previously. So let's press Ctrl Z. So now I have the code that we had previously. Now if you hover over this max, it says variable used only in formatting return can be inline. So if you click here inline variable, now this thing does the same thing that it was doing previously, but this is a shorter way to write the same thing. So now it returns A if this condition is true, otherwise the else part is called and it returns B. So we have the same thing, but written in a shorter way. Alright, another way to write the same thing that we have here is by using what is called the single expression function. And to do that, we can remove the curly braces. We can put our code up here. We can remove the first curly brace, and we can also remove the return keyword. And here we put equals. And this now does the same thing that the code the previous code was doing, but this is a more concise way, and it's recommended to use this only if you know that you have in your function a single expression, or in other words, if you know that you have a single line of code. And you can also remove the type here, because the type can be inferred. And again, only use this if you know that you have in your function a single line of code, and in that case you can skip the return keyword. But if you have multiple lines of code, you should always use the curly braces and the return call or the return keyword. Alright, so this is our discussion about how we can return a value from a function. Alright, so now let's continue our discussion about functions, and now it's time to look at what is called function overloading. And let's say that I want here to pass not two integer types, but two doubles to be compared. So let's say that I type here 6.5 and 9.6. Now, this will not work because we define here explicitly that the parameters are of type int, so we cannot pass here double. And a solution to this, it may be to create another function with a different name and to define the parameters as doubles. But that does not make a lot of sense, because we are doing the exact same thing, so it does not make sense to create a function with a different name. So what we can do instead is to, let's change this back to integers, is to duplicate this getMax function, and to do that you can press Ctrl D or command line on Mac. So I'm going to press Ctrl D here. Now what I can do is change the types of the variables. So I can put here, instead of integer, I put double, and here I can put also double. Let's add a space to make things more clear. Now if I pass here, let's say 5.6 and 9.7, now you see that we have no error. So if you run this code, alright, so we get in the output 9.7, and this is correct. This is bigger than 5.6, but now it's using the second function, which is the function which has the parameters as of type double. And you can see that this function now, which is using the parameters as integers, is grayed out, because the compiler can figure out what function to use by the argument types we pass here. So in this case, we pass here doubles, and it knows that it has to use this function, which has the types, which has the parameters defined as type of double, right? Another way to overload a function is to, let's also press Ctrl D, is by changing the number of parameters. So I can put here, let's say also integer, also integer. Let's pass the third parameter now, and this is also going to be an integer. It's going to be called C. It's going to be of type int. Alright, now let's change this logic to an if statement. So let's delete the if expression. Let's put the curly braces. Alright, so let's change this now. So you can type it here now, if A greater than equal to B and A is greater than equal to C, then we're going to return A. So now we're using the return keyword. Else if, now we're putting here an else if B is greater than equal to A and B is greater than equal to C, then return B. Else C is gonna be the bigger value, so put here return C. Alright, let's press Ctrl Alt return B here. Right, so I need to put here the type. This way I get that error. Right now everything is okay. Oh, so from here is the problem. Right, so now if you run this code, let's change this to, let's say, 5, 7, and 10. Now if you run this code, you see that the two functions above are grayed out. And now it's going to use the third one, which has third parameters. Alright, so we get in the output 10, which is correct. So if you change this to test, let's say we put here 100, let's put here 3, and if you run this code, now we get 100, and this is correct. Alright, so this is our discussion about function overloading, and you can use function overloading every time you know that you will do the same task but with different type of parameters or with a different number of parameters. Also, you may have noticed that we have an underline over the if statement. So if you hover over here, it says that the return can be lifted out of if. So if you click this, you can write it in this way, or we can keep it in the previous way. But because this is underline, that means that Kotlin recommends to use it in this way. So see you in the next video where we're going to talk about default parameters. Alright, so now it's time to look at another features that you can use with functions, and that is called default parameters. And let's first declare a function. So I'm going to declare down here at the end of our enclosing curly brace of our main fun. I'm going to call it send message. Let's put the parentheses, and inside the parentheses I'm going to define two parameters. The first is going to be called name, it's going to be of type string, and this second one is going to be called message, and it's going to be also of type string. Now let's declare the curly braces, press enter, and let's print those parameters in our console. So let's put a print line here, and inside the also while I'm typing this println, you may see that this println function is a function which is overload, referring to our previous video, because you can see that it has the same name, but it can take different types of parameters here. So it has int, this thing which is any, byte, short, char, long. So the println function that we've used throughout our videos is overloaded. This is why you can pass different types of data to it. Now let's type here println quotation marks, and inside the quotation mark we're going to type name equals $name. So now it's going to print the argument values that are going to pass to this function as parameters. Now let's call this function here. So let's type send message. Let's press Ctrl Alt L to format our code, and here I'm going to pass a name, let's say Alexa, and the message, let's say hello. Now if you run this code, you're going to see in the output the name here is going to be this argument that to type here, which is Alexa, and the message is going to be hello. So we have this. But let's say that for whatever reason the user doesn't want to send any kind of message, but we still need to use this function. What you can do then? One way is to remove this parameter all the way, but that's not good, because you still need to use this function with those two parameters, the name and the message. So let's say that if the user doesn't pass any message, we can define here what is called a default parameter. So we can assign here a default value for our parameter. So I'm going to put here just double quotation marks, or you can put some text here, but let's put just the double quotation marks, which is just an empty text. So if now I don't pass a message here, now it's still gonna work, because as a value for this parameter is gonna use the default value that we defined here. Alright, so let's run this code to see now how it works. So now I get name Alexa and message equals empty, because double quotation marks without any text is an empty text. Now if I want to pass here now the message, now I can pass here the message, and now our default value is going to be replaced with the argument value that we typed here. So now I'm going to see name Alexa, message hello. Alright, you can do the same thing for the name. So here you can define, let's say the user doesn't want to type a name, and you can define a default name, let's say user. Yes. Now let's say that I delete both arguments here, and I just have an empty function. If I run this, now it's gonna use the default values that you type here, respectively user and this empty string. So now I get name, user, and message. Now let's put back what we have. So let's put here Alexa, and let's put our message here again. Now let's run this code again. Now what we can also do is use what is called named parameters, and let's say that I want to pass a parameter only for the second let's say that I want to pass an argument type only for the second parameter that we define here, respectively for our message. So if I delete this, now let's say that I delete the argument for our name, and if I want to pass a value only for the message, let's put in the quotation mark because it's a string. Let's say I put the message hello here. Now you can see that the hint is name, so it's using the first parameter that we define here, not the second. So what we can do now to pass a value only to our second parameter, because as you can see it's assigning this value that we typed here for this parameter. And to solve that, you can use what is called name parameters. So with name parameters, we can type an argument for our parameter irrespective of the order in which they are defined. So in our case, we have the name first defined and then the message. So to use that, you can type the name of the parameter, let's say message. Now you see that we have this p message and it's equals to a string, so that means that we need to pass some text there. And now we can pass here hello. And now this is gonna work, because now we can pass a value to our parameter irrespective of the order in which they are defined here, right? So now we get name is this default user, and the message is hello. And we can do the same for the second one, which is name. So I can put now here name, and I can type here let's say Alexa. And if you run this, now you get Alexa is the name and the message is hello. So with named parameters, this is how they are called, or name arguments, we can pass a value to our parameters irrespective of the order in which they are defined in the function. So in our case, name is first defined, and you saw there that when I try to use the message to assign a value only for the message, it was using the first parameter, because this was the order in which they were defined. But with these named parameters, you can change, you can type an argument irrespective of the order in which they are defined, and you can put this in multiple lines to make it more clear, like this, let's say. So this is our discussion about named parameters and default parameters. But before we end our video, I should say that to the default parameters, we cannot only type literals values like we typed here some values directly. We can use variables, or you can use a function which can return a value. So I can define here a function, let's say fun send text. It's not gonna have any parameters, it's gonna return a string. So I'm gonna define here a string as the type of return, and here we're gonna type return, and let's type some text. Now we can call this function here send text, and now this value which is returned for this function send text is gonna be assigned to our parameter message. So now if you run this code, let's increase this a little bit. So now if you run this code, you're gonna see that now the default value for the parameter message is the return value from our send text function. So you can see now that we have okay, so let's change it here to no value for our message. So now if you run this code, because there we have an argument passed, so let's not pass no argument. So now it's using the value that was passed as the default value for our parameter, which is this return value from this function. Now, because here we have one single line of code, we have one single expression, we just return some text to our function, we don't have multiple statements in our function, we can write this as a single expression function. And you can remove the curly brace, and you can write this as a single expression body like we did in the previous video. So you can put it just equals, and you can remove the type here also. So if you run this code, now you're gonna see to the output for the parameter message some text, which is the value which is returned from this function, from the single body expression function, right? So see you in the next video. Alright, now it's time to look at the var arg keyword and how we can use the var arg keyword with functions. But first, let's declare a function below of our enclosing curly brace of our main function. So I'm gonna type here the fun keyword to declare a function. I'm gonna call it sum because it's gonna return the sum of all the parameters that we're gonna define. So I'm gonna define here some parameters. First is gonna be called a, it's gonna be of type int. Second is gonna be called b, also int. Third is gonna be called c, also an int. And the final one is gonna be called d, also an int. And this function is going to return the sum of all of those parameters. So we need to define here the return type, which is going to be an int, a whole number. And now we can put the curly braces, and here we type return a plus b plus c plus d. And this is going to return the sum of all the parameters that we define here, or the values that is going to be passed as arguments to this function. And you can write this as a single expression function if you want. So you can write this like this if you want. This will have the same effect. But I will write it with the curly braces because it will make things more clear. So let's undo this. Right, now let's call this function here sum. Let's press Ctrl Alt L to format the code, and let's pass some values here. So I'm gonna type here 5, 6, 7, and 10. Alright, if you press Shift Ctrl P on this, you're gonna see that the type of this function, let's press again, the type of this function is an int. So this function returns an integer. So it's an expression. That means that we can put this, instead of putting storing the return value in a variable, we can put this directly in a println function. So we can type here print ln, and we can put the function inside here because that function is of type int, so it's going to return the sum of all the arguments that we type there. So now if you run this code, we get 28 because 5 plus 6 plus 7 plus 10 is 28. Now, if I want to pass another parameter here, let's say that I want to pass another number here, I can't because I am limited by the number of parameters that we define here. Of course that I can define another parameter here, but what if I want to pass 10 numbers or 15 numbers or 100 numbers? In that case it will be very tedious to write all of those parameters, and to solve that you need to use what is called a vararg keyword, and a vararg keyword allows us to pass more than one parameter, actually more than one argument to our parameter. So to declare a vararg keyword, we type here vararg. So this is the keyword vararg. It stands for variable arguments. Now we need to define a name for this vararg. I'm going to call it numbers, and we also need to specify a type, what kind of values this vararg is going to store. Now this return keyword these variables here are red because they don't exist. Now if I want to, but first let's say that I want to type here another parameter. Now you see that we have no problem, so I can type here whatever number of numbers I want, and there is no problem, as you can see. Now to sum the values which are stored in these vararg numbers, we need to use something which we didn't cover yet, but we have a separate section which I show you how to, in which I explain this thing that I'm going to use now, and that is loops, because now we need to loop through our numbers and to add our numbers to a variable. So we need to use what is called a for loop. So to do that, first we declare a variable. I'm gonna call it let's say result. I'm gonna assign a value of 0. Now to use a for loop, we type for, and again I'm gonna go into more detail about this in the separate section, but now we need to use this because there's not another way to sum up the values inside the vararg numbers. And here we need to define a name for our variable, so it's going to be called number. And now we use the keyword in, and now we're referring the parameter, the vararg parameter, which is defined up, called numbers. All right. Now here you can put the curly braces, and inside the curly braces we're going to type, here it should be numbers, result, and now we're going to use that abbreviation, which is plus and equals, plus equals number, and now here we're going to return the result, return result. Alright, so let's explain what we have here. So first we declare a variable, we assign a value of 0 to it, so it's a type int. Next, what this for loop is doing. So this for loop is doing executing a line of code multiple times. So it's executing what's inside the curly braces until it finishes to loop through all these numbers which are stored in the vararg numbers. So it first assigns the first number to our number here, and it loops and it adds that number to our result. Then it does that again and again and again until it finishes, until it reaches the final number 5. And in that case, also gonna assign from our numbers the number 5 to our number, and then that number is going to be added to our result variable. And when it finishes that looping, when it finishes that thing, it's going to return the result. It's going to return all the values which were been added to our result variable. So now if you print this, now you get 85, and probably this is the result of this calculation. So this is how you can use vararg numbers, vararg keyword to store more than a limited number of parameters defined by you. And another shortcut to loop through this is using a for each loop. So we can do something like this. But this time, let's say that I don't want to return something. So let's say that I delete this. And I can type here, actually, numbers for that. Here you put that for each. And here you type print ln. Again, this is a more complex subject which is going to be covered in the next videos. So here you type print ln, and we type it. All right. Now let's call our sum. Let's define some numbers here. Let's say that I type here 1, 4. Alright, so if you run this code, now you can see that every number in that that we defined here is printed one by one. So this number, this for each, which is also a loop, it goes through all of these numbers and it prints them one by one. And again, we're gonna look at the for loop and the for each in the next videos, but I had no other way to show you this example without using them. But if you feel confused by the for each or the for loop, don't worry, we have a separate section in which we talk about in detail about this. For now, the only thing you need to know is that you can pass an indefinite number of parameters you can pass an indefinite number of arguments to our vararg numbers, because this allows us to pass an indefinite number of values. So here you see that we have 1, 4, 5, 6, 7, 8, 9, 5, 7, and 6 numbers that we have here. So this for each is going through all of them and it prints them one by one. So see you in the next video. Right, now it's time to start our discussion about loops. But first, let's create a new project. I'm gonna call it loops. Select IntelliJ, click on next and finish. Right, a project is created. Let's delete the code inside the curly braces. Let's hide the project pane. And let's start by explaining what loops are and why you need to use them. So loops allows us to execute a piece of code multiple times without you writing down every line of code manually. So let's say that I want to print 10 numbers in the console, or 20 or 50. Instead of instead of typing that code manually line by line, which will be very tedious, you can use a loop and you can put that code in a loop, and that code in the loop, it will be executed repeatedly until a certain number is reached. So let's see how you can define a loop. To define a loop, we type here for. This is the first loop that we're going to look at, because there are other loops. So this is the for loop. We press enter, Inside the parentheses we type I. This is convention, you can put whatever name you want there. Now we put here in, this is the keyword in, and now let's say that I want to loop from 1 to 10, and to do that we type 1 dot dot, this is a range, 1 to 10. Now I put the curly braces, and inside the curly braces I'm gonna put the code that I want to be executed 10 times. So I'm gonna type here println, and I'm gonna type the value of I at each iteration, and we can put it like this. You can type here, you can put in the quotation marks, and you can do the placeholder. You can put I. So now if you run this, so now you get I is 1, 2 until 10. So what it's doing is looping through this range until it reaches 10. Then it stops. Now you can write this I like I did it here using a placeholder, or you can write it like this. Now if you run this code, it will have the same effect, but will not have the text before here. So now you get 1 until 10. Now there are other variations to use this range, and one of them is to use until. So let's comment this code. So let's press Ctrl/. Right? Now let's type 4 again. And now I'm gonna call it also I. Here you can put whatever name you want. And instead of now I'm gonna put also again the in keyword. And instead of putting the dot dot to loop to a range, I'm gonna put 1 until 10. Alright? Now I'm gonna add the println statement, and here I'm gonna type I, and this will have the same effect with a single difference, that 1 until 10 is gonna exclude 10, and 1 using the range dot dot 10, it will include 10. So if you run this code, you're gonna see that you will not have 10 here, because 10 is excluded when you're using the until. So now as you can see, we have 1 until 9, and 10 is excluded because now we're using the until. So if you're using the range, which is dot dot, the last number is gonna be included, but if you use until, the last number is gonna be excluded. So it's important to know that these two, respectively the until and the range, can only count upwards. So we cannot put here 10 until 1, because the first number, the number on the left, needs to be smaller than the number on the right. So we cannot put 10 until 1. We can only count upwards. You can only put 1 until 10, or 1 dot dot 10. So to loop backwards, we need to use another thing. So let's comment this code also. Now to loop backwards, we type 4. Again, in the parentheses you put I. Here you can put whatever if you want. In. So here you can put whatever name, but conventional is I is used. Now I'm gonna put in, and now I'm gonna put down. First let's put 10 down to 1. Let's add the curly braces, the println, and let's put I here. Now this is gonna count downwards. Now it's gonna count from 10 to 1. So if you run this code, Now I get 10, 9, so it's counting backwards, right? Another thing that you can do is that you can introduce an arbitrary step. So let's comment this code also. Let's add below another code, another for loop. So here I'm gonna type for parentheses. Let's put I, and let's use the until. So in 1 until 10. So now I can put an arbitrary step. So at this arbitrary step, that number which is at that arbitrary step is gonna be skipped. So I can put here step 2, let's say. So now I'm gonna put the curly braces to have some code executed. I'm gonna put println, and let's put here I. So now if you run this code, now I get 1, 3, 5, 7, and 9. So you can see that at the second iteration, the number is skipped. So we have 1, 2 is skipped. Now then we have 3, 4, 3 and 4 is skipped, and so on. So you can put this arbitrary step if you want. So let's comment this code also. And let's add the first code that we had here to talk a little bit more. So let's put I in 1. Let's put the range .10 and curly braces. Here I'm gonna type println I. Now if you run this code, we'll get the same output as at the beginning of the video. So get 1 until 10 inclusive. Now again, what this loop is doing is going through this range from 1 to 10, and it's executing the code inside the curly braces 10 times, and when it reaches 10 it stops and it executes the next line of code below here. But because here we don't have any line of code, our program exits and is finished. So this is our discussion about for loop. There are other loops which can loop as long as a certain condition is true, not as long as a certain number is reached. So we're gonna look at the next loops in the next video. See you next. Alright, now it's time to look at the next two loops that you can use in Kotlin, and those are the while and the do while loop. But first, let's open our previous project called loops, because I'm gonna type my code there. So open your previous project, and here I already have deleted the code that we had previously here. But if you have the code, delete it, and let's start our discussion about the while loop. So first I'm gonna type while. This is how you declare the while loop, and here you can press enter to fill in the while key and the parentheses for you, or you can type manually the while and the parentheses. So I'm gonna press enter to fill in that for me. And next you put a space and you put curly brace here. So I'm gonna put the left curly brace and press enter, and the right curly brace is gonna be added automatically, as you can see on the line 5. Now, a while loop loops as long as a certain condition is true, in contrast to the for loop, which loops for a specific number of time. A while loop loops as long as a condition or an expression is true. So this gives us more flexibility in circumstances where we don't know for what specific number of times we want our code to be repeated. So we put our condition inside the parentheses here, and as long as this condition is true, the code inside the curly brace is going to be executed repeatedly. So let's see how we can do that. So first, let's declare a variable here. I'm going to call it number, and I'm going to assign a value of 0 to it. And here I'm going to type while number is less than 10. Inside the curly brace, I'm going to type the println function, and we're going to output the value of our number, and then we're going to increment the value of our number. So I'm going to put number, I'm going to use the increment operator, plus, plus. Let's put a space here to have things more clear. Now, if you run this code, you're going to see the numbers from 0 to 9. So what is happening, how this works? First, we've declared a variable, we assign a value of 0 to it. Next, we loop using the while loop. And first, the while loop is checking to see if this condition inside the parentheses is true. So it checks to see if the value of our variable number is less than 10. And it's true because we have 0. Then it executes the code inside the curly braces, and it outputs the value of our number in the console using the println function. Then it increments the value of our number, and then it loops again. But now the value of our number is 1. So now it will compare again if the value of our number is less than 10, which is true. It will loop again, it will output its value, it will increment its value, so now we have 2, and so on until it reaches 9. When it reaches 9, it will increment the value, it will output the value in the console, it will increment its value, then it will check again to see if this condition is true, but now the value is going to be 10 because it was incremented when it was 9. And this condition is going to evaluate to false, and the code inside the curly braces is not going to be executed. This is why we don't have 10 here. And it executes the code that comes below our while loop. But because we don't have any code, the program is terminated. And you can write this thing in one single line, but it's recommended to use this form only if you know that you have one single statement in your loop. So if I can delete this too, and I can put here directly number plus plus, and because this returns the value, it increments the value and it returns the value, it's an expression, I can run this code and it will have the same output. But if I delete the increment operator after the variable, and if I put it before, now I'm gonna see a different output here, because this increments the value of our number, then it decrements the value of our number, and this is called prefix increment. So this is called prefix incrementing, and the previous one, let's press Ctrl Z, this is called postfix increment. So this is postfix because it's the end of our variable, and if you put the increment operator at the beginning of our variable, is called prefix increment. Anyway, let's press Ctrl Z to have the code that we had previously and the curly braces. Now look what happens if I delete the increment, if I don't increment our variable now. Now let's talk what is happening. Because we don't increment the variable and the variable always has the value of 0, this will always be true, and it will execute the code inside the curly braces forever. So we'll have what is called an infinite loop. So if you run this code, now you can see that it prints 0 forever, because this condition never evaluates to false. So let's stop this by pressing on this red square. So now the process, the program is terminated. So this is why you need to increment the value of our number, because we want that condition to be false at some point in the future. Next, let's say that I assign here 10. So if I run this code, now this condition is going to be false because 10 is not less than 10, and the code inside the curly braces is not going to be executed. So now we have no output here because this condition is evaluates to false, and it's not executing the code inside the curly braces. But there are certain situations where you'll want to have your code executed at least once, even though the initial condition or the initial expression is false. So if I delete the curly braces and the code inside the curly braces here, now to do what I said, to execute the code even though the condition is initially set to false, to execute the code at least once, you need to use a do while loop. And to use a do while loop, you put here a do, press enter to add the curly braces, and we put our while at the end of our enclosing curly brace of our do. And here inside the curly brace, I'm gonna put our println function, and I'm gonna output the value of our variable number. So now if you run this, now get 10, because this executes the code inside the curly braces at least once, and after that it comes down here and it checks to see if this condition is true or false. And if this condition is true, it will repeat the code, but if the condition is false, it will not repeat the code. But the important aspect here is that it will execute the code inside the curly braces at least once, irrespective of our condition, if the condition is true or false. In our case, it's false. So these are the 3 loops that you can use in a Kotlin: the for loop, the while loop, and the do while loop. Now it's time to see how you can use the continue and the break keywords with those loops. So let's press Ctrl Z to undo the code to have the while loop back, because I'm going to start with the while loop and to see how we can use the break and continue keywords with the while loop. Let's bring this up a little bit. So let's first look at the continue keyword, and the continue keyword can be used to bypass a section of code. So let's say that I want to skip the number 7 in our loop. So I can type here if our variable number equals 2, so 2 equals 7. Let's put curly braces, press enter to add the right curly brace, continue. So now what this is gonna do is, when it's gonna reach the number 7 and this condition is gonna be true, it's gonna call continue, and it's gonna bypass the code that comes below of our if statement. So if you run this code, look what happens. It happens nothing, because here our number has a value of 10, so this condition is false, so the code is not executed. So let's put here 0. Now if you run this code, so you get 0, 1, 2, 3, 4, 5, and 6. But and you see that at 7 it skips the code, but why you don't have the next numbers? This is because unintentionally we created here an infinite loop. So let's stop this and to explain. So what happens here is that because we say here explicitly to check here explicitly, we check here to see if our number is equal to 7, then we're going to continue. In other words, you're going to skip the code which comes below of our if then statement. Then this code is never called. So this code is never called, the println, and more importantly, the increment operator is never called on our number variable. And because of that, because our variable is not incremented here, when it's gonna loop again, it will have again the value 7. So this condition in the if is gonna evaluate again to true, and it's gonna call continue again. And because this code again is never reached, this code, and the value is not incremented, it will still have the value 7. So this is gonna evaluate again to true. So it does this forever. And to change that, we need to put our number, and which is incremented, before our if, and that is gonna solve the problem. So now if I Now if I run the code, let's increase this. Now get 1, 2, 3, 4, 5, and 7 is skipped. Then 8, 9 and 10, because now when this condition evaluates to true, it will continue. It's not going to print the code is not going to be executed below of our if, and it will come back to loop, and now it's going to increment the value, and the value is going to be 8 instead of 7. This is going to evaluate to false, and the continue is not going to be called, and it will print the number 8, and it will do the same for it will increment the value again, and then we'll have 9 and so on. So this is how you can use the continue keyword, and you have to be careful where you put your where you increment your variable, because as you saw, you can easily get into an infinite loop. Now you can have a more complex expression here. So you can put here if number is greater than, let's say, 2, and number is less than 8. Now if you run this, look what happens. Now you get 1, 2, and then we get 8, 9, and 10. Because what this condition now checks is if our number is greater than 10 and less than 8, then continue, then skip that number. So this is why the numbers between 2 and 8 are skipped, because we call continue on them. And if you hover over here, you see that it says the two comparisons should be converted to a range check. So we can write the same condition that we have here using a range, but this is different from a range that you've used in a for loop, in the sense that this is now checking to see if our number is in the range from 3 to 7. So if you run this code, now I have the exact same output, but now we are using the range to check to see if our number is in that range, and if it is that range, we call continue to skip that. The next thing that you can do is you can break the loop. You can stop the loop using the break keyword. So I can say here again, if number equals let's say 7, call break. So I'm going to type here break. Now when this condition is going to evaluate to true, it's going to call break, and the loop is going to stop. It's not going to execute any line of code after that. It's going to stop, and it's going to leave, and it's going to execute the code which comes below of here. But in our case, we don't have any code. So you see that we have 1, 2, 3, 4, 5, and 6, and when it reaches 7, it breaks, and it's stopping the loop. It's not printing the value, and it executes the loop. So it terminates. So and we can do the same thing with a for loop. So we can use the continue and break with a for loop. So you can type here for, let's say I in, let's create let's say 0 to 10. Let's create this range. Let's add the curly braces. Now I can say here if I in, let's say 3 to 8, then continue. Let's print the value. Let's type here println. Let's print the value of I here. So now if you run this code, so we have our first loop, which loops to 6, and then it breaks because you call break there. Then it's using the for loop, it loops from 0 to 10, but because here we're checking to see if our number is in the range 3 to 8, then skip it. You get 0, 1, 2, and then the numbers, the 3 and the numbers between the 3 and the numbers between 3 and 8 inclusive are skipped here. So we have 0, 1, 2, and then the numbers between 2 and 9 are skipped, and we have 9 and 10. And we can use also the break keyword with the for. So I can put here if I equals 7, break. So now if you run this code, now you get 0, 1, 2, 3, 4, 5, 6, and when it reaches 7, it breaks, similar to our while loop. So this is how you can use the break and continue keyword with the while and for loop, and you can use the break and continue keyword also with the do while loop. Next, we're gonna look at how we can nest loops within each others, and we're gonna look at an example using the while loop. So I'm gonna delete the code of the for loop and the println statement there. I'm gonna delete the if then statement, the break keyword, and I'm gonna bring the println function up there. Down here I'm gonna declare a variable. It's gonna be a var. I'm gonna call it I, and I'm gonna assign a value of 0 to it. Now, inside the while loop, I'm gonna type another while loop. Here I'm gonna put a condition while I is less than 5. We're gonna increment I, and we're gonna output the value of I in the console. But let's put some text here to make clear what loop is looping. So I'm gonna put 3 asterisk signs here. I'm gonna type the $sign and I. So now if you run this code, let's also change this condition to less than 5. So if you run this code, now we get, first we get 1, then we get our code inside of our inner while loop, which is the 3 asterisks, and we get 1, 2, 3, 4, 5, then it loops again. But let's take this code line by line to explain what is happening here. So first we declare this variable call number, we assign a value of 0 to it, then we loop using the while loop, the outer loop, and it checks to see if this condition is true, and it's true, 0 is less than 5, so it executes the code inside the curly braces, and it increments the value of our number by 1, then it outputs the value of our number in the console, so we get here 1. Then it declares this variable called I, and then it starts looping inside our outer loop while using the inner loop while. So it loops here 5 times. So when it finishes, it goes back, and now the value was incremented by 1. It will check again if the condition is true. It will execute the code inside the curly brace. It will increment the value now, so it will have 2. It will output that value, so now we have 2 here. And then it will loop again 5 times using the inner loop, and it will do the same thing for the next round and the next round until we get to 5. When we'll get to 5 will not be less than 5, and this condition will evaluate to false, and the code inside the curly brace is not going to be executed. Alright? And you can use the break keyword inside the inner loop. So I can say here if, you can put it above here. So I can say if I equals 0, then break. And you can put the break and continue keywords in one single line if you want. You can avoid the curly braces. So now if you run this code, now get 1, 2, 3, 4, 5, because now when it reaches the inner loop, it breaks immediately at every iteration in the outer loop. So when it comes down here, it will check to see if this condition is true. It's going to be true, but when it gets to the if statement, it will break. It will stop the loop. So it will execute only the outer loop. And with a break keyword, you can not target only the loop. So with this break keyword, we stop only this while loop that we are currently, that is currently the nearest loop. But there is something which is called labels, and with labels you can target an outer loop. So you can break the outer loop here. So you can break the while loop which is here. And to do that, we give to our while loop a label. So we type here a name. I'm going to call it outer, and we put at. Now here you can put break, and now I'm going to type at and you put outer, and this should be a single word. Now, if you run this, look what happens. Now you get 1 because it breaks the outer loop. So it first evaluates this condition, it increments the value of our number, it prints the value of a number, and then it goes in the inner loop, it checks to see if this condition is true, then it checks to see if I is equal to 0, which is true, then it breaks, but now it's not breaking this loop, this inner loop, it's breaking the outer loop. So it's breaking this loop. So this is why you get only 1, and the code is not executed because it breaks the outer loop, and the code, our code, it's terminated because down here we don't have any code. So this is how you can use labels with the break keyword to target an outer loop, and the labels can be used also with the continue keyword and in other loops that we've looked at. So this is our discussion about loops. What you can do, I should say, is that you cannot target with the labels an inner loop from an outer loop. So you cannot, you can give here a label to our inner loop, but you cannot target our inner loop from our outer loop. So this is our discussion about loops, and in the next video we're gonna do a challenge. Alright, so now it's time to do a challenge using all the knowledge that we have accumulated so far, and I'm gonna use the previous project to put my code there. But if you don't have the previous project, you can create a new project and give it whatever name you want and type your code there. So I'm gonna open my previous project. I'm gonna delete the code inside the main function. Now, what is the challenge? The challenge is to create an arbitrary range of numbers. Then you need to find a way to go to that arbitrary range of numbers and to determine if a number is an even number or if a number is an odd number. And based on that, if the number is an odd number, skip that number. But if the number is an even number, then output that number in the console. Additionally, you should create a way to count all the even numbers that you found in your range and display the total numbers of even numbers at the end of your program. So try to do this solution, and after that you can watch my solution to this. So first I'm gonna declare a variable called number. I'm gonna assign a value of 1 to it. Next I'm gonna declare another variable, but this is gonna be a val. It's gonna be called last number, and it's gonna have a value of 20. Now I'm gonna loop using the while loop, and in the parentheses I'm gonna type while number is less than equal to last number. Then I'm gonna put curly braces. Now I'm gonna increment our number. Now here we need to add the logic to determine if a number is an even number or not. And to do that, I'm gonna add the function at the end of our enclosing curly brace of our main function. So I'm gonna type here the fun keyword. Now you need to give a name to our function. It's gonna be called is even number. I'm gonna put parentheses, and it's gonna take a parameter called number of type int, this function, and it's gonna return a boolean value, true or false, this function. So you put colon and we type boolean. Then you put curly braces, and now we add the logic to determine if a number is even or not. So you type here if, and now inside the parentheses we put another set of parentheses, and here we refer our parameter number that we have defined above, and here we put the modulus operator, because the modulus operator gives us the reminder of a division. So we put the modulus operator 2. Now outside our inner parentheses we put equals 0, then we put curly braces and we return true. Else we're gonna return false. Now how this logic works? So our number parameter, which is defined here, is going to take an argument. Let's say that it's going to take an arbitrary number. Then it's going to check to see if that number divided by 2 has no reminder, if it has no reminder, then that number is an even number, because even numbers, when they are divided by 2, they have no reminder. And if that is the case, if the reminder equals to 0, our number is an even number, and it's going to return true, and the else part is not going to be executed. Now, let's add the logic here. Let's use our function here, because as you can see now it's gray out, it's not used. So let's type here if, and in the parentheses we're going to type is even number, our function. We're going to call our function here, and we're going to pass a parameter to it called, now I'm going to pass the parameter, we're going to pass an argument, and the argument is going to be the variable that we define above. As you can see, you have the v there, so press enter to fill in that for you. Let's press Ctrl-Alt-L to format the code. Now, if you press Shift-Control-P on this, you're going to see that this is a Boolean expression, because this returns true or false. So we can put the logical NOT operator in front of it to change its value, to switch its value from true to false and from false to true. So let's put curly braces. And here we're going to call our continue keyword. Down here, I'm going to add a println, which is going to output the number in our console. Next, we need to add the logic to count the total even numbers which are found. So I'm going to declare a var. It's going to be even numbers counter, and I'm going to assign a value of 0 to it. And here we're going to increment our even numbers counter. So now if you run this code, we get 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So these are the even numbers that our program found, and is correct. But let's add a println at the end of our loop to print the total number of even numbers found. So let's put println here, and let's refer our even numbers count here. Even numbers counter. So if you run this, let's put some text actually. Let's put this in curly braces. So let's type here total number of even numbers found equals $. Now if you run this, now you get total numbers of even numbers found is 10, and this is correct. So, and it outputted correctly our even numbers, and it showed that the total number of even numbers found is 10. So let's now think about how this logic works here. So let's look at the if statement that we have here. So what is doing this thing here? So let's take an specific example, a specific number to see how this works. So let's say that here we pass 4, and it's going to use the logic to determine if this number is an even number, and if that number is an even number, it's going to return true. So this function, which is a Boolean expression, is going to return true, and then we're going to negate this value. We're going to change this value from true to false, and continue is not going to be called. And the code which comes below, which is our variable, which counts how many even numbers we have, it increments, then it outputs that number in the console. So we have our even number 4 output it in the console. But if you pass here 3, that number is not going to be an even number because it has a reminder, and this is going to return false. And because here you put the logical NOT operator, that is going to be switched to true. And the continue keyword is going to be called, and our code which comes below here, which is our variable even number counter, is not going to be incremented. And our number, respectively our number 3, is not going to be outputted in the console. So this is how this works. So this is our solution to our challenge. Of course, you can simplify this. So if you hover over here, because you have all of those underlines, you can see that it says remove redundant if statement. So this can be simplified to this. This does the exact same thing. It is going to return true if this divided by 2 has no reminder. Otherwise, it's going to return false. And this can be simplified even further, because here we have a single expression. And we know when we have a single expression, we can write our function as a single expression function. So we can remove the curly braces here. We can remove the Boolean return type. You can remove the return keyword. And you're going to put the equal here. And this, now if you run this code, this will work the same. So we have the same output here. Now, I use the function here because we've talked about functions in our previous videos. But you can remove the function completely and add the logic to determine if an even number is even or not directly in the if statement. So you can put here if, let's put parentheses, our number. Now we're going to use the modulus operator to is not equal to 0, then continue, and this will have the same effect. So if you run this code, this will work in the same way. So we have the same code here, because this does the exact that the function did previously. It will check to see if this is an even number. If this is an even number, this is not going to be true, because here we're checking to see if this is not equal to 0. And our number is equal to 0. So this condition inside the parenthesis is going to be false. The continue is not going to be called, and our code below is going to be called. Our even number counter is going to be incremented, and our number is going to be output in the console. So this does the same thing as previously. And we can do this challenge also with a for loop if you want. So you can type here for I in 1 to 20, then execute the code inside the curly braces, and here you can check if parenthesis again, if I %2 not equal to 0, then call continue, then else is gonna execute the code which comes below here, which is, let's first assign a value for to a even number counter to 0, because when we're gonna enter in the for loop, we should have 0 to not have the previous value, which was 20. So let's put 0 here, and here you can increment our even number counter ++, and we're gonna print our even number. So I'm gonna print I here. So if you run this code, let's run it from here. But let's add the println to make things more clear. So I'm gonna add here print. Let's put quotation marks, and here I'm gonna type total number of numbers found using for loop are, let's put the $sign. Now let's refer our even number variable. Now if you run this, now we have the exact same output, but now we're using the, first we're using the while loop, then we're using the for loop. So let's add a println statement between our loops to make clear which loop is looping. So let's add a println here, and let's type here now we are looping using the for loop. So now if you run this, it will make more clear which loop is looping. So now, as you can see, first the while loop loops, then we have our println, which says that now our for loop starts looping, then we loop with the for loop, then at the end we output the total number of even numbers found with the while loop. We have 10, then we output the total number found, the total number of even numbers found using the for loop, and R10. So our code works perfectly well. And this does not represent the best way to solve this challenge. Of course, that you can find a total different way, a better way to solve this. So this was just my way of solving the problem. So see you in the next video, and I hope that you enjoy this challenge. So now it's time to start a discussion about arrays. But first, let's create a new project. I'm gonna call it arrays. For the language, select Kotlin. For the build system, IntelliJ. Make sure to have the JDK selected, and check this little box, add sample code, to have the main function auto-generated for us, and click on create. Alright, now let's delete the code inside the curly braces of the main function. Let's hide the project pane, and let's start our discussion about arrays. And so far in our videos, we've only looked at how we can store only one single value in a variable. And that is very useful, but what if you have a large amount of values that you want to store in our variables? Let's say that you want to store 30 or 40 different values in our variable of a certain type. Of course that you can declare a variable for each of one of those values and then assign it to the variables. But what happens if you have 1000 or 20,000 values? In that case, it will not be practically possible to write each one of those variables and then assign a value to it. And Kotlin helps us here because it provides us arrays, and an array allows us to store more than one single element in a variable name. So it allows us to store more elements in one single variable name. Now, to declare an array, we type val. Here we type names. Next, we need to provide a type, and the type is going to be an array. And IntelliJ has given us some suggestions there, so press enter to fill in that for you. And now we put angle brackets, and inside the angle brackets we're going to put what kind of data this array is going to store. So it's going to store string or text or sequence of characters. Then you put equals, and here we don't type a literal value. Here we type a function call, and here we type array of. And now we put our elements inside the parentheses of the function call, separated by comma. So I'm gonna put 3 names here. So I'm gonna put John, Steven, and Megan. Now let's see what we have here. So first we have the val keyword. Next we have a name for our variable, and the name is names. Then we have the type, and the type is an array, which means that we can store multiple values in our variable. And next we have angle brackets and string, and this means that this array is gonna store text or sequence of characters. It's gonna store only strings. And then we put equals, we have the function called array of, and then we put our elements of type string, which is those names, separated by comma. But because Kotlin has type inference, here we can delete the type, and the type is going to be inferred in the same way it was inferred previously when you just declare a simple variable. So now the type is still inferred as an array of strings. And now is a good moment to introduce type hints, but we need to activate the type hints from settings. And to do that, you can go to File, and click on settings, or you can press the shortcut that we have here for our particular system, and for Windows is Ctrl Alt S. So I'm gonna press Ctrl Alt S, and here we go to, if you have something like this, you go to editor, click on this greater arrow in front of editor, and then you go down here where it says inline hints. Click on this greater arrow in front of inline hints, and from those options select Kotlin, and here you go to types and select local variable types, then click apply and OK. Now what we have here on the right of our variable name is a hint, so it's not real text. This is just there to remind us what kind of type this variable has, and in our case is an array of string. And my suggestion for you is to keep those scenes activated, because in this way you'll always see what type a variable is without explicitly declaring the type. So this is not this is just there to help us, to remind us what kind of type a variable is. Now let's say that I want to output a certain element in the array in the console. To do that, we cannot just type here println and pass names, because we need to be more specific than that. We cannot pass the array here. And to get a specific element in the array, you need to know that the elements in the array are stored at indexes, and the index of an array always starts at 0. So the first element is stored at the index 0. And to get the first element, we type here square brackets and we put 0. And that, if you press Shift Control P on it, it's a string, because that is gonna return us the first value in the array, which is John. So if you run this code, we get John. But let's put some text here to make it more clear that this is the first element. So let's type first element. Now let's choose the $sign, because this now is a placeholder, and let's put the curly braces around our element and the quotation mark here. Now if you run this code, you get first element John. Let's put here some. So we get the first element John, because John is stored at the index 0. And in the same way, John is stored at the index 0, Steven is stored at the index 1, and Megan is stored at the index 2. So our index starts at 0. The index of an array always starts at 0. And you can replace a specific element in the array also using the index operator. So you can type here names, again square brackets 0 equals. So now I'm gonna assign a new value to our element stored at index 0, which is now I'm gonna put here the value Alex. So now if you run this code, now we get first element Alex, because John, which is at index 0, was replaced with the value Alex. So now we have Alex, Steven, and Megan. But what you can't do is you cannot get an element at an index that doesn't exist. So we cannot get here, let's say, an element at the index 4, because if you run this, look what happens. We get an error which says array index out of bounds exception, index 4 out of bounds for length 3. That is because the index 4 doesn't exist, and here we try to access that value, and that value and that index doesn't exist. And this is called the runtime error, because this error is called only while our app is still running. So you don't have here an error like we have for here you don't have a compile error which you saw in our previous videos. That is because the size of an array is not known until at compile time. Also, it's very important to know here that the size of an array is fixed. So this will always have the size 3, and the only way to add new elements to it is to put the elements directly here, but there is not another way to, let's say that I can put another element in the array down here. We can only replace elements, and then in the next videos you're gonna see that there are other arrays which are more flexible in the sense that they can grow and shrink. We can add or remove elements from those arrays, but for now we're gonna look just at this array. So let's change this back to 0 to don't have that error. And to avoid this kind of errors, you can check to see what is the size of the array. In other words, to see what is the number of elements stored in array using the size variable. So let's do that. So I'm gonna add the println statement below of our first one. So I'm gonna type here println. And here I'm gonna put the text, the size of the array is. And here I'm gonna put the $, curly braces. Now I'm gonna use our names array. And here we're gonna put dot size. And this is gonna give us the size of the array, or it's gonna give us the, in other words, the number of elements which are stored in this particular array. So if you run this code, you're gonna see first output, the first element is Alex, and then you're gonna see the size of the array is 3. So we get first element Alex, and the size of the array is 3. And this is very important to note, that the size of the array is always 1 times greater than the last index in the array. So we have an array which starts as index 0 and ends at index 2, which has a size of 3. So it's very important to remember this to avoid crashes in your programming. And of course that you can put other data types in our array. So I can declare another array here, also val, called numbers, and we can use the array of again, and here I can pass some numbers, and now you see the type is an array of int, or an array of integers or whole numbers. And you can also mix types here, so you can put here numbers and strings. So now we have an array, and this, which is between our angle brackets, you don't need to understand this for now, but this allows us to have array of 2 types, respectively of type int and of type string. And you can put also a char here if you want. Let's say A. So you can create an array of any type if you want. So this allows us to mix our types in the array. And because we've looked at loops and how we can use loops, you can use loops to loop to this array. So I can put here, let's say that I want to use the first array, so I can put here for name in names. Now I'm going to refer our array of strings. Then print ln name. So now you see that we have this type hint for our name variable that we have here. Of course this can have whatever name you want. Now if you run this, you're gonna see our 3 names outputted down here in the console. So now we have Alex, Steven and Megan, because now we're using the for loop to loop through our array names. And this is interesting, but what if you want to loop through our array numbers, which is a mixed array? We have numbers and strings and chars. We can refer it here. Let's call it I in and now you see the type that was inferred for the I is this comparable that we have here. So this is gonna loop through our mixed array. So we put here I. Now if you run this, you're gonna see our numbers and then our name 1 and our char outputted down here. So now we get first element Alex, which is our println statement, then the next println statement, the size of the array, then we have our numbers in our numbers array, and then we have our name 1, and then we have our char. So this allows us to loop through our mixed arrays. But what if I want to output only if I want to output in the console only the integers in this mixed array called numbers? To do that, and this is a good way to introduce the is keyword. And with the is keyword, we can check to see if a literal or a variable is of a certain type. So I can put here if I is, let's say, an int, then and only then I'm gonna output its value in the console. Then I'm gonna call our println, and I'm gonna pass our I variable to our println function. Now if you run this, you're gonna see in our loop only the numbers here, only the integers, because this is keyword is checking to see if our I is of type integer, and this is gonna return true or false. In our case, it's gonna return true for all of our numbers that we have here. So we have 4, 5, 6, 7, and 4 again. And you can check to see if this is a char, and we're gonna see in the console only our single element A outputted down here. So we have A, or you can check to see if this is a string, this element that we're looping at this particular iteration, let's say. So if you run this, you're gonna see in the console only name 1, because only name 1 is of type string. So you get name 1. So this is very important to know that with the is keyword, you can check to see if a variable or a literal is of a certain type or if it's not, and based on that to execute some code. In our case, you output that value in the console if that condition is true. So this is how you can use the is keyword and the for loop to loop through our array, and the is keyword to check to see if an element in our array is of a certain type or if it's not. And let's change our array numbers to a different name, because numbers is very specific. It implies that we only have numbers in this array, but we have a mixed type, so we have multiple types in our array. We don't have only numbers. And to do that, instead of changing our numbers array in everywhere in our code where you're using this variable, we can right click on it, go to refactor, and click on rename, or you can click Shift F6. Now, if I change the name of our array numbers, it will be changed everywhere where you call this variable. So look, if I delete now the name is also changed in our line of code 9 we're using in the loop. So now if I change this to, let's call it mixed elements, if I press enter, now this will be also changed everywhere where we call our variable, respectively on the line 9 here. So now we have our array numbers changed to mixed elements, which is more descriptive because it implies that we have an array of mixed elements. So now it's time to do a challenge using the knowledge that we have about arrays. But first of all, I'm going to delete the code inside the curly braces of the main function, because I have the previous project opened. Now, the challenge is to create a function which is going to take as an argument an array of integers. Then you need to figure out a way to determine which number is the biggest number in that array. Then you need to return that number to the function. And you need to create another function which is gonna do the same thing, but is gonna figure out what is the minimum number stored in that array, and then it's gonna return that value. And third, you need to find a way to combine those two functions in just one function, which is gonna return the maximum value stored in that array if you want, or if you don't want, it will return the minimum value. So try to solve this challenge and then watch my solution. Now let's solve this challenge. So first I'm going to create a function which is going to be called find max. This function is going to return the maximum value, and it's going to take as a, and I'm going to define here a parameter and an array. So here I'm going to type a name for our array. It's going to be called numbers, and it's going to have the type array of integers, and it's going to return an integer. Now here I'm going to declare a variable. It's going to be a var, and it's going to be called max. And in this max variable I'm going to store the first value in the which is in the array. So I'm going to type here numbers, square brackets, and I'm going to use the index 0 to get the first value in the array. Then I'm going to loop through this array. So for number in numbers, then here we're going to check to see if our number is greater than our first value which was stored in the array, our max value. And if that is true, then we're going to store this value, which is now greater than our maximum value, in our max variable. So here I'm going to put max. Now it's going to be equal to this number, which is found to be greater than our previous max value. And at the end of this loop, we're going to return the maximum value. And we're going to do the same for find the minimum value. So I'm going to copy this code. And this is going to be called find min. But here we're going to change a little bit the logic. Let's call this variable min. And here we're going to change the condition to less than min. Now let's call those function in our main function, and let's pass some arrays to see how it works. So first I'm going to declare a variable. It's going to be a val, and it's going to be called max. And now I'm going to call our find max function, and here I'm going to pass an array. And I'm going to pass the array directly here. So I'm going to type array of, and I'm going to pass some arbitrary numbers like then I'm going to declare another value. This is going to be called min. Now I'm going to call find min, and here I'm going to also call our array of function, and here I'm going to define some arbitrary numbers again. Now I'm going to output those values in the console. So I'm going to add println here. I'm going to type max value is $, and I'm going to refer our max variable defined above. Another println. Now if you run this code, get max value 7, which is correct. This is the biggest number. and then we get minimum value is 4, and this is also correct. So our code works perfectly well. Now the next thing is to combine those two functions that we have here. Let's decrease this. Now you need to find a way to combine those functions in one single function, which is gonna also return the maximum and minimum value, but only if I want to return to be returned. So I can determine if I want the minimum value to be returned by that function, or if I want the maximum value to be returned by that function. So I need to find a way to combine those two. And to do that, I'm gonna delete our second function. I'm gonna delete the code inside this function, and I'm gonna change the name of this function to find min and max. And now here I'm gonna define a parameter which is gonna be a boolean, which is gonna have a boolean type. So I'm gonna call it search max, and it's gonna be a boolean. All right. Now, based on that boolean value, if it's true, if I want to search the maximum value, here I'm gonna type an if statement. So I'm gonna put if search max, then I'm gonna add here the code to search for the maximum value. But first, let's define a variable here. It's gonna be also var, and it's gonna be called max, and it's also gonna have the first value in the array, which is as the index 0. Now, if our search max is true, then we want our maximum value to be searched and returned. So I'm gonna add here to the code to do that. So I'm gonna type here a for loop, which is gonna go through our numbers array. And here I'm gonna add the if statement, which I'm gonna check to see if our number is greater than our max. Then I'm gonna assign our number to our max. Now I'm gonna go down here, and here I'm gonna add the else part. So if this argument which is passed to our parameter search max is false, so I don't want to search for the maximum value, then that means that I want to search for the minimum value. So I'm gonna put here else. Now I'm gonna add the code to search for the minimum value, and for this we need to define also a variable here. It's gonna be called min, and it's gonna have the value of max. I'm gonna explain in a minute how this works. Now here we're gonna also loop in our numbers through our numbers array, and here we're gonna check if essentially we have the same code that we have in our find min function. So here we're gonna search if our number is less than our min, then we're gonna assign our number to our min. Also, we need to return this value at the end of our loop. So here we need to return max, and here we need to return min. Now let's press Ctrl Alt L to format the code. Now let's delete the code that we have here. Let's delete also this code. Now I'm gonna put our find min and max function directly in the println statement. So I'm gonna type here or to put in a variable first. So let's put in a variable first. So I'm gonna define a variable. It's gonna be also max, and here we're gonna type find min and max. Now here we need to pass an array first. So we need to call our array of. We need to define some numbers here. Let's say 20, 40, 50. Now we need to pass an argument to our parameter search max, which is going to be either true or false. So first I'm going to pass true here. Now if we print this value, if you output this value in the console, let's say that we type here the max equals to $, I'm going to refer our variable. Now if you run this code, we get the maximum value is 100, which is correct. Now let's duplicate this code that we have here. Let's try it for the minimum value. Let's call it min. And let's add the println statement down here. Let's type the min value is $min. Now if you run this code, and let's pass here false. Let's run this code again. Now we get the maximum value is 100, which is correct, and the minimum value is 20. And we did this with our find min and max function by combining our two previous functions. And our code until now works okay. Now it's time to have a discussion about how this solution to my challenge works. So now let's see how our logic inside our find min and max function works. So first we declare our function find the min and max. Then we declare two parameters, which is one is numbers and is of type array of integers. So here we're gonna pass only an array of integers. And the second parameter is called search max and is a boolean. So we can pass here only true or false. Then we're gonna say then we say here that this function is gonna return a value. Next, on the line 9, we declare a variable which is called max, and we assign using the index operator the first element in the array in our max. So in this case we assign 20 in our max variable, and then we declare another variable called min, and we assign our max in our min, but our max has the value of 20 because we assigned it here. So this variable min is also having the value 20. So both have the value 20 at the start. Then we check to see if our search max parameter is true or false. And if it's true, then we're going to execute the if part. And the if part works in the following way. First, we loop using the for loop through our numbers array. Then we check at each iteration if our number, let's say if 20 is greater than our max. So if 20 is greater than 20, which is going to be false. So the code inside the curly brace of the if is not going to be executed. Then we go for the next iteration. So here now we're going to check to see if our number, respectively 40, is greater than our max, which is 20. And this is going to be true. And because of that, the code inside the curly brace is going to be executed. So now we're going to assign to our max, which is now is 20, our number, which is 40. So now our max variable has a value of 40. And we're going to do the same thing for the next, for the 50. So this condition is also going to be true. So we're going to assign to our max 50, and so on, until it reaches 100, which is going to be also true. This condition is going to be true, and we're going to be assigning 100 to our max value. Of course, if we had another number here, let's say 2, it's going to loop for that number also, and this condition is going to be false for that because our number 2 is not going to be greater than max. And it's going to exit the loop, it's going to terminate, and it's gonna return the maximum value, which is 100, like we saw in our output in our console. And at this point, when we return our max value, the function is lived, so it's not executing any line of code besides our return max. It's not going to execute the subsequent code which comes below. But if our search max is false, it's going to execute the else part. So in this case, it's going to search for the minimum value. So here we have the same for loop. We search, you go through all the numbers, but here you're not checking to see if our number is greater than max. Here you're checking to see if our number is less than our minimum number. So you check to see if our let's take 20 first. You check to see if 20 is less than our minimum value, which is 20, and that is gonna be false. So this code is not gonna be executed inside the curly brace of the if, and it's gonna loop again. And now it's gonna check for the 40, and that's also gonna be false. So and so on until it reaches 100, which is also gonna be false. The loop is gonna execute and it's gonna return 20. Of course, that if we put here 2, let's say, now the minimum value is gonna be 2 because it's gonna loop for another iteration, and now one is gonna compare to see if our number, respectively 2, is less than our mean, which our mean previously was 20. That is gonna be true, and it's gonna assign our 2 to our mean. So if you run this code now you're gonna see that the minimum value is not 20, but it's 2. And after that, we return this value to the function which is called. So now we get the minimum value is 2, which is correct. So this is how this code works. And see you in the next video. So now it's time to start a discussion about object-oriented programming, and particularly in this video, we're gonna look at classes and objects. But first, I'm gonna create a new project. I'm gonna call it OP. For the language, select Kotlin, and for the build system, IntelliJ, make sure to have the JDK selected. And also, I'm gonna check this little box because this add sample code is gonna add the main function and that code for us. So I'm gonna click on create to create the project. Now I'm gonna delete this code, and I'm gonna hide the project pane. Now, what is object-oriented programming? Object-oriented programming is a way of writing code, in a sense, in the way we think about the real world. So, in the real world, we have objects which can interact with each other and which can do stuff. But the objects in the real world have two major characteristics. First is the state. So the state of an object in real life is represented, let's say that we think about of a car. The state is represented by the color of that car, by the number of gears that car has, by the brand name of that car. So this is the state of a car. The next thing that real life objects have is functionality. So objects can do stuff. So let's take again the example of a car. A car can move, a car can stop, a car can switch gears. So objects in real life have those two characteristics, those two major characteristics represented by the state and the functionality. And the aim of object-oriented programming is to construct objects using code in the way they are in the real life. But to do that, let's say that you want to build an actual object in real life. What you first need to do? The first thing that you need to do, you need to create a template or a construction plan for creating that object, in which you're gonna define the generic things that a car has. And in programming, you will do the same thing, but instead of using a piece of paper or something on your PC to draw that template, in programming you're gonna use a class. So the class is used to create the template, which then is gonna be used to create an actual object, an object which is gonna have a specific state and a specific functionality. So in a way, you can think that the real world serves here as a model for us to write code. And in this way, by combining the state and the functionality in one entity and have an object, and as you can see, you can also have, like in the real life, objects communicating with each other. You're gonna see that this is really powerful, because you can model your code in a more dynamic, in a more creative way. So this is what we're gonna do next. So first, let's say that I want to create an object of type car, and to do that we go down here and we need to define, as I said, the construction plan, the template for building an object. And in this case, we're gonna build the car object. So we're gonna define what is called a class, and we type the keyword class. Now we need to name our class. I'm gonna call it car, and the name of the class should start with a capital letter, and if it has multiple words, it should be in Pascal case. Then you put curly braces and press enter. Now inside the curly braces, we need to define the state and the functionality, as I said, for the objects that are going to be built with this template. And to do that, we need to use variables first for the state, or in the context of object-oriented programming, and more specifically in the context of classes. They are called classes and objects. They are called properties, and we define them like we define a simple variable. We type var, and the first thing that a car has is a name, a brand name. So we're gonna type name, but we cannot keep this variable uninitialized. We need to provide a value to it, and I'm gonna put an empty string for now. So it's gonna have the default value, an empty string. The next thing is the model, what kind of model this car is. So it's gonna be also a string. I'm gonna assign an empty string. The next property is gonna be called color. It's gonna be also an empty string. And the next property is gonna be called doors. So this is gonna store the number of doors that a specific object which is gonna be built with this template is gonna have. And we're gonna put 0. I'm gonna put 0 now. Now we need to define some functionality for this class and for the objects, and implicitly for the objects that are gonna be built with this class. And I'm gonna add 2 functions. First one is gonna be called move. It's not gonna take any parameters. It's gonna just output some text to the console, which is gonna say that the car is moving. So we put quotation marks. The car is moving. Now I'm gonna define another function called stop. Also, it's not gonna take any parameters. It's gonna just output some text to the console. It's gonna say that the car has stopped. Now we have the template. We defined what our car is gonna have. Now we need to create an actual or object, an actual and specific object using this template. And to do that, we first need to declare a variable, and it's gonna be a val, and I'm gonna call it car1. So our object is gonna be stored in this variable car1. Then we put equals, and we type car, and now we have some suggestions, and we have our car that we define below, our car class. So we press enter, then we put parentheses. So now we have created an actual object, a real in the programming sense, and but now this actual object was also, this is called instantiation, because we created an actual instance, but we don't need to bother with these names for now. So we created an actual object using this template that we have below, but the properties of these specific objects are those properties that we define here, those default properties. And to define some specific some specific values to these properties that this car object that we created has, we need to type car1 dot. So this is called informally dot notation. And now we have some suggestions. So we have our properties that we define for a car. And now we type car1 dot and we choose the name. And now I'm going to assign a value to this name. I'm going to be called Tesla. So now our car1 object that was created has the property name Tesla. Now we do the same thing for the next property, for the model. car1 dot model. Press enter. And we put here as played, so the model. Next we also type car1 dot. Now we're gonna assign a value to the property color, and it's gonna be red. Next we type also car1, and we define for the property names, for the property doors, also a value. So we're gonna put here 4. So now our object car1 has for its property some specific values. Respectively, have for the name Tesla, for the model as played, for the car, for the color red, and for the doors 4. So now let's output the property values of this object that we created in the console. And to do that, we put our println function down here. We put quotation marks inside the parentheses because I'm gonna add some text here. So I'm gonna type name equals, we put $, then we put curly braces, and inside the curly braces we type car1 dot name, and this is gonna return the value of the property name for the car1 object that we created. Respectively, it's gonna return Tesla. Let's press Ctrl D 3 times to do the same thing for the next properties, and here we put car1 dot model, so this is gonna return the value of the model property. Here we're gonna put color, and here I'm gonna type doors. Now if you run this code, we get name Tesla. Actually, let's change the text here to model to match the property name. Model color and doors. So now if you run this, we get name Tesla, model as played, color red, and doors 4. And those are the values of the properties of this object that we created here with our template car. Next, what we can also do, because in the class we defined 2 functions, we can call those functions on this object that we created. And to do that, we also use the dot notation. We type car1 dot move, and this is gonna call the move function, which is inside the car1 object. Let's also type car1 dot stop to call the stop function. So now if you run this code, we get the values of to our properties, and then we get the car is moving and the car has stopped. So car1.move and car1.stop is calling the functions on this object that we created here. Now let's also add inside the functions the name of the car that is moving. So to do that, we put here $sign inside the class, and we type name, and this is gonna reference this property name that is defined here. And let's also do the same thing for the stop function. Let's type name, and now what this is gonna do, because those functions are they are living inside this object that we created here, car1, and this object has the name Tesla. When those functions are gonna be called, they're gonna say that the car and the name of the car, which is in our case for our object is Tesla, is moving, and then it's gonna say the car again Tesla has stopped, because they are called on this specific object that we created, which has those specific values for its properties. Alright, so now if you run this code, we get as expected the car Tesla is moving and the car Tesla has stopped. So the functions are called on this object that we define here, and it's using the property values that we define for this object. But as I said, with you can create as many objects as you want using the same template. And let's do that. Let's create another object. So I'm gonna type here val car2. Let's put equals. We type car and then we put parentheses. And this creates now another object, but we need to define some values to its properties, because now the values for the properties are the default values that we define inside the class, respectively the empty string and the 0. And to do that, we type here car2 dot name. So now we are calling the properties for the car2 object, and now we define some values to the properties of the car2 object. So they are this here is not overriding the value that we have here, because this thing that we have here, it's a distinct object in memory from this object. They are distinct objects, and they have their own properties with their own values and their own functions. And now let's put here Ford. Let's put car2 dot model. Let's put Mustang. Let's put car2 dot color blue. And for the doors, let's put 2. car2 dot doors equals to 2. And let's output those values in the console. So let's output the values of the properties for this second object that we created in the console. And to do that, I'm going to copy this code. I'm going to paste it below here. And now I'm just going to change the variable to car2 to call the properties on the car2 object. So we put here car2. So now we're calling the properties values on our car2 object. And now if I run this code, now we get name Ford, model Mustang, color blue, and doors 4. And the first part is from our first object, which is name Tesla, model is plate, red, doors 4, and the car Tesla is moving and the car Tesla has stopped. But let's add a space here to make clear that this is the output for the second object, to make things more clear. And to add a space, we put here a println statement. We put quotation marks and we put a backslash n, and this is gonna add a space between our println statements. So it's gonna add a space between those statements and those. So now if you run this code, let's increase this. We get name Tesla, so this is our first object, model is plate, color red, doors 4. The car Tesla is moving because we're calling the functions on the first object, and the car Tesla has stopped. And then we get name Ford, model Mustang, color blue, doors 2, and we have our space because we put here this backslash n, which adds that space for us. Let's decrease this, and let's also call the functions, the move and stop functions, on the second object. So I'm gonna type here car2 dot move and car2 dot stop. So now if you run this, let's right click and just click on run main.kt. Now we get our first object, which is with its value for the value for its properties, and then we get the two functions called on our first object, and we get then our second object with its values for its properties, and then we get the car Ford is moving and the car Ford has stopped, because now we're calling the functions on this second object, and this second object has the value for the properties, has different values for its properties. So this is why we get the car for is moving and the car for has stopped. Again, they are different objects, they are distinct objects created using the same template, the same construction plan. And I'm gonna end this video now and see you in the next video. So in the last video we saw how we can create a class, and then how we can define some properties and some functionality to that class. Then we use that class to create two objects, and then we defined for those objects, for the property of those objects, some values. But the way we define values to the properties of the object is to call the object and then the property of the object, and then we assign a value. And this is okay, but if you have more than 4 properties, let's say you have 20 or 100 properties, that will be very tedious to write each one of them and then assign a value. And a better way is to use what is called a constructor. And as the name implied, the constructor is used to construct the object, and the constructor is called at the time when we create a new object. So at the time we type this line of code, when you finish to type this line of code, the constructor is called immediately. So that is the time where we need to pass the values to our properties. And to do that, we go down here where we define our class. We put at the end of at the end of the name of the class, we put parentheses, and here we define some parameters, the way we define parameters for functions. And the first one is going to be called name. It's going to be a string. The second one is going to be model, also a string. The next one, color, also string. And the last one is going to be doors, and this is going to be an integer. Now we need to assign whatever values passed to those parameters to the properties of the class here. And to do that, we just delete the empty string here and we'll type name. And as I'm typing, you see that we have name and it has this P, and this P stands for parameter. So it's saying, do you mean this parameter that we define up here? And we press enter to fill that for us. Then we type here model, color, and then doors. Now if you go up here, we have some errors, because now when you create the object is expecting for its constructor some values. So if you hover over here inside the parentheses, it says no value passed for parameter color, doors, model, and name. So if you look down here, you see that it has this public constructor. So now what we need to do is to pass the value that we passed down here to the properties by calling them on the object, is to pass them directly in the constructor, and then the values, the arguments if you want, are going to be assigned to the properties. So I'm going to put here, and you have this hint name, Tesla, then we put a comma. So we have again the hint, which is very helpful. So for the model we put displayed, and then for the color we put red, and for the number of doors 4. Alright, so now this is more concise, and now this is doing the exact thing that we did previously, but this is more concise, and we're using the constructor to pass those values to the parameters that we define here, and then those parameters are going to be assigned to the properties, respectively those properties, name, model, color, and doors. You're going to see what is the difference between the properties and parameters in the next video. Now we have also an error here, because this also expects some values to its constructor. So instead of putting those values here, we put up here Ford, Mustang, blue, and 2. Now we can delete this because we already passed the values for this second object for its properties. And now if you look at the code, the code is more concise and more and easier to read. Now if you run this code, you will have the same output because the code works well. So now if you look at the console, let's decrease this a little bit. Let's scroll up. You have the name Tesla, model is placed, color red, doors 4, the car Tesla is moving, the car Tesla has stopped. So we have the same output as previously. And down for the second object, we have the name Ford, the model Mustang, the color blue, doors 2, and the car 4 is moving, and the car 4 has stopped. So our code works well. Now let's close the console. But if you go down here, you will see that you have this the properties color. So if you hover over them, it says the property is explicitly assigned to a parameter name, so it can be declared directly in constructor. Now what is saying here in other words is that we can put the properties directly in the constructor, so you don't need to define the properties down here and then assign the value that is passed to the parameter to the property. And the difference between the properties and parameters is that the properties, respectively those that we define in the header of the class inside the parentheses here in the constructor, is that the properties are not storing the state of the class. They are not storing the state of the object. They are only here to get whatever value we pass here. So whatever value you pass here, and its job is to only get that value and assign it to the property name. So only the variables which are declared inside the class are storing ultimately the state of that object. So if I delete, let's say if I delete this here, now we have an error here because the property name it says on unresolved reference name, create member property car.name, and that is because the property name is not declared. It's not existing. It's not a characteristic of a car. We didn't define property name because here the parameter name is only there to get the value and then pass the value to the property. But we can let's press Ctrl Z to put the code back. Now the error disappears because we have the property declared, but because the only thing that we do here is to get the value that is passed to the property as an argument here and for the next ones, and then assign it to the property, we can put those directly in the constructor. So to do that, we can hover over here and let's hover over and click on this light bulb and click move to constructor. So now you have this, you have the same thing, but the only difference is that you have this var keyword in front, and that is responsible for changing the parameter into a property. So let's do the same thing for the next ones. Move to constructor, and now we don't have that error that we don't have a property for our class because they have the var. So if you put the var or the var keyword before declaring the parameter, it is going to be converted into a property. So now those are properties of our class car. So they are storing the value that we pass to them for the object that we create. So it's not like previously where we have the property, the parameter, and then the value is passed to the property inside the class. So now if you run this code, we have the exact same output. the only difference now is that this is more concise. We have the properties declared directly in the constructor, so we don't have declared the parameters and then we assign the value that is passed to those parameters to the properties. So you can declare the constructor like this if you want. So the question may arise when to use properties and when to use parameters. And to answer that question, you need to have in mind that if you want to do some work before you assign the value to the property, because in our case the value that is passed here to the property in this case is directly stored in the property, so we cannot add some validation to check to see if I don't know if this name is if it starts with a specific letter or if it's an uppercase, or because the value that is passed as an argument to the property there, I say property because they are not declared as properties, is directly stored as the state of the object. So if you want to do some work before you assign the value of the property, you need to declare it. Let's say that you want to, let's actually delete this, and I'm gonna declare it as a parameter. So let's say that you want to trim the space that is passed. So let's say that I put some spaces here. Let's actually press Ctrl Z to see what is happening if I don't do that. All right. I pressed Ctrl Z too many times. So let's again let's put some spaces here. So now if you run this code, let's run it again. Now, because the value that is passed as an argument here to the object car1 is passed directly to the property, so it's stored in the property and we don't do nothing with it. We have also the space, but if you want to delete that space, currently we can do that because the values pass directly to the property and there is nothing that we can do from that point. And to change that, we can declare the property that is defined here, the property name, as a parameter first, and we can declare it down here. We can declare down here now the property, and we can put equals, and now we pass the parameter to the property, so we assign name here. But before that value is assigned to the property name, we put dot trim, and that is going to remove the spaces. So dot trim is a function which is part of the string class, because all the data types that we looked at are also classes, so you can call functions on them the way we called functions on our objects. So name.trim removes the space, so in this case it removes the space that we have here, and after that it's assigning the value to the name property. So now if you run this code, now we have the space, but if you run the code, so let's go up, run the code. Now, as you can see, the space is removed because we pass the value to the parameter now name, then the parameter name trims that space, and after that it's assigned the value to the property name. So in this case, this can be a scenario where you can declare instead of declaring directly here the property, you can declare it as a parameter. But what we can do if you want to add more code than just one line of code, in that case we'll need to use what is called initializer blocks. But we're gonna look at the initializer blocks and at other things in the next video, because this video is long enough. So see you in the next video. So in the last video we looked at constructors and how you can use constructors to construct your objects, and it was an alternative to defining the values to the properties of a particular object. And we've also looked at how you can define this was, I should say, it's also called the primary constructor that we have here, the parentheses and then the parameters or the properties. And we've also talked about how we can define parameters to our constructor, and then how we can convert those parameters directly into properties. And I also talked a little bit about how and when to use parameters and properties. But in this video, we're going to continue our discussion about parameters and properties, and specifically going to look at how we can execute more than one line of code when the object is created. Because now when the object is created, and in the last video we trimmed this space that we have here, here we can execute only this line of code. So if you want to add more line of codes here to do some to do a more complex validation, we can't, because here we can put just one line of code. And to add more than one line of code, we need to use what is called initializer blocks. And initializer blocks are, as you'll see, some blocks where we can put our code, and you can put more than one lines of code. You can put as many lines of code you want, and that code is going to be executed when an object is created, when an instance of your class is going to be created. So this is what we're going to do in this video. Also, I should say that you can declare the class in another file, not just in this file like we did here. So we can open now the project pane. You can go to src, go to main, go to Kotlin, and here on Kotlin you can right click, select Kotlin class file, and from here make sure to select file, and I'm gonna call this file classes, because here we're gonna put our classes. Respectively, we're gonna put our car class, but you can put more classes there. And we're just gonna copy this class that we define here, Control C, and paste it here. Now I have an error because this is declared 2 times, here and here, and we just delete it from here, and now the error disappears. And if you run this code, we get the same output, because our code works perfectly well now. The only difference is that now we put our class in a different file, and my suggestion for you is to put the class, if you want, in a different file, because in this way you have the code in a more organized way. Because here you have your class, here you have the code, the objects that you create with that class, and so on. Now, for this video, I'm gonna create a different class, and to do that, I'm gonna declare another class, but I'm gonna declare it down here, and I'm gonna delete the code that we have here, because we're gonna use a different class. And the class is gonna be called user, so it's gonna represent the end user object. So we type here class user. Now we create the constructor, the primary constructor. We put parentheses. We define the parameters or the properties. For now, I'm gonna define directly the properties here. So we type here the var or the val keyword to have the property declared. Var name string, so it's gonna be stores text. Var last name, also string, and var age, this is gonna be an integer. So with this class, we're gonna create some user objects. We're gonna put curly braces, and for now we're not gonna put any code here. So let's create an user. So let's type here val. Let's call it user. You can give it whatever name you want. So let's create a new object now. So we type here user, and then we put a parenthesis, because we're gonna pass the values to the constructor here. So we need to pass a name. I'm gonna type Alex, last name 𝐁𝐞𝐬𝐭, and for the age 23. So now we created a new instance, a new object using the class that we define below. But what if I want to pass to the name property only the names which starts with the letter A? In that case, we need to declare this property as a parameter. First, we need to declare here the parameter, and then to declare the property below. And before we assign the value that is passed to the property, we need to do some validation. And if that argument that is passed to the parameter is starting with the A letter, then we're gonna assign the value to the property name. Otherwise, we don't do that. So to do that, we need to use initializer blocks, because we're gonna type more than one line of code. And the initializer blocks are used in conjunction with the primary constructor. So when we create a new object, like we did here, the initializer blocks or the initializer block is gonna be called immediately when the object is created. And to use an initializer block, but first let's declare, let's change this to a parameter. So let's delete the var keyword in front of the variable. So now we have only a parameter here. Now let's declare the property down here. And now here we need to define an explicit type declaration. So we need to put here the type string, because as I said, we're not gonna assign the value to the property directly here in one line of code. We're gonna assign the value to the property inside the initializer block after we do the validation, respectively after we check to see if the name that is passed to the objects that we're gonna create with the class starts with the letter A. And if the argument doesn't start with the letter A, then we're gonna assign an empty string and we're gonna output something to the console. So this is why we need to provide here the type, because we're not gonna assign the value directly here, so it cannot infer what kind of data is gonna store. Then we press enter, we type init, and here we have a suggestion. We have the init keyword, and then we have the curly braces. Press enter. And now here we're gonna add our validation. And here we type if, parentheses. Now we type name. So now we're referring the name parameter defined above here. So if name, or the value that is passed to the name parameter, first we're gonna lowercase that name. And to do that, we type here name dot lowercase, because I want to have both cases. So if the user passes, let's say, a name with a lowercase letter, then we're gonna check to see if it starts with A. But if the user passes the name with an uppercase letter, we also want to check to see if that letter starts with A. And to cover both cases, we lowercase the input. We lowercase the name, so we lowercase all the letters. Then we put here another dot, starts with, and we put here A. And if that is true, then we're gonna assign whatever value was passed to the name parameter to the name property. And we cannot type here name equals name, because now it's referring the parameter here. And to refer the property that we define here, we need to use what is called the this keyword. So the this keyword is used to refer the properties of the class. So we type here this. So we're saying this name. So now we have this name, and we have we have this v variable here. Then we put equals name. So now we assign the value that is passed to parameter only if that value passed to the parameter starts with the letter A. Then we're gonna assign the name to the property name. Else, if that is not true, put curly braces. And now we need to cover the else part, because if this is not true, we also need to pass a value to to the name property. The name property cannot stay without a value, so you need to pass also a value here. Else we're gonna put this dot name, and we're gonna put user. So I'm gonna put the user text if the name doesn't start with the letter A. And we're gonna also output some text to the console. So we put println here, and we type the name doesn't start with the letter A or capital A. So now if you create a new object here, so we type here val, let's say friend, we create a new object, so we type user. Now we need to pass the values to the constructor, so you put here let's say John, let's put Smith, and let's put 30. Now, because the value that you pass here to the parameter name doesn't start with a letter A and start with the letter J, this validation inside the initializer block is gonna be false, and then it's gonna execute the else part, and it's gonna assign to the property name the user text, and it's gonna output the name doesn't start with the letter A or A. But if that is not, if it's true, if it starts with the letter A, then this line of code is gonna be executed, the if part, and it's gonna be assigned. It's gonna assign the value to the property. So now if you run this code, we get the name doesn't start with the letter A or A, and it's correct. Our name starts with the letter J. So if I put here, let's say Andra, let's change this to let's say also Smith. Now if I run this, now we have no output because the initializer block is called, and the if part is evaluates to true, and it's assigning the name Andra to our name property. So let's add the print ln down here to see that that is correct. So let's print the value of the property name for our friend object, and we put here and here we type $, we put curly braces, and we type friend dot name. So now if you run this, let's close. Get name Andra. Let's put comma here. Let's put colon here. So our initializer block is called, the code inside the initializer block is executed, and then this if check evaluates to true, and then it assigns the name Andra to our property name. But if I put here John, let's type it like this, let's say, to see that it's working, because we lowercase the letters. We get the name doesn't start with the letter A or A, name user. So the initializer block is executed immediately when the object is created, and the code inside the initializer block is called. It checks to see if it starts with the letter A, and if not, then it is assigned to the property name user. So we have this is why we have user here, and then it outputs this text to the console. So this is how we can use the initializer blocks in conjunction with the primary constructor, and you can also put more initializer blocks, and the order in which you put the initializer blocks matters, in the sense that the order in which you define the initializer block is going to be the order in which they are executed. So the order in which you define them is important. But most of the time I think you use only one initializer block to put your code. So this is our discussion about initializer blocks, and in the next video we're gonna look at because we talked about the primary constructors, there is another type of constructor which is called the secondary constructor or the secondary constructors. And we're gonna also look at the default parameters, because we can define default values to the properties or to the parameters of the constructor. So we're gonna do that. We're gonna do that in the next video. I'm gonna end this video now. So now it's time to start a discussion about secondary constructors, because besides our primary constructor that we define and that we talked about, in Kotlin we can define multiple constructors, and those are called secondary constructors. Now you may be wondering why you will need secondary constructors. And to answer that question, we need to consider the user class and the user objects that we can create. So let's say that a user only provides its first name, and for the properties last name and age doesn't provide any value. In that case, you will need a way to define some default values for those properties in case the user only provides the first name. And if let's say the next user does provide the first name and the last name and the age, in that case you're gonna use the primary constructor. But if it doesn't provide those values, then you're gonna use the secondary constructor. But to make this more clear, let's add the code, and we talk about while I am writing the code. So let's delete the initializer blocks that we have here, because we don't need this code. And let's also put the property now. Let's define the property in the primary constructor. So let's just put here a var, the var keyword in front of the variable. Let's also delete this println. And let's delete the values here for the last name and the age. So now, as you can see, we have an error because it's expecting here it's expecting an argument, a value for the last name and for the age. And to solve that problem, we just go down here and we type constructor. So this is the keyword for declaring the secondary constructor. And we press enter to fill in that for us, and we put parentheses. And now here in the parentheses we define the parameters, and I am specifically saying parameters because, as you will see, the secondary constructors cannot declare properties. They can only declare parameters because anyway, let's define here the parameter. So I'm gonna type here name. Let's put here the type of this variable is going to be a string. Now, if you hover over here, it says primary constructor call expected, insert this call. So what all the secondary constructors need to do is they need to call the primary constructor, because ultimately the primary constructor is the one which declares the properties for the class and stores the values of that property. And to do that, we put here colon, we type this, so we put colon, this, type the this keyword, then we put parentheses, and to the this call we pass the name, so this name that we define here. And for the next two values, we're gonna pass some default values. So here I'm gonna put user, because let's say that because as I said in the beginning, this user is not gonna provide the last name. So let's put here last name, not user, last name. And for the age, let's say 0. All right. Now, what this is gonna do is, now if you look up here, you don't have an error. So let's so now we don't have that error, because now it's using the secondary constructor, is passing the value here Alex to the secondary constructor that we define here, and here we define only the parameter, and the value that is passed to this parameter then it's passed to the primary constructor, because by putting colon and this and parentheses, we're calling now the primary constructor. And is the primary constructor the one which ultimately declares the property and stores whatever value we send to him. In this case, we send the value Alex, and for the last name we just send the text last name, and for the age we put 0, because this is our way to saying that this user doesn't want to provide its age. So this is why you need to call the primary constructor from the secondary constructor, because again the primary constructor is the one which ultimately declares the properties of the class, is the one which stores the properties of the class. The secondary constructor only takes parameters and then calls the primary constructor. So in fact, if you put here the var keyword, you have an error which says var on secondary constructor parameter is not allowed. That is because the secondary constructor cannot declare properties, only the primary constructor. And because, as I said, we can declare multiple secondary constructors, we can type here constructor, so we can declare another secondary constructor, and here we can put name, here we put string, then we type last name, also a string. So this secondary constructor is only gonna take the name and the last name as arguments. The age is not gonna, this secondary constructor is not gonna take any value for the age. Now we need to put colon. We type this, parentheses, because now we're calling the primary constructor, and here we pass the name that is passed to this secondary constructor, this that we define here, the last name, and for the age we're gonna put 0, because this secondary constructor doesn't take any value, any arguments for its age. But because, as I said, ultimately the primary constructor is the one which defines the properties, we cannot call the primary constructor and not pass any value. So we pass this default value here, and so now if you go up here and let's say that I delete the age, now our code works fine, because now what is happening here is this the value for the name and the last name is passed to this secondary constructor, this one here, and the secondary constructor then calls this primary constructor, and it's passing the two values to the primary constructor, name, respectively this name John, and last name Smith, and for the age it passes the default value 0. So this is why we can pass here this is why you can avoid here to pass let's say you can avoid to pass the last name and the age for the first, because here is using the first secondary constructor, and this object that we created here, it's using this secondary constructor, because here we're passing only the first name for the a value for the first name property and a value for the last name property. So it's passing them to this secondary constructor, which then in turn calls the primary constructor. It passes them to the primary constructor, so it passes the values for the two properties, and the last one is defaulted because you don't provide a value for the age. With secondary constructors, you can also at the end of the call of the primary constructor, you can put curly braces to have some code executed when you create an object with that specific secondary constructor. So you can put here curly braces, and inside the curly braces you can have some code which is going to be executed when you create an object with this, let's say, secondary constructor, when you create an object with this secondary constructor. So it's up to you what code you put there. But to illustrate this, let's put a println statement here in this secondary constructor. So let's type here println, and here I'm gonna type second, and I'm gonna type second because this is the first constructor, this is the primary constructor, and this is the one which ultimately does all the work, is the one which stores the value for the properties, and this is the third constructor. So let's copy this, let's put here third, just for illustration. Also, let's output in the console the value of the property values for these objects. So let's type here println, and let's type here name equals, let's put $, let's put curly braces, let's use our user variable. Now let's call the properties on this object. So let's type name. Now let's press Ctrl D 2 times, and let's put here now last name and age, and let's also add a space between the information about the two objects to make things more clear. So let's put a println here, let's put a \n here, and let's copy the code that we have here. Let's paste it below. Let's change this object to our friend object that we created. So let's type here friend, and I'm gonna speed this now a little bit because it will take some. Now let's output this information in the console. So now what we have is we have second and then third, because this first object is using the second constructor. So this is why we have here second, and then the next line of code is called, and we have third because this object that we have here, the friend object, it's using the third constructor, this secondary constructor. So this is why we have here third. Then we have the values for the properties then we have the values for the properties of the user object. So we have here the output down here, and then we scroll down and we have name John, last name Smith, age 0, because we have the property values for the second object, for this object, and this is okay, this works completely fine. The thing to have in mind is that now we're using the secondary constructors, and the secondary constructor then calls the primary constructor, and the primary constructor is the one which ultimately stores the values, which ultimately declares the properties and stores the values. But one thing to notice in the output is that the first object has the name Alex, and the last name, and the age 0. That is because the first object is only taking a value for the first name property, or for the name property, and for the last name and the age, because it's using this secondary constructor, it's only passing the first name, which is Alex, that we have here, and then it's using the default values, last name and 0. It's passing those default values to the primary constructor. So it's calling the primary constructor, it's passing the value Alex, and then the default value last name and 0. This is why I have last name and 0 here. And for the next one, we have name John and last name Smith. This is because now this is using the next secondary constructor, and that takes as arguments the name and the last name, and then it's calling the primary constructor. It passes the first name and the last name, and the age is defaulted, so we have 0. So this is why we have here John and Smith and then 0. So it's important to notice this and to think about how to think about this thing. So this is our discussion about multiple constructors, respectively about secondary constructors. In this video you saw how we can pass a different number of values to our properties. Ultimately you pass all the values to the properties by calling the primary constructor and providing default values, because in this way you can satisfy all the possible cases. So if in our case one user only provides the name and the last name is not provided and the age, is going to use this secondary constructor and is going to pass the last name as default and the age 0. And this is in a way similar to overloading functions, but is not the same, because what you're doing here is overloading the constructors. And in this way you can think about why we are overloading the constructors. And that is because if we didn't have secondary constructors, we would have to create another class with a different number of parameters or a different number of properties, and we will need to create each object with that specific class. Let's say that we create this object which only takes a value for its parameter name. Then we have to create a class in which we're going to define only the name property, and then we're gonna create that object only with that class. And if an object, let's say if a user creates, if your user doesn't is providing the name and the last name but not the age, you will have to create another class with only the name and the last name defined as its properties. And you can see that this will generate duplicated code and so on. And we can solve all of this by using secondary constructors and calling the primary constructor. So see you on the next video. And because Kotlin is about conciseness, in the next video we're going to look at how we can do the same thing that we have here with default parameters, because Kotlin supports for its properties, for its parameters in the constructor, default values. So the same thing that we have here can be achieved by providing default values to the properties. So see you in the next video. So now it's time to look at default values for our properties. And first, let's delete the secondary constructors. And now we have errors here because it expects the value, expecting the values for the next properties here. And let's also change this to first name, because I referred to it to the first name, but it was called, it is called name. So let's call it first name. So go right click on it, go to rename and then to refactor to change it in all the places, and let's call it first name. And as you can see now it's changed it in all the places. Then press enter. So now we have the first name. And default properties are default values to our properties are basically, they are similar to default values that we provide to our parameters when we talked about functions. And what we do is, let's say that I want to provide a default value for the last name. We just put equals. So inside the primary constructor we put equals, and here we put, let's say, last name. So now this has the last name as its default value if a value is not provided for the last name. And here you can put also equals, and we put 0. And now the error, as you can see, disappeared from both of our objects, because now what it's doing is when we don't provide a value for the last name and for the age, then the default values that we provide here are gonna be used as the values for the properties. So this is a way of achieving the same thing that we achieved previously with the secondary constructor, but this is more concise. And the question is when to use one or the other. Is the answer may be if you want to execute some code when an object is created, let's say with one of the, let's say if you want to execute some code when you create an object, then you can use secondary constructors, because as I said, secondary constructors can have a block of code when which can be executed, but the default, because primary constructor don't have a block of code, you cannot do that. Maybe you could use initializer blocks, but that is open to discussion. So this is how you can provide default values to the primary constructor. And our code works fine. And it's very concise, very beautiful. And the next thing that you can do is that you can also use named arguments. So you can use because here you use the first name and the last name. And if I because those are both strings here, you cannot see the distinction. But if I put here now I can use the name argument, so I can put here first name equals, so it's similar to the way we have name arguments in our function. And here you can put the text John also here. And this with this thing you can change the order in which you need to define the values for the parameter. So let's put here last name. But to illustrate this better, let's create another object. Let's type val user2. Let's type user, and let's put here 𝐤𝐿. But let's use the name argument. So let's put first the age. So we're gonna provide the value for the age. Let's say 19, and let's type first name. So here let's put 𝐤𝐿, because this is a string in quotation marks. And for the last name, let's say let's type also the name argument last name. And for the last name, let's put here Dobby, let's say. Right, so what we did here is that in the primary constructor, the order of the property is very specific. We have the first name and the last name, and then we have the age. But with the name arguments, we first provided the age. So we provided a value for the age property, which is the last one. So, and then you provide a value for the first name. And with name arguments, similar to the way used in our functions, you can pass the values to the properties in which order you want, irrespective of the order in which they are defined here. So this is very powerful, if you ask me. It's very interesting, because you can pass the values to the properties irrespective of the order in which they are defined. So this is our discussion about default parameters and named arguments with the primary constructor. And you cannot use default parameters and name arguments with the secondary constructors. They can only be used with the primary constructor. So see you in the next video. But before I end the video, let's actually run this code to see that it works in the same way it was working in previously when we used the secondary constructors. So let's run this code. So you have name Alex, last name, because it's using this default value that defined here. Then we have age 0 because it's using this value defined here. So this object. And then we have name John, last name Smith, age 0, because now it's using this default value. So the same thing can be achieved using default parameters. And we didn't output the values for the third object that we created here, user2, but you can do that as a challenge. If you want, you can output the values for this object. So see you in the next video. So now it's time to start a discussion about getters and setters, because so far in our videos, even though we didn't say explicitly the getters and setters here, we've used the getters and setters every time we got the value of a property and every time we assign a new value to a property. And the getter and setter in Kotlin are implicit, so they are declared, they are auto-generated by default by Kotlin for you. So every time let's say you get the value of an object, let's say that you get the value of the user, that first name, what actually happens here is not that we're getting the value of the first name directly, even though if you look at the code, this is what it seems to be. What is happening is that every time we get the value of a property, that value is returned by the getter. So you never access the property directly, and you never thus change the property of the value of a property directly. Every time you are using the getters and setters. And now this discussion is touching on a very important concept in Kotlin programming, and that is encapsulation. So encapsulation basically means to protect, to hide the inner workings of the class from being accessed outside. And if you look at this syntax that we have here, it seems that we actually accessing the values, the properties directly. But as I said, that is not the case, because we always using the getter and the setter. And because we always use the getters and the setters, the getter to get the value and the set to change the value of a property, that means that your data, your properties are never accessed directly. Thus, the laws of encapsulation are not broken. In other words, you never allow somebody outside of the class to access directly that property. So this is why we have getters and setters, and this is why the getters and setters in Kotlin are implicit. So they are not even declared explicitly here. We don't see any code which will imply that we have a getter, a setter here, because they are automatically and by default generated every time you define a property. So every time you define a property, either in the primary constructor or inside the class, the getters and the getter and setter is automatically generated for you. But let's say that you want to override the getter and setter to provide some additional code to the code that is by default provided. You can do that by changing, let's say, this property to a parameter. And to override the getter in setter and to see how the getters and setters actually look under the covers, just type here var. We define the property, first name. We assign the first name parameter to property. Now, the getters and setter need to be overridden immediately after we define the property. So we cannot have some code here and then to override the getter and setter. So we need to define them immediately after we define the property. So we type here get, and as I'm typing, you see that I have some suggestions. Then you go down here and you can choose this one. So you have parentheses, curly braces, and inside the curly braces you press enter. Here you type return field. I'm going to explain immediately what is this. And now we need to override the setter. And to do that, we just type set, and I have some suggestions. We also go down here, we choose this one, press enter, and here we type field again, this identifier, and we put equals to value. So this is the implicit code that is generated, that is auto-generated by Kotlin for you every time you define a property in your class, either in the, as I said, in the primary constructor or inside the class. So because in fact, if you look here, we have some underlines, and if you hover over here, it says redundant getter, remove redundant getter, because and also for the setter, redundant setter, because they are redundant because they are implicitly, again, auto-generated by Kotlin for you. So this code is redundant here. You don't need this code because Kotlin already provides this code under the covers for you. But if you're not satisfied with this code, with this implicit code that is auto-generated by Kotlin, you can override them like we did here and provide some additional code. So we can put here, let's say, some text, so that every time we get the value of our first name property, we're gonna have a prefix. And let's put here first name. Let's put a colon, $, and field. I'm gonna explain immediately what this field is, but let's say first how this works. And here let's put a println to print a value that is passed to the setter and then assigned to the first name property. So let's put here $, value was assigned to first. So now if you run this code, now we have name, so we have our text that we have here, name, and then we have first name Alex. Let's actually delete this text to make things more clear. Let's delete this text. Let's delete this. Now let's run this code again. So what we have now is that every time we get the value of our property name, we have that prefix first name that we have overwritten here in the getter. So the getter is called, as I said, the value is returned by the getter. So the getter is called, it returns the value of the first name property. So this field is the first name property, but it has this identifier field because of an important reason, which I'm going to explain immediately. So it returns the value of the first name property with the prefix first name. And we have first name, the text that we have here. Then we have the value of the first name property. We have Alex in our case because our object has the name Alex, as the property name Alex. Then for the setter, we don't have any code here. Also, we have the first name prefix for John. So our code, every time we get the first name property by any of our objects created by using the user class, it gets that value. It returns that value through the getter. And the setter, we don't have value as assigned to first name property because the setter is called only when we change the value of a property. And to do that, we type user, like we did in our first video about object-oriented programming, dot first name equals, let's say, let's put here Vlad. So now if I run this code, now the setter is going to be called because the setter is called, as I said, only when we change the value of our property. So we get Vlad was assigned to first name property. So the code inside the setter was called because this code that we type here is calling the setter. So our code always goes to the setter. And the code that we have here, user.first name Vlad, what it's actually doing is passing that value Vlad to here. So this parameter that we have here is receiving the value of Vlad, and then that value is assigned to first name property. Again, we have this field identifier for a reason, and the reason is going to be explained immediately. So the getters and setters are working well, and they are, as I said again, the use always when we get or we assign a new value to our properties. Now, what is this field identifier? Why I didn't type here first name, and here I didn't put first name? equals to value. So whatever value is passed to the setter, then that value is assigned to the first name property. So why we don't do that? And the reason for that is that because this syntax user.firstName equals Vlad is calling the setter. If we put here first name equals value, so first name equals Alex, it will be equivalent to call the setter again. So this line of code that we have here, it will call the setter again, it will pass the value to the setter, and then it will assign the value again to the first name. So it will call the setter inside the setter forever. It will generate an error. And to avoid that recursive call, that infinite call, we need to use this field identifier. So the field identifier is the first name property, but it has this special use that it bypasses that error that it will be generated if you use the first name here. So in fact, let's put here first name to see. So if you put here first name instead of field, and we have an error here, let's put here field, because I want the error from the setter to get in the console, not the error from this thing here. So now if you run this code, as I said, that will generate a recursive call. It will call the getter over and over. So we get the error. So you see we have Vlad was assigned to first name property, Vlad was assigned to first name property, Vlad, and so on. That is because the setter, it's calling the setter forever. It's a recursive call, because this line of code here, it's calling the setter, it's assigning the value to the, sending the value to the setter, then that value is assigned again to the first name property, which in turn calls again the setter, and so on. So this field identifier is used because it has this characteristic of bypassing that error. This is why we're using the field instead of the first name property here. And it's basically the first name property, but it has this specific characteristics which bypasses the recursive call which we got when we've used the first name property. Now if you run the code, now I have no error because the recursive call is not happening, because we're using the field which bypasses that error. So this is why we're using and Kotlin has this thing field, and the field can only be used inside the getter or the setter, not anywhere else outside the getter or the setter. And the same is true about the getter. This is why you need to use the field identifier inside the getter also, because it will generate a recursive call again. Now, to illustrate better, because you maybe find confusing this discussion about getters and setters, what they really are. They are equivalent to having two functions which update the first name property and return the first name property. So they are equivalent to having a function called set first name, and this function defines a parameter called, let's call it new value. It's gonna be of type string. Let's put curly braces, and here we type this dot first name equals new value. And the getter is equivalent to having a function called get first name, and this is not going to take any parameter. We're going to say explicitly here that it's going to return a string, because it's going to only return a value, and this is going to return the first name property. So we put here this dot first name. So the getter and setter that we have here are similar. This is illustrative for you to have in mind, to having two functions which are setting the first name property, are updating the first name property, and are returning, let's change this to first, and are returning the first, the value of the first name property. But because Kotlin is about conciseness, it has this special syntax, and they are automatically generated for you, because as I said, Kotlin is about conciseness, so you don't need to declare those things every time you create a class. So let's delete this. So have in mind that under the covers we have something like this. So let's delete this. Now the error disappears. Also, you can have a shorter way of writing the setter and getter if you don't provide some additional code. So if I delete this and this, I can put here get equals field, and yes, this is okay, because this is like having a single line, a single function, a single line expression function, because we're returning the value to the function get. So you can write it like this, or I show you this for you because maybe you'll see written in this way and you may be wondering why. That is because this is like having a single body expression function. So you can write it like this if you want. But again, if you hover over, this is still redundant. Let's press Ctrl Z to have the previous code. So this is our discussion about getters and setters, and see you in the next video. So now it's time to start a discussion about the late init keyword and how we can use the late init keyword with our properties. But first, let's delete the code that we have from the previous video, because we don't need this code. Let's also delete this code. Let's delete those two objects. Let's delete this property. Let's declare it here. So let's put the var keyword, and let's also delete the default values here. And let's press Ctrl Alt L to format the code. Now we need to provide the values here because we don't have default values for the last name property and the age. So I'm gonna type here Dobin, let's say, and age 23. Now, as you already know, if you declare inside the class a property, let's say that that property is called favorite movie, and it's gonna store the favorite movie of the user. You cannot let this variable uninitialize. So let's say that it's going to be of type string. So you cannot let this variable uninitialize. You need to provide a value either by assigning directly a literal value here, or by receiving the value through a parameter defined in the constructor. But that is not completely true, because sometimes you'll want to have a property declared inside the class, but you don't want to assign to it a value right away. So you want to assign the value to the property later. And to be able to do that, we need to use the late init keyword. And to use the late init keyword, you just type here late init, and we have a suggestion, late init. And late init stands for initialize later. So what we're saying here is initialize later this property favorite movie. So you say to the compiler, hey, I'm gonna initialize this property favorite movie, but I'm gonna initialize it later, so believe me. And to do that, we just type user dot, so you whatever object you create with this class, and you have defined the late init property favorite movie, and you put equals, and then you put, let's say, Interstellar here. So now we've initialized our favorite movie property, but we initialized its value later. So we didn't provide the value here directly inside the class, either by, as I said, by providing a literal value, or by providing a value through the parameter defined in the primary constructor. So this is how you can use the 𝐁𝐞𝐬𝐭 keyword if you want to assign a value to a property later. So you don't want to assign the value directly, or you don't want to assign the value, more correctly said, right away. So you want to assign the value later. You just put the 𝐁𝐸 keyword in front of the property, and then you declare the property as the way you declare a simple variable, right? And if you don't initialize this property and you output the value in the console, so let's say that I put here a println and I type user.favoriteMovie and I don't initialize it, and if I run this code, now this favoriteMovie property is not initialized, doesn't have a value. We're gonna have an error, and the error is very specific. So we have exception in thread main, Kotlin uninitialized property access exception, and then it says 𝐁𝐸 property favoriteMovie has not been initialized. So it's very specific in saying that, hey, you said that you're gonna initialize that property, but you didn't, and down here you try to output in the console the value of the favoriteMovie, but we don't have provided a value. And it's better to have this, this is called an exception, so it's better to have this uninitialized property access exception than having a null pointer exception, because this is why Kotlin actually enforces this behavior of assigning values to the variables. So Kotlin enforces to assign values to the variables and not let them uninitialize, because if you don't initialize, you don't provide a value to a variable or to a property, then when you try to access that variable or that property, and let's say that you have an app, that is gonna throw what is called a null pointer exception, and that is very bad, because those kind of exceptions are called only at runtime and not at compile time. So your app can work, let's say, completely well, and when you press a button, I don't know, to see the favoriteMovie of a user, then you get an error and the app crashes. So this is why you need to avoid those null pointer exceptions. And Kotlin, as I said, enforces this behavior of providing values always to the variables and to the properties. And if you don't want to provide a value to the property, then you can use this 𝐁𝐸, and it will throw this different exception called 𝐁𝐸 property favoriteMovie has not been initialized. So it's a different exception than the null pointer exception. But with the 𝐁𝐸 keyword, we can still have, as I said, that behavior of not initializing the variable, but you still need to initialize it later, because this is why it's called 𝐁𝐸. But this is not saying that the 𝐁𝐸 error that is showed here is not also having the same behavior like the null pointer exception that I talked about, because the 𝐁𝐸 error that is that we have here, if you have an app, it will also crash your app. But the 𝐁𝐸 keyword allows us to not provide, as I said, a value, a literal value here, or a value through the constructor by assigning the parameter here with the value passed to the parameter, and is our responsibility to initialize that variable later, so that we don't get into the same problems that we talked about, so we don't get this error. So it's up to you to declare a property as 𝐁𝐸 and then provide a value later, because if you don't, it will also crash your app when you try to access by I don't know, in your app, somehow you want to access the value of that property. So always have this in mind, that you need to initialize that variable later. Also, I should say that the latent keyword only works with classes, and it does not work with primitive types. So even though as I said, the integers and all the data types that we looked at, and also the boolean and char are classes, we cannot use latent keyword with them, because if I put here int, you can see that I have an error that it says latent modifiers not allowed on properties of primitive types. Because I'm not gonna get into much of details, but all we need to know is that when the int class and all the primitive types which are classes, at least at the surface, when they are compiled, I think they are compiled into primitive types, so they're not compiled into classes. So this, I think, is the reason that you can't use this latent keyword. But for other classes, because a string is a data type, but it's a special data type, as I said in a previous video, and because of that, you can use the latent keyword, and you can use the latent keyword with other classes. So I can put here user if you want, and it works because users is also a class. It's this class that we define here. So it's good to remember this. Now I'm gonna end the video and see you in the next video. But first, let's press Ctrl G to have the code that we had previously. So now I'm gonna end the video and see you in the next video. So now it's time to start a discussion about companion object. But to do that, I'm gonna delete the class that we have here, and I'm gonna paste it inside our classes file, because we're gonna need this class later in our videos. And I'm gonna also delete this code because we don't need this code. And let's say that let's create a class called calculator. It's not gonna define any properties. It's just gonna have a simple function called sum, which is gonna sum two numbers. So we're gonna define two parameters here. A is gonna be an int, a b also an int, and it's gonna return the sum. So we put colon at the end of our parenthesis for our function. We put int because this is what we're gonna return, and we put curly brace and we type return a plus b. Or you can put this in a single body expression function, so you can put the code like this if you want. So you can put here, you can also delete the type, you can put here equals, and this will work, but I'm gonna keep it like this. Now, if you want to use this sum function that is defined in this class calculator, first you need to create an object with that class. So we type here val, I'm gonna call it calculator, and I'm gonna create here a new object calculator. The constructor doesn't have any properties, any parameters, and if you want to call that sum function, we need to use our calculator variable or our calculator object or reference, and we put dot like we did in our previous video. So use the dot notation. So now we're calling the sum function on our calculator object that we created on line 2, and we call our function sum. Inside the parentheses you pass two numbers, let's say 5 and 10, and let's capture this value that is returned by the function in a variable. So let's put here val result, because that is going to return the sum of 5 and 10. Of course, that you can put that in a println statement if you want, but I put it in this elaborate way to make more clear what we're doing. And here I'm going to type println result. So now if I run this code, you're going to see 15 in output in the console. So let's increase this. So we have 15. And the way we did this, we created an object like we did so many times. Then on that object, use the dot notation to call that function on that specific object, on this object. And that function takes as arguments, as values to its parameters, to integers. We pass 5 and 10, and then it returns that value. And we retain, we capture that value in the result variable, and then we output that value in the console and get 15. But if you think about the way we did this thing, is that the only way we can call the sum function is by creating an object and then calling the function on that object. But it doesn't make a lot of sense if you have a calculator class to create every time through our code, every time you need to use the sum function to create an object throughout your code. A better way would be if you could call that sum function somehow without declaring, without creating an object and then using the object to call the function. And to do that, we need to use what is called a companion object. And to use a companion object, we go inside our class, we type companion object, so we can press enter to fill in a companion object for us, or we can type that. Then we put curly braces, and inside the curly braces we put our code. And in this case, we're going to put our sum function. Now, you're going to see something. Now we have an error here. Now this function, this sum function, doesn't belong to an object, to an instance that is created with the class calculator. Instead, it belongs to the class itself and not to any object that we create. Those the variables and the functions that are declared inside the companion object are also called class variables or class functions, because they don't belong to a specific object that you create with that class. Instead, they belong to the class itself, so you don't need an instance to call that function, and that implies that we can't use it with an object because it belongs only to the class. And let's see how you can use it using the class without creating an object. We just type calculator dot sum, and here you pass again 5 and 10. So we just use our name, the name of our class, we put dot sum, and now we can use the function without us needing to create an object and then calling the function on that object. So this is very powerful, because you will need this in your code sometimes when you don't it actually doesn't make sense to create an object every time you call, let's say, a sum function for a calculator. Now we can also retain that value that is returned in a variable, also result, put equals. Now we can print this in the console. So we get also 15, but this time we didn't create an object, we didn't create a new instance, and we call the sum function on that object. We just type the calculator class and we call that function directly on the class. Right, so this is how you can use the companion object. And this is also true for a variable. So if you put a variable here, let's say max, and you put an arbitrary number here, let's say 100, we can call this variable also by typing calculator, the name of the class, dot, and have our max variable. In contrast with how we did how we called the properties in the past by creating an object and using that object to call that property on that object. In this case, we just use the class and we call the variable. And this also can be useful if you have some constants which you want to use in or throughout your code. So let's delete this. So you can use also with variables. And if you think about at our one of our first lessons about the data types, when you look at the minimum and maximum value, I type something like this, val max, and to get the maximum value, I type int dot max value. And this is using also a companion object, because as you can see, the integer class, because the primitive types are also classes, at least on the surface, not when they are compiled on the JVM. They also use companion objects like we have here to get the properties and to get the functions, because we didn't create an instance of our integer with our integer class and then call that max value on the object. In fact, if you hold control on this integer class, and if you actually hover over it, and after you hold control, it says public companion object of int. So if you hold control and if you press click now, it will open this primitives.kt file, and inside primitives.kt file we have our int class, and we have a companion object, and inside the companion object we have this public constant value. We're gonna look at the constants in the next, but the point here is that it's using the companion object to declaring this minimum value, the maximum value inside the companion object, so that you don't need to create an instance, an object every time you need to use them. So this is our discussion about companion object, and see you in the next video. I'm gonna close this file now. And if you want, you can look in that primitives file if you want. Just take a look at what is there. So see you in the next video. So now it's time to start a discussion about singleton. But first I'm gonna copy this code. I'm gonna copy this class with the companion object, and I'm gonna paste it inside the classes file. And if you don't have this code because you create a new project, just type the code that I'm gonna type in a second. So let's delete the code inside the main function. Now, what is a singleton? A singleton is a design pattern in Kotlin with which you want to have only one instance of a particular object. So you want to have only one instance of a particular object, and you want to have that instance available globally throughout your program. So you don't need to create an instance every time you need to use that object in a different part of your code. And there are practical reason for having only one instance of a class. Let's say that you have a database. You want to have only one instance of that database, which creates the database, which gets the data, and so on. Because if you have multiple instances, if you are able to create multiple objects with that class, then you will have multiple databases in your phone or on your PC, and that is not good, because you're using more memory than you should, and you have duplicated and unnecessary code. So to solve that, what you need to do is to create only one instance of a particular class. And having this example in mind, this is what we're gonna do next. And first I'm gonna show you how we did in the past, how we created a singleton without having the object keyword. So you go down here, and first we're gonna create a singleton in the old way. So we type here class. We're gonna use our example database, not gonna create a real database. We're gonna just use this as an example. And to restrict the creation of instances with this database class, we need to make the constructor private. So we type private, and when you use an access modifier with the primary constructor, you need to use the constructor keyword. Otherwise you'll have an error. So if I delete the constructor keyword here, I have an error which says use constructor keyword after modifiers of primary constructors. So we put constructor, and inside the class, now because we cannot create instances of this class, that means that we cannot access any of the properties or the functions of this class. And to have access to a function which is gonna return an instance of this class, you need to use a companion object, because with companion objects you can have properties and functions being allowed to be accessed outside of the class without creating an instance. And here we type again the private access modifier. We call this instance, and it's going to be a database, a nullable database. Should be var there. Instance database, and as I said, nullable, so we can assign null to it. Then we define a function called getInstance, and this function is going to return an instance of our database class. Only one instance, only one single instance, not multiple instances. And to do that, first we check to see if the instance is null. So if this is the first time that we want to access this instance, then it's going to return true. If not, it's going to return false. So we check to see if it's equal to null. If it's equal to null, so our instance hasn't been initialized, you're going to type instance equals to database. Alright, so if the instance is equal to null, that means that the instance has been initialized. We initialize the database. So we can initialize the class inside the class. We cannot initialize it outside. Else, so if this condition fails, the code below is going to be red. Else you're going to return the instance. So if the instance is not null and this code is not going to be this condition is going to be false and the code will not be executed inside the if, we're going to return the instance. But here you should return the database, and it should be a nullable database. Alright, so our error disappeared. Let's delete this. Let's press Ctrl Alt L. Alright, now how we're going to use this? First, we type here val instance, and put equals, and we type database dot, and now I'm going to use our function getInstance. And if we print this instance in the console, so we type here instance. If you run this code, so now we're calling the fun getInstance inside the component object. We get this code. This code represents the location memory of the instance. So we have this code here. And if we try to instantiate this class, so we put here the constructor. If we do that, then we get an error because the constructor is private, so we cannot create an instance. And when we call the getInstance function, so when we did this, it first checks to see if the instance was equal to null, and it was equal to null, then it created the instance and then it returned the instance. But if you call this function again, so let's call it instance2 equals database.getInstance. Now this will evaluate to false because the instance is not equal to null. We have an instance, and it's going to come down here and it's going to return the instance, the already created instance. So if I put a println here and I'm going to output the instance2, you're going to see that there is no instance2. You have the same instance because it's returning the already created instance. So we have the same code here, meaning this translates to that you have the same instance. So no matter how many times you use database like instance, if it's the first time, then it's going to create the instance and it's going to return the instance. If you call that again, like we do for instance2, then it's going to return the already created instance. So in this way, you have the same instance no matter how many times you call the getInstance function, because it will always return the same instance because of our logic that we created here. But there is a shorter way to achieve the same thing by using the object keyword, and this is what we're gonna do next. So let's close this. Now let's see how we can create a singleton, and which is gonna have the same behavior that we created here. So it's gonna be only one instance using the object keyword. So I'm gonna type down here object. I'm gonna call it database. Now let's delete this code because we cannot have two objects which have the same name. And we cannot have a constructor here because it's a singleton, so you put only curly braces. You can have properties and functions inside the singleton created with the object keyword. So let's delete that code inside the main function too. So now by just typing object database, now we have the same thing that we had previously, just by typing object and database. So this will always return the same instance, and we have only this code object and the name of the object. So and the instance of the object is going to be created the first time you call it. And we can put an initializer block to have some code to be executed here. So let's put a println. Let's say database created. And to use this, just type, let's put a println, and type database. And now if you run this, and the first time you call the singleton, that time the singleton is gonna be created. So we have database created, then we have this code which represents the string, is the string representation of the object. And if you press Ctrl D here, look what happens. We have database created. So because this is only one instance, this object is a singleton, it calls the initializer block only once when it initializes itself. So when we call the database for the first time, it's initialized and it calls the code inside the init block, and after that it outputs this string representation. The second time we call the database, we don't have database created because the instance was already created, and the initializer block is not called again because we have the same instance. So if you can press Ctrl D here multiple times, and you're gonna see that we have the database created only once, because that is called only when the object is created for the first time. So on this line, in the next lines we have the same object. So we have here this is why I have the same code, because it's basically the same instance. So as you can see, this is a lot simpler and more concise than the code that we had previously. So this is how you can create a singleton in Kotlin. This is how we should do it. So see you in the next video. So now it's time to start a discussion about lazy initialization. But first I'm gonna copy this singleton inside our classes file. And if you don't have this file because you created a new project again, just type the code that I'm gonna type in a second. So I'm gonna delete this. Now, what is lazy initialization? Lazy initialization is used when creating an instance, when creating an object is expensive. And expensive in the programming context means that it will take some time, it will use some memory, and in that case it's recommended to use lazy initialization. And to illustrate the lazy initialization, I'm going to use our user class. So I'm going to copy our user class inside our main file, not because I can't create here an object by having the file here, but because I want to put the code here to make clear what I'm doing. So I'm going to delete the code from here. And if you don't have the file, just create a new class called user, define the properties first name, last name, and age. I'm gonna delete this because you don't need this. And inside our user class, I'm gonna put an initializer block, which is gonna be called every time you create a new object. And here we're gonna put a print line statement, which is gonna say user. We're gonna call first name property, so the value that is passed to first name property. Was created. So let's create a new object here. Let's call it user1 equals user. Now let's pass some values to the properties of the constructor. Let's say Alex. Now if you run this code, we get in the output user and the value for the first name property, Alex was created. If I press Ctrl D and I change this to user2, and let's change this to a generic name, user, and for the last name let's pass just the last name text, and let's keep that age. So if I run this code now, because now on the line 3 you create a new object, the initializer block is going to be called again because we create a new object. It says user was created. Now to initialize our user2 with the lazy initializer, we just delete this. And to illustrate how the initializer block works, we delete this and we put after user2 by, so we put the keyword by and we type lazy. And as I'm typing, you see that I have that block lazy. Press enter and put the curly braces, and inside the curly braces we create our object. So user, and here we pass the values to the properties. So let's put user1 let's pass last name, and for the age let's put 0. Now previously when the user was initialized in the old way, we saw in the output user was created, so the initializer block was called when we created the second object. But now if I run this code, look what happens. We get only our first object. We get the initializer block only called for our first object, and for our second object initialized using the lazy initialization, we don't have the initializer block because the object is not initialized. The object is only going to be initialized when you use that object in your code. So if you use that object somewhere in your code, the object then is going to be initialized and is going to be used. So if I type here a println which says user dot first name user2, now if I run this, now because I am using the user2 object, now the user2 object instance is gonna be created, and then I'm gonna see user2 that first name. So now we see user1 was created, so the initializer block was called because when we called the println user2 that first name, then in that at that moment it created the instance and then it outputted user1. So this is why now we see here user1 was created, and previously we didn't, because now we're using the user2 object in our code. So unless you are not using the instance, the object that you have created using the lazy initializer, it is not going to be initialized. So this is initialization by lazy. So see you in the next video. So now it's time to start a discussion about enum classes, but first I'm going to copy our user class inside our classes file. Now I'm going to delete this class, and also I'm going to delete the code inside the main function. Now, what are enum classes? Enum classes are used when you want to represent a fixed set of values. So when you want to create some constants, you should use enums, because enums are like constants, but they are more powerful because they can have properties, and they can also have functions. And enums are usually used in if conditionals, or in if statements, or in the when statement, or if you want to call it the if statement expression or when statement expression. Now let's see how you can create an enum class. And to create an enum class, you just type here enum, the keyword enum, and as I'm typing I have some suggestions. Then we put class, and let's call this enum class direction actually. Then we put curly braces, and inside the enum class direction we define our enum values. So here we define north, we put comma, enter, south, you can put them in one line just to have comma between them, east, and west. Right, so we have our enums values defined inside our direction enum class, and those enums values that we have here they are instances of our enum class direction. So they are an instance, they are an object created inside the enum class direction, just that they have this different name. And as you can see, the name of the enum values should be, all the names should be in uppercase letters. Now let's see how we can access those enum values. To access the enum values, we can, let's put the println here. We type direction, then we press dot, and we have some suggestions here. We have west, east, north, and south. So we have our enum values suggested. So let's choose west, and let's output this in the console. So we get west. So this is the enum value west, and let's press Ctrl D. Let's change this to east. So let's change this to east. Let's change this to north and south. Now if you run this code, we get our enum values: west, east, north, and south. So this is how you can get the enum values that you define inside your enum class. Now we can also pass you can define a constructor here for our enum class and define some properties like var, let's call it direction of type string, and var distance, and this is going to be an integer. Now if you hover over here, you have some underlines, and the underlines, if you hover over, it says that enum has not default constructor. So now, because as I said, those enum values are instances, they are objects created inside our enum class. Now we need to pass some values to the properties that we define here. So let's pass some values here. So let's type here first north, and I'm gonna speed up this now a little bit. Alright, so now what we did here, we passed some values to the enum values constructors, because up here in our enum class direction we define some properties, and those properties, because the enum values are objects, they are instances for enum directions, even though they have those different names, we need to pass to the constructors then some values. So we pass here north, south, east, west, and we pass for the distance 10, 20, 50, and 40. Now let's see how we can loop through our enums values, and to do that we just delete this code, and here we add the for loop. So we type for, let's call it direction in, and here we type direction, our enum class, dot values, and this is going to return an array with all the enum values that we define in our class. Now let's put curly braces, and let's add a println, and let's print the direction. So now if you run this, you'll see the same output, but in the order that they are defined inside the class. So we see the same, not the same output, because they are outputted in the order in which they are defined in the class. So we have north, south, east, and west. And this is how we can loop through an enum, through the enum values of an enum class. So this is how we do it. So now let's delete this code. Now if you want to access the arguments that are passed to our enum values constructors, we just first put a println to output the values on the console, and we type direction, so our enum class, dot, and we choose our enum value. Let's choose north, and from here, and here now we type also dot, and now we have some suggestions. We have direction, distance, and we also have name. And name is a variable which is not defined by us, so we only define those properties, direction and distance, but name is variable which is built in the enum class, similar to the direction that values, which return the array, is the direction that values was also property, actually it was an array property which was built into the enum class, so we didn't create that. It's provided by the enum class, so this is why we have that name there. So let's put direction, let's press Ctrl D, duplicate this code, and let's change this to distance. Let's press Ctrl D again, and let's also print that name, which is the built-in variable, provided by the enum class. So let's put here name. Now if we run this code, get north, so this is the value that we pass here, we get 10, and then we get north with capital letters. So we get the values that we passed here for direction and distance, which are defined in direction class. So we get the values passed for this specific enum value, and then we get north, and this is the built-in variable which is provided by the enum class. But as I said, we can also have functions. So let's have a function which returns the direction and distance. So let's type here fun. We call it print data because we're gonna print the data of a specific enum value. It's not gonna take any input, put curly braces. But now we have an error here. And that is because when you declare a function inside the enum class, you need to provide a semicolon for the last enum defined in your class. So you need to put here a semicolon, and the error disappeared. And let's print the data here. Let's add the println. Let's put quotation marks. Let's put direction equals $, direction, and distance equals $, distance. Now if you call this on our enum value, let's type direction dot, let's say west dot, and now we have our function print data. So this print data function is gonna print the data of the west enum that is defined here. So it's gonna output west and 40 in the console. So now if you run this code, we get direction west and distance 40. So this is how you can use functions inside the enum classes. Next, let's see how we can use our enum direction and generally how we can use enums with the when statement expression. So I'm going to close the console. I'm going to delete this code, and the print data function works for all of our enum values. So let's delete this. And here I'm going to define a variable. It's going to be a val. It's going to be called direction. I'm going to put equals, and here we type direction, our enum class. Let's choose east. So now the enum actually is no west, east. So now our direction enum east is going to be stored in our direction variable. Let's use the when statement expression, and we type here when direction, then we put curly braces, and here we type direction dot east. We're gonna put arrow, execute this code. So println the direction is east, and we'll do the same thing for the next one. So let's press Ctrl D. Let's change this to west, north, and south. So this is how you can use the enums with the when statement. Now if I run this, actually I should change the text there, but I'm gonna change it. So let's close this to change the text here. Now if you run this, you're gonna see the direction is east because this condition is true. Our direction argument here is gonna match with this branch, so it's gonna evaluate true, and then it's gonna execute this code. You can put curly braces if you want, but as I said in our discussion about the when statement expression, you should do curly braces if you have multiple lines of code. In our case, we have one single line of code, but you can put curly braces if you want. And of course that this branch will always evaluate to true, because here we type direction.east into our direction variable literally directly, and this value doesn't change. But in a real app, this value could come from a database or from the user input, and in that case you need to use a function which is also built into the enum class, and that function is called value of. So we type direction dot value of, and this value of function checks to see if our value that we pass here exists inside our enum class. So it checks to see if it's defined here, and it also returns that value. So if I type here east, now if I run this code, we get an error which is no enum constant direction that is, because all of our enum values have they are defined in uppercase letters. But if I put here dot uppercase, and if I run this code, now we get the direction is east, and this value that we have here is this value, as I said, could come from a database or from the user input, and direction that value of is going to check to see if this enum value exists in our enum class, and it's going to return that value in our variable. So it's going to assign that value to our variable. So see you in the next video. So now it's time to start a discussion about inner classes. So what are inner classes? Inner classes are classes which are declared inside another class, and they are generally used when you know that there is a very close relationship between two classes. So when it doesn't make sense to put two classes separated, then you should use inner classes. And let's look at an example. And we're gonna imagine here that we have a list view, and this list view is gonna display some items in a list on the screen, and here we're gonna use inner classes because for displaying each individual item, we're gonna create a list view item. So first, to create a class called list view. We create the primary constructor. We define a property called items, and it's going to be an array of strings. Now we put curly braces, and inside the class we type the keyword inner, then class, and now we create a class which is going to represent the individual items in the list view. So we type here list view item. We put the primary constructor, but we put we don't define any properties, and then we put curly braces. And this inner class list view is going to have a function called display item, and it's going to display the values of an item of at a specific position. So we put here position. Let's say we define a parameter to our function. It's going to be an int, and we're just going to type here print line. And the inner classes have access to the properties of the outer class. So inside our inner class that we have here, we can access the properties that are defined inside the outer class list view. In this case, we have a single property called items, and here we can type items, and notice that I can use the items property, which is defined in our outer class list view. We type position, and this is going to return an item at this position, which is passed as an argument here to our parameter position. And we go up here and we type val list view, because we're going to create an instance for list view. Type list view. Now we need to pass an array to our primary constructor, to the property item. So we type here array of, and we define some generic names here. Let's say name 1 and name 4. Now, how can we access the display item function, which is inside our inner class list view items? This should be list view item, not items. So let's change this. Go right click on it and go to refactor and rename. Let's call it items. Press enter. Now, to access the display item function, which is inside our inner class list view item, we type list view. So our instance, our object list view dot list view item, and then again dot, and now we have our function display item, and we can pass here, let's say 2. Now if you run this code, so we get in the output name 3, and this is correct because name 3 is at the index 2. And this is how you can access the display. This is how you can access generally a function inside an inner class. You just create an instance of the outer class, then you call the name of the class of the name of the inner class, and then you call the function. So see you in the next video. So now it's time to do a challenge using the knowledge that we have about object-oriented programming. And the challenge is to create a class which is going to represent a bank account of a person. And this class is going to have 3 properties. The first one is going to be called the account name. The second one is going to be called the balance. And the third one is going to be called transactions. And it should be a mutable list. Also, you should create functions for deposit and withdraw, and also a function for calculating the balance. And you also should add the checks for checking to see if the amount is when you deposit, the amount is greater than 0, and all of that stuff. So do this challenge and then watch my solution. So my solution is this. I'm gonna create a class. And for this challenge, you should also have in mind the discussion that we had about access modifiers. So I'm going to call it account. And I'm going to define here a property called, going to be called val, is going to be called account name. And it's going to be of type string. And we put curly braces, And inside the class, I'm gonna declare the next two properties, and those one first I'm gonna declare it without the access modifiers, because IntelliJ probably is gonna figure out that we need to put access modifiers on them. So I'm gonna type var balance, and I'm gonna assign 0, so this is the default value, and var transactions, and this is gonna be equals to a mutable list of int, because this is gonna store the transactions. So these are the three properties of our class. Now I'm gonna create the first function, which is gonna be called deposit, and this function is gonna be used to deposit money inside our bank account, and it's gonna have a parameter called amount. It's gonna be of type int, and first we need to check if this amount is greater than 0, because we don't want to deposit a negative value. So if amount is greater than 0, and we choose greater than 0 because we also don't want to deposit 0, so this is why I put greater than 0. Then if it is greater than 0, then we're going to add that to our transaction list, that add amount, and then we're going to say balance. We're going to update our balance. I'm going to put plus equals amount. Then I'm going to add the print line, which is going to say, I'm going to put quotation marks, $sign. I'm going to type amount, and I'm going to put $sign this dot balance. So I'm going to output in the console what is the balance. But if the amount that is passed to this function is a negative sum, I'm going to go in the else part, and I'm going to say, I'm going to add the print line here, which is going to say cannot deposit negative sums. So I'm going to put here cannot deposit negative sums. So this is our deposit function. Next, I'm going to create another function, and this is going to be called withdraw, and this is going to be used for withdrawing money. So we type fun withdraw, and we put parentheses, and this is going to take a parameter called withdrawal. So it should be like this, and it's going to be an integer. We put curly braces. Now it should be with here withdraw. Now we need to convert this into negative sum, because now we're withdrawing money from our account. So first we need to check if, and I'm gonna put minus, because I'm gonna convert this into a negative sum. Withdrawal is less than 0. So if this is a negative sum, which is gonna be withdraw, we're gonna add to our transactions this transactions that add, and you also put the minus. So you put minus withdrawal, because now we're adding, now we're taking money out of our account. Then we're gonna put this dot balance plus equals minus withdrawal, because now we're taking money. And then we're gonna add again a print line. It's gonna be this one, so I'm gonna copy this, but now this is gonna be the withdraw. Else, if this is not a negative sum, so I'm gonna put else. I'm gonna type print line cannot withdraw negative sums. So if he tries to withdraw a negative sum, then we're going to say cannot withdraw a negative sum. Here we put the minus because we're taking money out of our account, so we need to check for this is why we're checking here if it's less than 0. Should be negative here. And we're gonna create another function, and this is gonna be called calculate balance. So we type here fun. Let's bring this fun calculate balance. This is not going to take any parameter, and it's going to return an int. We put curly braces, and we're going to put this dot balance to 0 because I want to calculate the balance. So I'm going to add the transactions to this property balance. So here we're going to say, and here we're going to loop, we're going to type for transaction in our list of transactions. So for transaction in our list of transaction, we're going to type this dot balance plus and equals transaction. So our transaction. And then we're going to return the balance at the end of our loop when we ended looping. So return this dot balance. So this is our solution to the challenge, and let's create an account and let's pass some values here. So I'm going to type here val Alex account. I'm going to put equals account. I'm going to put, now I'm going to call the primary constructor. So I'm going to type here Alex. I'm still using my name here, but so I'm going to type here Alex account dot deposit. So I'm going to deposit, let's say 1000, and I'm going to type Alex account dot withdraw. I'm going to withdraw 500. Then I'm going to put Alex account, and I'm going to put deposit negative sum, let's say minus 20, and Alex account dot withdraw also negative sum, let's say minus 100. Now if you run this code, we get 1000 deposit, balance is now 1000, so we have our call called from our deposit function. Then we have so I didn't change the text here, so this is why it's saying this should say withdrawn. So sorry, let's change this to withdrawn. So let's run our code again. So we get 1000 deposit, balance is now 1000. Now we get our correct output. We get then 500 withdrawn. So we get our call from our withdrawn function. Withdrawn balance is now 500. Then we get cannot deposit negative sums, cannot withdraw negative sums because we passed negative numbers to our deposit and withdraw function. And here we're checking to see if those are negative or positive. So this is our solution to our challenge, and I hope that you enjoyed this and that you solved this. And this is not again the best solution. This is just my solution. Probably you find you figure out a better solution, or maybe a better and more concise solution than this. Actually, I forgot, before we end our video, let's actually call also our calculate balance function. So I'm gonna type here 𝐷 dot calculate balance, and this is gonna return an integer, so I'm gonna type here val, because that function returns something, so I need to capture that in a variable. So I'm gonna type here val balance equals 𝐷. So now add the print line here, and it's gonna say balance is $balance. Let's proceed per Ctrl L to format the code. Now if we run this code, now we get our previous output, 1000 deposits, balance now 1000, 500 withdrawn, balance is now 500, then cannot deposit negative sums, and cannot withdraw negative sums, and then get balance is now 500. So our code works well. So this is our code. One more thing that I forgot is that I said at the beginning of the video that you should have in mind the discussion that we had about access modifiers when doing this challenge. And I forgot to add the access modifiers for balance and transactions, because now what can I do for balance? I can use our 𝐷 accounts, and I can type here balance, and now because that is actually that is not really public, because when we talked about getters and setters, we said that when you access a property, you always access that property through getter and setter. So you never access directly the getter and the property, but still you should not make that public, because by default, if you don't provide an access modifier, they are by default public. So if I type here now account balance, as you can see, I can call that, and I can type here 1000, and I can deposit. Now I can change the balance of the account directly from here. And if you hover over here, IntelliJ figure out that you should make this private. So make this private, the balance, and also the transactions, because you don't use them inside the primary constructor, and they are used only through the functions that we defined here. Because of that, you should declare them as private, because you use them only through the function that you declared inside the class. So declare them as private, and now if you hover over here, it says you cannot access balance because it's private in account. And now we cannot change the balance from outside the class. We can only deposit or withdraw sums of money from our bank account by interacting only with the functions, and not by calling the property directly and assigning a new balance to the property. So make them private, and this way you cannot you don't access the property outside of the class, and you change directly the value of the property. Again, it's not really direct, because the code that we had previously, so this code actually is calling the setter here, but still you can change the value of the balance. But now, because we made that private, and the compiler is smart enough to figure out that because they are not declared inside the primary constructor, and they are only used, you only interact with them with the deposit and withdraw and calculate balance function, so we don't use them outside, you don't have them also declared in the primary constructor. It knows that you should make them private, because you interact them only with the functions. And now we have this underline because it's private, so we cannot change this balance now from outside the class. We can only interact them again using the functions. So I'm gonna delete this, and now see you in the next video. So let's delete this. So actually I'm gonna let it there, because it's good to see. So now it's time to start a discussion about inheritance. So what is inheritance? Inheritance is the concept in the Kotlin programming context with which you can create a class using another class. So in other words, you can get all the functions and properties that a class already has in your new class, and in addition to getting all the functions and properties in your new class, you can add some new functions, some new properties which are specific to this new class, but they aren't for the, also the class from which you are inheriting is called the base class, the parent class, or the superclass. And you might be wondering, why is this useful? Why you'll want to do this? Let's say that you have a very big class which performs a very hard task and has a lot of functions and code, but you want to create a new class which is slightly different from this class. What you can do is you can get all that code copied in the new class, and then you can add your new functions or your new behavior to this class. But that is not recommended because you have duplicated code. What you can do instead is you can inherit all the functions and properties which this big class already has, and in your new class you can add the new functionality, the new behavior which is specific to this new class, but it's not for the base class. So in this way you can you avoid the duplicated code, and you increase the code reusability. And for that I'm going to show you an example, and I'm going to create two classes. One is going to be called car, and one is going to be plane. So we create here a class. We go down here, we type a class. I'm going to call it car. It's going to have some properties. The first one is going to be called name. This is going to be the brand name of the car. The second one is going to be color, also a string. Engines, the number of engines that this car has, it's going to be an integer. And val, this is going to be doors, so it's gonna store the number of doors. Alright, we put curly braces because I'm gonna add some functions to this class. Two functions actually. Fun move and fun stop. And here we're gonna say print line, quotation marks, $, the name of the car is moving. Similarly, down here in the stop, we're gonna say the car has stopped. Car has stopped. And we're gonna create another class called plane, which is gonna have also val name. It's gonna be a string, a val color, also a string, val engines, an integer, and the val doors, an int. Put curly braces, and we define those two functions. I'm going to copy those, and I'm going to paste it here. So now what we did here is that we created two classes. They both have properties for the primary constructors, and but as you probably already noticed, we have the same properties. We have the name here, we have the name there, we have the color there, we have the color here, the color there, the engines also we have here and there, and we also have those functions which are almost, actually they are the same. So we have what I said at the beginning, duplicated code. So it doesn't make sense to put this code here. Another way to do this is to create a base class, a generic class called vehicle, which is and usually you create the generic class when you know that several classes are gonna share those properties and those behaviors. So a car and a plane both are vehicles, so we can put here, instead of declaring the name and the color inside our classes car and plane, you can put this in a vehicle class, in a base class, and we can inherit those properties in our classes instead of declaring them inside our car and plane class. So we can put here val name, it's gonna be a string, and val color, also a string. Now I can copy those two let's put curly braces here, and I can paste it here. So now I can delete those two functions from our classes, and what we can do now is we can inherit those properties. So we can delete those properties that we have here. We can, as you'll see, you'll need to declare them as parameters, but they're not going to be as properties anyway. They're not going to be as properties here. Now, what we can do is that we can inherit these those shared functions and those shared properties, because both the car and the plane have a function to move, have a function to stop. They both share a name, they both share a color, so they both share those properties and functions. But as we did it previously, is to put them inside the classes. So it's not good, because we have duplicated code. And in this way we put this code here, and now we can inherit this code. So we can have this code directly. You can have this code being accessed inside the car and plane without declaring them in our classes. So to inherit from a class, first you need to mark the class from which you want to inherit as open, because by default you cannot inherit from a class. So to inherit from a class, we go at the enclosing parenthesis of our primary constructor, we put colon, and we type the name of the class from which we want to inherit. And in this case, it's going to be vehicle. Now, if you hover over here, it says that this type has a constructor, and thus must be initialized here. And next, it says this type is final, so it cannot be inherited from. And that means that we cannot inherit from this class unless we mark this class with the open keyword in front of it. So we need to put here open. And now if we hover over here, now we don't have that error, we only have this error, which says this type has a constructor and thus must be initialized here. And that basically means that it says, hey, I'm trying to use this vehicle class, but in order to use it, I need to initialize this vehicle class. So we need to pass some values to the constructor, to the primary constructor that is defined here. You need to pass some values to the name and to color. And to do that, we define here name. We type name. Actually, let's press Ctrl Z. Let's put a space, and we type name. We put comma. Then we type color. And notice that we don't have the var or the val keyword in front of them. That is because those parameters that we have here, because they are parameters, because they don't have the val or the var keyword, they have to be declared only as parameters, because the properties are gonna be declared, and they are declared by the primary constructor of the base class from which we are inheriting from. And because of that, we don't need to declare the property again here. As you can see, if I put the var keyword, we have an error, says name hides. Anyway, that means that we cannot have the property declared here, because the property is already declared inside the base class, inside the vehicle class from which we are inheriting from. What we can do here is define the parameters, and the value that is passed to those parameters, to the primary constructor of the class cars, are going to be passed to the vehicle primary constructor. So here we put the primary constructor, so we put two parentheses, and we type name, and this name is this one from here. So we type name, then we put comma, because we need to pass a value for the second one, for the color, and we type color, and this color is this color here, so we type color. Now if you go up here, let's say let's look first as the, actually let's also inherit also on the plane class. So we put colon also here, we type vehicle, and now we need to also define here the parameters, the name and the color. So we type name, And as I'm typing, you can see that IntelliJ is giving us some hints. So if I type here color, it says that color string, so it's very helpful. Put colon, we pass those values to the primary constructor of the base class. So we type name, color, and now if I go up here and I create some instances of our car and plane class, so we type here val car, let's put equals, let's type car, let's choose for the name BMW, and for the color let's say red, for the engines 1, for the doors 4. Now I'm going to create also an object with our plane, so let's press Ctrl Alt L to format the code. Val plane equals plane, so our class, we type here for the name Boeing, for the color let's say white and blue, and for the engines 4, and for the doors let's say also 4. Now if I go down here and I type here car dot, if you look here, you see that we have the function stop and the function move, but we didn't declare them here, we deleted them previously. But because we are inheriting from the vehicle class, because when you are inheriting, the properties and the functions from the class from which you are inheriting from are part of the new class. So the move function and the stop function, they are now part of our car class. Similar, the same here. The move and stop are part of the class plane. So if I type here car dot move and car dot stop, and then plane dot move and plane, so look, then now I can call them like they are declared inside our car and plane, but they are not there. But because we are inheriting, they are part of the class. So you can think of this thing that we have here as a single entity. So it acts like a single entity. So now if you run this code, we get in the output BMW is moving, BMW has stopped, Boeing is moving, Boeing has stopped. And we get this output because, as I said, those functions are part of our classes, and they are using the name. So in this case, the name that is passed to the car, this name that we have here, BMW, is passed to the primary constructor of the base class, and then it's used here. So it's calling the move and say BMW is moving. So in the same way for the plane, we get the same output. It gets the value that is passed here, Boeing, and then it outputs Boeing is moving and Boeing has stopped. But we can do even more. We can override those functions inside our class, so we can create a version which is inside the base class from which you are inheriting. We can create a version of this function which is specific to the car or which is specific to the plane, and I'm going to look at that. So now I'm going to override the move function from our base class vehicle inside our plane class, because I want to make the move function specific to the plane class. So I want to provide an implementation of the move class which is specific to a plane. So how a plane is moving? A plane is moving by flying. So I'm not satisfied with only this generic function which says the name of the vehicle is moving. And to override the function, you first need to mark the function similar to the class. We need to mark it with the open keyword. So we type open because Kotlin wants to make things explicit. So we put open, and now we can override that function inside our plane class. So we go to override the function, we go to code, generate, And here we have equals and hash code, toString, and you go to override methods, and you have those equals, hash code, and toString, and those are here because every class that you create in Kotlin is implicitly inheriting from the any class. But we're gonna look at that on more on that later, because we're gonna look at that in a different video. And we have our function move and stop. So the IDE is telling us that those are the functions which can be overridden inside our plain class from our vehicle base class. So we choose move, we press OK, and you have this super.move. We're gonna see immediately what is this. And you can also override it by just typing the keyword override, and you can override the function. So you can type here override, and while I typing, you see that we have this override fun, move, stop, and have also those. So we choose move, and now we have the same thing. Now super.move means that call the function. So super means call something from our base class. In this case, call the move function from our base class. So we're gonna let that here, but in addition to that, we're gonna add a new function. So we're gonna type here fun flying, because the plane is flying, and we're just gonna have a simple print line, which is gonna say, put quotation marks. Let's bring this down a little bit. The plane is flying. So now I'm gonna call this function flying inside our move function, which was overridden. So we type flying. Now, if we run this code, look what happens. If you look in the output, you get BMW is moving, BMW has stopped, and then you get the plane is flying, and then you get Boeing is moving and Boeing has stopped. So what has happened here now, because when this function move is called here on our object plane created, now it's using our own implementation of the move function, and after that, so it's using our own implementation, is calling the flying function that we created here, because a plane is moving in a specific way, is flying, and then it's calling super.move, and super.move is calling the function from the base class. So it's calling the function from here. So by doing this, we made our function specific. We made the function move specific. We make the function move unique to the plane class, because the plane is moving in a specific way. And we can do the same thing for the car class. So now you may be wondering why I didn't declare inside our base class the engines, because they are also present in both classes. Because when you create a generic class, you should only include the commonly used functions, commonly used and shared functions and the properties. So all vehicles have a name and a color, but not all vehicles have engines. So this is why I put the engines here. So in addition to the name and the color, which all vehicles have, we added some new properties which are specific to a car. Similar here. In addition to the name and the color, which all vehicles have, and we inherited that from our class, we added also engines and doors, which those things are, in addition, they are specific to a plane. And more, we also override the move function, because we're not satisfied with the simple move function from our base class, to include, to provide our own implementation of how a plane is moving. So you can see that by using inheritance and adding new properties, adding new function, you can create more specific classes. You can inherit. You can also inherit from the car class to create a more specific class. You can create a Tesla class and so on. So this is what inheritance is, and see you in the next video. So I thought that's a good idea to show you another example with inheritance. And I'm gonna go down here and I'm gonna define a class. I'm gonna type the keyword class and I'm gonna call it view. And this view is gonna represent a view in which is used in Android. And a view in Android is just a rectangular area on the screen and it's responsible for drawing and event handling. But we're gonna mimic, as I said, what a view is in Android. We're not gonna create a view like the one that is used in Android. And we define the primary constructor, but we're not gonna define any properties to the primary constructor. And this view is gonna have a simple function called draw, and it's gonna be responsible for drawing this view on the screen. So we type draw, and we create a function, and we're gonna add a simple print line here, which is gonna say drawing the view. So we put here quotation marks, drawing the view, and we're gonna mark this class as open because I want to inherit from it, and we're also gonna mark the function open because I'm gonna override that function in the next class. And because this is a generic view and is gonna have this draw function, only this function, what you can do, let's say that I don't want to create a simple view which is just a rectangular area on the screen, but I want to create something more specific. Let's say that I want to create a button. In that case, instead of creating the button from zero, because this view in Android has a lot of functions and properties which are responsible for creating the view, for handling the events and so on. So because here you have only a simple function, but the real view has hundreds of functions. And instead of creating our button from zero, we can just inherit from the view, and we can inherit all the functionality that the view already provides to create a generic view. And we can add some unique characteristics which are specific to a button. And in this way, we increase the code reusability, and it's more easy for us to create the button rather than creating the button from zero, because the view already provides all the tools that you need to create the generic view. Only we're gonna inherit all that behavior, all that properties, but we're gonna change it a little bit. So this is what we're gonna do with inheritance. So we create a new class called button. So we define the primary constructor, and here you can define now some properties which are specific to a button, not just to a generic view, which is a rectangular area on the screen. So we put val text, and this is going to be a string. So our button will have a text which can be login or sign up, and also it's going to have orientation, because it's going to be on a place on the screen, on a specific place on the screen, and this is going to be a string. Of course, you just only mimic the view and button which are used in Android. This is why we have so many. We have so little properties and only a simple function in our view draw. And we put here colon to inherit from our view, because I want to inherit all that functionality, all that properties that a view provides, but I want just to change it a little bit to make it more specific. I want to make a button. And of course, as I said, this is just an example we don't have, but in a real app, this will have hundreds or thousands of lines of code, and we can inherit all of that behavior or that functionality in our new view, which is a button. But we can override some functions, and you can provide you can create a more specific view than a generic view. So here you need to define the primary constructor, and you put curly braces. Now I want to override the draw functions, so that when the draw function is called, I want to not drawing just a generic view, but to draw a button. Of course, as I said, this is just an imaginary example. So we type override fun draw, and instead of calling the super function which is inside our our base class view or parent class view. I'm gonna type here print line, and we're gonna put the text drawing the button, of course. And now what we did here, we created a generic view, as I said, and again, this can have hundreds of, maybe thousands of lines of code and functions and different functions, different properties. But we inherited from the view class, and we added some new functionality. So instead of just drawing a generic view, now of course we just added simple print line here. But here we can have the code which is going to be responsible for drawing a button. So it's going to be more specific than a simple generic view. So we can put here, here is the code for creating the button. So I'm going to put a comment there. And let's say that now I want to create a round button. So instead of creating again all that functionality which is present in the view, and then creating all the functionality which is inside the button class, we can make this button open, and we can inherit all the functionality that the button provides, and we're gonna add something new, something unique to this class that we're going to create. And this class is going to be a round button. So we type here round button, and here we need to define the text, because we're going to inherit from the class button orientation. And notice that I don't use the var or the val keyword here, because they're going to be only parameters, because the properties, the actual properties, are going to be ultimately declared in the button class. And one thing which is going to be specific to a round button that we're going to create is going to be corners. So we type val corners, and it's going to be an integer, because the corners, basically here we're going to pass a value which is going to, in our imaginary example, this is going to receive a value which can be in degrees. So how many degrees do you want to make the buttons? By how many degrees you want to make the button round? So you can pass here 20 or 30, anyway. So we put colon here, and we inherit now from our button class, right? And here we need to pass the text, the orientation, and that's all. And we put curly braces. Now let's override the draw function in our round button, because when that function is called, now I want to add some specific code, some new functionality which is specific to a round button. So it's not gonna draw just a button, but it's gonna draw a round button. So of course we're just gonna add a simple print line there, but in a real app you can put here the actual code which is gonna draw the round button. So we put here print line, and we put drawing the round button. Now let's create some instances. Let's create some objects with those classes, and we type here val view. So we're gonna create our generic view. We define the primary constructor. We don't have to pass any values there, because we didn't define any properties inside our view. Then we create a button. So we put here val button equals button, and here we need to pass some values. So I'm gonna pass here the text, let's say login. The orientation, let's say it's gonna be a text here, so we put here, let's say center. Next we create a new object, but this is gonna be now a round button. So we put here round button equals a round button, and we pass the text here round button. Actually, let's pass the text sign up, and for the orientation let's put center also, you need to pass also value for the colors. Let's put let's say 30 degrees. It will be in our imaginary example. Now let's call the function draw on all of our objects that we create. So we type view.draw, then we put button.draw and round button.draw. Now if you, let's press Ctrl Z, if you run this code, so we get in the output drawing the view, then we get drawing the button, drawing the view again, drawing the round button. And let's think about why we have this output. So first we see that we have drawing the view, which is the function inside our view that we created here. So it's from the generic view, so it's drawing the view. Then we have drawing the button. So here, when this line of code is red, it says drawing the button. So we have our code, which is, you know, which is just a print line, but this is drawing the button, then it's calling the super function. So it's calling the function inside the view, which it says drawing the view. Next, when this line of code is red, so round button.draw, now it's calling the draw function, which is inside the round button. So instead of just now calling because now we are inheriting from the button class, now we override this function here, and it's using our implementation for creating a round button. It's executing this line of code, and then it's calling the super implementation, which is drawing the button. You can actually remove this if you want, because let's say that calling the code inside from the button is not gonna affect our logic. So if I delete this, now if you run this code, now we have drawing the view, drawing the button, and we have drawing the view, drawing the round button. So now it's not calling here the super, so it's not calling the code which is inside the button, because we are inheriting first from the button, but the button is also inheriting from the view. So it's calling first this, then it's calling draw, which is inside here, and we had drawing the view. But now we only have drawing the round button, because here now it's using our own implementation of the draw. So we have drawing the round button. So by this, just by making our view, because as I said, in a real app, this view can have hundreds of, maybe thousands of line of code of different functions and properties. So you don't want to create all of that from zero when I want only to, let's say I want to create a button. I can inherit from the view, which already provides all the functions and properties and logic to create a generic view, but I can override some functions which are responsible, let's say, for like this draw, and I can define some logic, and when all of that functionality is called, it's gonna not draw only a generic view, but it's gonna draw a button. So by inheriting from the view, we increase the code reusability. And this is very, very powerful, because let's say that like in our example, you're not satisfied with a simple button which is used in Android, and you want to create a round button. So instead of creating all of that logic from zero, you can just inherit from a simple button. You can override some functions, and when you execute that code, now it's gonna execute the code with the implementation, with the additional implementation, with the additional code, which is gonna generate a round button and not just a simple button. So this is our discussion about inheritance. I hope that this clarifies some things, and see you in the next video. So now it's time to start a discussion about seal classes. So often you want to represent only a fixed set of possibilities. So a web request can either succeed or it can fail. A user can be a standard user or a pro user. And in those cases, you may be thinking now that you can use enum classes, but enum classes have some limitations. And let's see why you should use instead sil class. So let's type main. I'm going to create an enum class here, call it result. And let's put curly braces. Let's type here success. And error. Now, the problem with this is that we cannot encode more information here. So let's say that I want to define here a non-resolvable error and a resolvable error, and I cannot do that here. So if I type here x.exception, I cannot do that because the types that we define here cannot have properties, so you cannot define this here. And for that we need to use sil classes. And to use the sil class, we just type sil class. I'm gonna call it result. It's gonna have a parameter called val message. It's gonna be of type string. And you can define your classes which are gonna inherit from the sil class either outside the sil class. So you can type here class, let's say success, and let's type here message of type string, and we can inherit from the sil class. So you can type here result message, or you can copy this and you can define it inside the enum class. So you can have it as an necessary class. So I'm going to type another class here called error. I'm going to define the parameter here. Actually, not that is the parameter. Message. And I'm going to define the parameter here, message. I'm going to inherit from the result, from the results class. I'm going to pass that parameter here to the parent class. Now, I'm going to define a function down here called getData fun getData, and it's going to have a parameter called result. Going to be of type result, and here we're going to define a when statement. So we type when and we type result, and now is the interesting part. Now if you hover over this underline over when, it says when expression must be exhaustive, add necessary is error, comma, is success branches, or else branch instead. So in other words, what it's saying here by to have the when statement exhaustive, is what it's saying in other words is that it needs to cover all the possibilities. So both possibilities that we have here. And you can type yourself this, or you can click on here, click on this right bulb, and you can click here add the remaining branches. And as you can see, it's added the remaining branch. So you add is result.error and is result.success, and those are exhaustive. Those are the only two possibilities which are possible. So here I'm going to type result. Let's define a function inside the sil class. So I'm going to type here fun show message. It's going to have a print line which is going to say result $sign message. So now I'm going to put dot show message, and also here result dot show message. And now this is exhaustive, because now we covered all the possibilities which are inside which are as a consequence of the fact that our classes are inheriting from the seal class. So if I add here an else branch, so if I put here else, as you'll see, this is going to be redundant because we covered all the possibilities, and the compilers know this, and this can be very useful in some scenarios. So if I put curly braces, as you can see, this is grayed out because it's redundant, because it knows that we covered all the possibilities, and the possibilities are only those two, result.error and result.success. So if I type here now val success, let's type success equals result, it should be O2 yes there, equals result dot success. Let's type success here. Let's press Ctrl D. Let's call this error. Result dot, let's change this to error. So this is how you create instances of the nested classes. Let's call this failed. Now let's type here get data, down here get data, and let's pass success, and let's run our code. Now as you'll see the message result success. So we get result success in the output. So if I change now this to error, you'll see that it says result error because it's executing this branch. So if I run this, you get result failed. Now the interesting part here is if I add here another possibility. So if I type here class progress and I type message string inheriting from result, let's pass the message parameter to the superclass, to the parent class. Now what we have, because our class is a sealed class, what we have here is that the when is underlined and is trying to say something to us. It's saying that when expression must be exhaustive, add necessary is progress. So it knows that there is another possibility for our result in which it can be. Therefore, you need to add that possibility. Otherwise, I'm going to show you this error, and if you try to compile this code, I'm going to throw an error. So what you can do here is we can type here is result to make it exhaustive, so to cover all the possibility, result dot progress. Let's put the arrow, result dot show message. And now if I create here another val, let's call this progress equals to result dot progress, and let's define for the parameter progress here. Now if I change this to progress, now you'll see in the output result progress. So we get result progress because now this branch is true. But if I delete all of those, look what happens. If I click here where you have those this underline, it says add else branch. So when expression must be exhaustive, so it means that it needs to cover all the possibilities. Add necessary is error, is progress, and is success. So if we click here on more actions, and if you click here on add remaining branches, it it knows that those are all the possibilities on which our result can be, and it automatically generated the check for us, and we only just need to type here result that show message, and that's all. And with enums you don't have this auto-generated code for you, because result that show message, let's type here and I'm gonna explain immediately. So with an enum, if you add another so if you have an enum class, I can delete the code now here but I'm gonna keep the code as it is. And because all the subclasses of a SEAL class are known by the compiler can fill all the possible cases automatically for you. So if I declare this arrow class as a SEAL class, and I declare two classes inside here called, let's say, class resolvable error, or recoverable error, and it's gonna have a parameter called exception. It's gonna be of type exception, this one, and we're gonna extend from our error SEAL class, not this one, this one, and we're gonna pass the message parameter. And I'm gonna declare another class, non-recoverable, and it's gonna have an exception. So this is more powerful than enums, because you can have all those properties, and you can have subtypes and all of this, and with enums we cannot do this. So let's extend from error. Let's pass the message, and now I need to delete this because you cannot instantiate the sealed class. So let's delete this. Now if I delete this now from here, look what happens. I have an underline, and it says when expression must be exhaustive, so it must cover all possible cases that exist for this SEAL class. As necessary, it's not recoverable, or it's recoverable branches. So if I click on this, and I click on this bulb, and I click here add remaining branches, as you can see, it added all the possible cases, so all the possible cases that we define inside our SEAL class for us automatically. And we just type here result dot show message. Again here result dot show message. And you cannot have this behavior with the non-class. So this is why SEAL classes are more powerful, because you can have subclasses, you can have more information on the classes, so you can have exceptions passed to them and so on. So this is our discussion about SEAL classes, and see you in the next video. So now it's time to start a discussion about abstract classes, and to show you what abstract classes are, I'm gonna use the code that we had in our discussion about inheritance, but I'm gonna change it a little bit. So I'm gonna delete first this class plain, because you don't need this class, and I'm gonna delete these instances that we have here, and I'm gonna declare this as a var, and this also as a var, so they're gonna be now properties. I'm gonna delete the properties that we have here, and now we have this here, so I'm gonna delete this too. Let's delete this, let's delete this. Now, what are abstract classes? Abstract classes are very similar to interfaces. The only difference is that in abstract classes you can declare properties which can have a value, and in interfaces you can't. Actually you can, but you need to provide an access modifier. And to declare an abstract class, we go in front of the class that I want to make it abstract, and we type the abstract keyword. Let's put the class keyword, and now our class is abstract. And with an abstract class you cannot create instances. Abstract classes are created only to be inherited from by other classes. And now if I try to create an instance with this abstract class, like let's type val vehicle, and we type vehicle here, and we put the parentheses to call the constructor. You have an error here and says cannot create an instance of an abstract class. So you cannot create an object with an abstract class. An abstract class can only be inherited by another class. And abstract classes usually are used like interfaces when you want to provide what needs to be done, but you don't provide how it's going to be done. So abstract classes are used when you define functions without the body and the code. The body and the code is implemented, it's provided by the class which inherits from the abstract class. So they are, as I said, very similar to interfaces. The only difference is that in abstract classes you can have properties. So you can have here a val text, and you can assign here some text. In an interface you cannot do this. Let's type some text. So this is the difference. And also I should say that you can implement as many interfaces as you want in a class, but you can only inherit from a single class. I forgot to say when I talked about interfaces. Now, if I want to make now our functions abstract, we just type the keyword abstract in front of them, and now they are abstract, and we're gonna do the same for our stub function. But now we have this underline because, as I said, abstract functions like interfaces or the functions which are defined in the interfaces cannot have a body. So we need to delete this. You need to delete the body. You need to delete the curly braces because the actual body, the actual logic and the code is going to be provided by the class which inherits from the abstract class. Now, to inherit from an abstract class, we go here, we put colon, and we type the name of the abstract class from which you want to inherit, vehicle. Now, if you go here, now we have this red bar which says, so you need to call the constructor here. Right? Actually, I think I can delete this. But you still need to call this constructor here, even though we don't have any parameters, even though we didn't even define the constructor here. Now we need, because like the interface, the abstract class, if you inherit from an abstract class, and if that abstract class has some abstract functions defined in it, you need to implement those functions inside your class. And you go here when you have this underline, if you click on this red bulb, and it says implement members or make car abstract, and we click on implement members, we select our two functions, we click OK, and now we have our functions implemented inside our class. So this is what abstract classes are, and they are, as I said, very similar to interfaces, but the only difference is that you can define properties inside an abstract class, and you can provide a value to that property. And here, because we have inherited from our abstract class, here you can provide the actual implementation of the functions. So as you can see, we have this to do which says not yet implemented. So they are very similar to interfaces. So I'm gonna end this video now and see you in the next video. But before I end the video, I thought that it's a good idea to say to you where abstract classes and interfaces are used. Interfaces are used in many places, but abstract classes are particularly used when and also interfaces are used when you have some APIs, and those APIs want you just to define the functions, and the API is gonna generate the actual code for those functions. So you can have let's say a database, and you can provide the name of the functions which are responsible for creating the database, for getting data from the database, but you don't provide the actual code which is gonna select that data from the database and return the data. You just declare your functions as abstract, and the API is gonna generate all that code which is responsible for returning the data, and in other words, the API is gonna do all the hard work. You just define the functions. If you have let's say if you have a property, define an abstract class and the abstract functions or interfaces, and the API is gonna do the hard work of based on what your function is doing. By reading the name of the function, is gonna generate all that code which you've had to generate if you don't have if you'll not be for the API to generate that for you. So this is where interfaces and abstract classes are sometimes used, and interfaces also are used in event handling, and that is when you need to write code to respond to graphical user interface movements. So I'm gonna end the video now. See you next. So now it's time to start a discussion about data classes. But in order to understand what data classes are, we first need to understand what is the difference between structure equality versus referential equality. And to illustrate the difference, I'm gonna declare two variables. The first one is gonna be a val. It's gonna be called name1, and we're gonna assign the value Alex to it. So it's gonna be of type string. Now I'm going to press Ctrl D to duplicate that line of code and to declare the second variable, which is going to be called name2, and it's also going to have the value Alex. Now I'm going to add the println here to output something to the console, and here we're going to type name1 equals name2. So the equals to operator is doing what is called, is checking for structure equality, because it's checking to see if the content of the variable name1 is the same with the content of the variable name2. So in other words, it's checking to see if they have the same value, and they have, because both have Alex assigned to them. So now if I run this code, because this is a Boolean expression, this is going to return true or false, and you're going to see in the console true. But if I change this to Alexandro, now the variable name2 has a different value, so this is going to return false, because they're not structurally equal. Their content is different. They have different values. Now we get false, and this is called the structure equality. The next type of equality is called referential equality, and the referential equality is used when you want to check if two variables or two objects are the same. So what the referential equality operator is doing is checking to see if two, as I said, variables or objects are the same. So if I type here name1, and to use the referential equality operator, we put 3 equal sign here. And if I type here name1 equals name1, so is name1 equals to itself, that is going to be true. So you're going to see true on the console outputted. So we have true. But if I change name1 equals to name2, that is going to return false, because they are distinct objects in memory. They are different variables. They are not the same. There is the name1 variable is not the same variable as name2, so we're gonna have false here. So we have false. So this is the difference between a structural versus referential equality. So now I'm gonna close this. I'm gonna close the console, and having this in mind, we're gonna start a discussion about data classes. So let's go down here and let's create our user class, because I want to compare two user objects to see if they are structurally equal. So we type user, let's define the primary constructor, and let's define 3 properties for the primary constructor: the first name, the last name, and the age. Which is going to be an integer. Now, if I want to check if two user objects are structurally equal, let's first create those objects. So let's delete this code. Let's type val user1 equals. Now let's create our object, and let's pass some values to the properties of the constructor. Let's pass here Alex. For the last name, let's put Dobin. And for the age 23. Now let's press Ctrl D to duplicate that line of code and to create the second user object. Let's give a different name to this, user2. Now we go down here, let's press Ctrl Alt L to format the code. We typed our println because I want to check to see if our users objects are equal, if they are structurally equal. So we type here user1 equals, so the equals to operator, user2. Now if you run this code, what do you think you're gonna see in the output? What you'll see in the output is actually that we get false. And you may be wondering why, because if you think about it, they are structurally equal, they have the same values for the properties, but they are distinct objects. But we said previously that the equals operator is checking for structural equality, so why get false here? This is because previously the equals to operator is it was checking to see if the two strings are structurally equal, and the equals to operator is actually a function which is defined inside the any class, and the string class, what actually was doing when we called the equals to operator, it was using its own implementation of the equals method. So every class that we create in Kotlin, it's implicitly inheriting from the any class, and because every class that we create it's implicitly inheriting from the any class, every class is also gonna use the functions which are inside the any class. So if you don't override those functions inside your class to provide your own implementation, like the string class did for our strings, then it's gonna use the implicit it's going to use the function which are inside the any class. And if you type here user1 dot and we have equals to string and hashcode, those three functions we are particularly interested in, and particularly we are interested inside the equals. They perform when you don't implement inside your own class those functions. Again, particularly the equals class. The equals class performs only a referential equality, so it only checks to see if those two users are the same users, and if they're not, it's gonna return false. So this is why we get false here, because it's calling the function which is inside any class. So what you have implicitly is something like this. So for any class that you use, or for any class that you declare, you have implicitly inherited from the any class, and because of that you have those three functions which are defined, and if you don't override them to provide your own implementation, then it's going to use the code that's inside there. So actually if you press Ctrl here and if you click, it takes us inside the any class. So it's clear that this function, the equals function, is inside the any class. So because we don't have any functions here, so we need to override that function inside our class, and we need to provide our own implementation. We need to define our own code to determine if when two users are structurally equal. This is what we're going to define inside our class. So let's delete this. Let's put the curly braces, and actually I'm going to bring an image to show you how the Kotlin hierarchy actually looks. So this is the image, and at the top, as you can see, we have the any class, and then we have our boolean class, our string class, and then we have our user class. And all of those classes that we have here, the boolean, the string, the number, they are inheriting from the any class. They are using the functions which are defined inside the any class, and they are overriding those methods inside them, and they are providing their own implementation for those functions. And this is what we need to do also here. As you can see, they all inherit from the any class implicitly. So we need to override them to provide our own implementation for the equals and for the next two, because we're going to look at also at the, as you saw there, we're going to look also at hash code, because equals and hash code are very linked together, and also at the toString function. So we need to override those inside our class. So this is what we're going to do. So we go inside our user class, and here we need to override the equals function. When we type override, and while untapping, you can see that we have three suggestions here, and we select the user function because this is the one that we are interested in. And as you can see here, this function is part of the any class. So we press enter, we delete the super return, and the first thing that we need to check is to see if the current instance, the current object that on which this equals function is called, it's comparing with itself. So we need to check if the object is the same as the object that we are comparing with. And to do that, we type here if this. So if this current object, this current instance equals, so 3 equals, we check for referential equality to see if they are the same, equals other. So we type other. And if that is the case, we are comparing the same object, so you have user1 equals user1, then we're going to return true, because that means that we are comparing with the same object. If that is not true, then the next thing that we need to check, we're going to go down here. So if not, you're not comparing with itself, then we need to check if the other, so the object which is passed as an argument to this function, which is called on another object, we need to check if other, so the argument, is user, because we need to check explicitly to see if this object which is passed as an argument to our equals function is a user object, because we don't want to check for a different object. We need to see if this is a user object. So only if the object which is passed as an argument to the equals function is a user object, then we're gonna return true. So here we need to type. Now we need to define our logic for what it means for two users to be equal. And it's up to you how you define this implementation. I'm gonna type here only return. So my logic is if they have the same first name, the same last name, and the same age, we're gonna say that they are equal. We have the same user. Of course, that in a real app you can have a more complex implementation. So we type here return this. So this current instance, that first name. So, and then we put 2 equals other. So the other is, because we check here explicitly to see if this is a user. The other is also because this condition is gonna only pass if the other argument is a user. So we type other because we have access to the first name and the last name and the age. If other dot first name, so this is our first condition, and this dot last name. So I'm gonna check for for our 3 properties. Equals other. So other is a user object because we determined that here. That last name, and this dot age equals age. So this entire expression that we have here is gonna return true only if all our 3 conditions are true. If this dot first name is equal to other dot first name, so with the object that is passed as an argument to our equals, and if this dot last name is equal to other dot last name, and if this dot age is equal to the other dot age, let's put here, then and only then we're gonna have true here. So it's gonna return true. Otherwise, if one of those condition fails, it's gonna return false. And down here we need to if other, let's say, doesn't pass, so if other is not a user, we're gonna return false. So in that case, we're gonna return false. Now if I run this code, look what happens. So previously we had false, and now we have true here. And this is because now it's using the equals function, which is inside our user class. So it's using our own implementation. So it's checked here to see if if first name is equal to other dot first name. So it's checking. So it's using our logic inside the equals function. So this is why you get true. And you can also now if you hold control here, as you can see, now it's taking us inside the equals method that we defined here. It's not taking it inside the 𝐁𝐞𝐬𝐭 class. This is because now it's using our own implementation. So first we check to see if we are dealing with the same object. then you're gonna return true. You're not gonna go we're not gonna go down. And if this is false, you're gonna come up here. You're gonna check to see if other, the object which is passed to our equals function, is a user instance, it's an user object. Then we're gonna check to see if our current object that we are calling on this equals function is equal. We check to see for the first name if is the same. We check to see if the last name is the same, and we check to see if the age is also the same. Then in that case, we're gonna return true, and we're gonna say that they are structurally equal. So we're gonna see true in the output. Else, if other is not an user, so if you pass to the function argument a different parameter, a different argument here, let's say you pass an integer, then it's gonna return false here. It's gonna come down here. So now, if you look here, you may be wondering how this syntax works. So we have those signs, but it's calling the equals function. So you can also put dot equals if it makes more sense, and if you put dot equals user too. So now you can see that. So, but if you hover over here, it says replace with the two equals. So it's the same thing as having dot equals and passing that argument here, which is user2. So again, we are invoking the equals method on the user1 object. Let's press Ctrl Z. And we are passing our user2 objects. And we are using our logic that we define here to determine if they are equal. And we can replace this back to equals. Or if it makes more visual sense to put to use the equals, you can use equals. It's the same thing. We put user2 here. So as you can see, we are calling the function. So this means this object. So this object that defined here. This, if when we're saying this that first name, we mean this object. So if this that first name, it's equal with other that first name, then we are calling this object that is passed here as an argument. So next we're gonna look at the next two functions, because as I said, the equals and hash code are very linked together, and we're gonna also look at the toString function. And now if I change the first name for the user2 to John, and if I run this code, it will get false in the output, because when it will come inside this if, it will check to see if this that first name equals to other that first name. And because we're using the AND operator and all the conditions have to be true, this is going to return false. So I get false in the output. And but if I change it back to Alex, we'll have true. So the objects are structurally equal based on the logic that we defined here inside our equals function. And as I said, you're gonna also look at equals and hash code, because they are very linked together. And the rule is whenever you override equals, you also need to override the hash code. And if two objects are comparing equal, so if they are equal based on the equals method that we implemented, they also have to have the same hash code. And I'm not going to go into that, but this is because they are the hash code is used for performance reasons in collections, but we're not go now into that. We can just type here override, and here we just type return 0, and this is not gonna affect our equality at all. As I said, this hash code it will make it makes more sense to implement the hash code in a different way in collections, because they are used for performance reasons, particularly with hash set and hash maps. But for now, for our simple class, because we don't use this class inside any collections, we don't need, because we don't have to think about that the performance reasons of the hash code. And just if you want to just return 0 here like I return, and it would work fine. It's not gonna affect at all our equality. But remember that rule, that if you override equals, you also have to override the hash code, and if two objects are comparing equal, they must have the same hash code. This is true, as I said, particularly in collections, not now, because we're not using this code inside collection. And we can also override the toString method, and this toString method is used to return the string representation of the class. So we also type here override, and we have our toString function. I said method a few times, but they are functions, not methods. Methods is a different thing in Java. And let's delete this function. Let's type it again. So if you can see, so this is gonna return the string representation of the class. So I need to return here the values that are passed to our first name and last name and age. And if you don't do that, if you add the print line here and you type user1, let's press Ctrl D, and user2, you're gonna see just you're gonna see the user, and you're gonna see some numbers, but you're not gonna see the string representation of those two users. So you're not gonna see Alex, the name and the age. So you see this those two. But to avoid that, because this is also useful, because previously when we want to output in the console the values of the properties, we had to call those properties and to add multiple print lines. But with the toString function, we can just type here return, and we type here user, we put parentheses, and here we type first name we put equals, we put $, let's put a single quotation mark, $, first name, let's put a quotation marks here, a single quotation marks, last name equals $, last name, let's put inside the single quotation marks this, comma, and age, we put also equals $age. Now if you run this code again, now when we are typing user1 and user2, is gonna use the toString function that we defined inside the user class, and it's gonna return the string representation of that specific object. So if you run this code, we get user and get first name Alex, last name Dobin, age 23, and we get for the second user first name Alex, last name Dobin, and age 22. So now we get the string representation of this class, and this is more beautiful, because you don't have to always type that user1 that age, user1 that last name, the first name, and so on, and for the second object too, because now it's using the toString function with our own implementation inside here. So this is how you can use the toString function, and this is also how you can use the hashcode. But as I said, hashcode is it's a different discussion which you're gonna have when we're gonna talk about collections. For now, just type return 0 here, and everything will all fine. And if you think about, there is a lot of code just to compare two objects. We have almost 38 line of code just to determine if two user objects are equal, and also have to override this, not necessarily, but we also override this hash code and the toString. So there is a lot of code just to do this simple thing, to compare it if two user objects are equal. And because Kotlin is about conciseness, we don't actually need to do all of this stuff. But I thought that it is okay to explain to you what you will need to do in the past in order to understand what now Kotlin is doing better, respectively data classes. So you don't need to type yourself all of this code that you have here. You can just, so if I delete all of this code, let's copy it first and then delete it. So if I delete all of this code, also and now if I run this, now we get false, and we get we get user and this text, because now we don't have an implementation of the equals, of the toString, of the hash code. And if you think, as I said, it's a lot of code to implement all of that. And in Kotlin, you can just type the data keyword in front of the class, and all of that code, not specifically the same logic, but all of that code that we type there is going to be generated automatically for you. So the equals method is going to be generated, the hash code, and the toString. And the properties which are going to be included inside the implementation of the equals, of the hash code, and inside of the toString are going to be all the properties defined inside the property constructor. So all the properties defined inside the primary constructor are going to be used inside the implementation of the equals of the hash code and the toString. So just by putting here the data keyword, all of that code, all of that logic is going to be implemented for us. So if you run this code now, so look at this, how concise is compared to what we had previously, just one line of code. And if you run our code with the data keyword, now as you can see, we have true, and we have user, first name Alex, last name. So you have the same output as previously, and just by putting data keyword, all of that was all of this code. So let's press Ctrl Z. All of this code, not specifically exactly this code, but all of this code, all the implementation of the equals, of the hash code, and toString was generated automatically for us just by putting the data keyword in front of our class. And if you don't want to have a property included in the implementation of the equals, or of the hash code, or of the toString, you can just omit it from here, and you declare it inside the class. So if I put, let's say here, so if I delete this, because data classes cannot have parameters, and I declare it inside the class, inside the data class, var age, you need to assign a value because we cannot let the property uninitialized. Let's delete this now. And if you run this, now that property is going to be excluded from the implementation of the equals, the hash code, and of the toString. So you have here true, but we have first name Alex, last name Dobby. So now the implementation for the equals only includes those properties, the first name and the last name. And also for the toString function, we have only the first name and the last name. The age is excluded, but let's put this back. So this is what data classes are. They are generating automatically for you the implementation of the equals, the hash code, the toString, also for the copy function and for the component function, but we're going to look at the copy function in a separate video. And they generate all of that code that we saw previously, that we talked about, automatically for you by just putting the data keyword. You put the properties inside the primary constructor, and all of that implementation is going to be generated for you for all the properties defined inside the primary constructor. And just by one line of code, all of that logic is generated automatically. So this is what data classes are. See you in the next video. So now it's time to start a discussion about interfaces. So what are interfaces? Interfaces are used when you want to have a commonly used behavior shared among different classes, but you don't want to provide the actual code that goes inside the class which is going to implement that interface, but you just want to define the name of the function and the parameter of the function. The actual code that goes inside the functions that you define inside the interface, they are particular to each object that implements that specific interface. So let's say that you have some classes. Let's say that you have a class car, a class which represents a truck, and you have a class which represents a plane. You know that all of those three objects have in common the same behavior of starting the engine, let's say. And you don't know how each particular class is going to start the engine, but you know that each class is going to have in common this function which is going to start the engine. Again, you don't care about how each particular object is going to what code goes inside, or what logic goes inside the start engine function for each of those particular objects. But we care only about the fact that they share the same behavior. They all start the engine, but how they start the engine is particular to each class. And this is what we do with interface. We only define the what. So what we define in the interface, only the what, and the what represents the what those classes are gonna have in common. So you know that they gonna have a function called start engine, but you don't know how each object, how each class is gonna implement that logic. And for that I'm gonna use an interface. So we define what needs to be done, but we don't define how it's gonna be done. So to declare an interface, we go down here at the enclosing curly brace of the main function, and we type interface. And while I'm typing, you see that we have this suggestion. We press enter, or we can type the entire word if you want. So interface, and I'm gonna call this interface engine, and the name of the interface should be with a capital letter, should start a capital letter, should be in Pascal case if it has multiple words. And interfaces cannot have constructors because they cannot be instantiated. You cannot create an object with an interface. Interfaces are used only, they are created only to be implemented by classes. They cannot be instantiated. So we need to put curly braces, and inside the body, inside the curly braces, we define what needs to be done. So we define only the function. We type the name of the function. I'm going to call it start engine, but we don't define the actual code for the function. So we put parentheses. Here you can define parameters if you want, but we don't put curly braces, and we define our logic here because we only care about what needs to be done. So we only care that each class needs to start the engine. How it's going to start the engine, it's up to each particular class. So we go down here, we type class, and I'm going to create a class called car, and it's going to have a val name, which is going to be a string, and a val color, which is also going to be a string. And now to implement the interface, we put colon, and we type engine. And as you can see, we have this engine, we have this I for interface here. So we press enter, then we put curly braces to define the body of the class, and now we have this underline here. And this underline is here to tell us that we need to implement this function, because the interface and the class have a contract. It's like a contract, and the contract says that if you implement an interface, you must override the function. So you need to implement the function. This is why we have here an underline. So if I click on this underline, or if I hover over there and I click on the light on the red bulb, you see that it says implement members. So click on implement, and we have our start engine function. We click OK, and now our function was overridden here. And we have this to do which says not yet implemented, and this is there to tell us that this method, this function is not yet implemented. So we need to define the actual logic here. And let's create two other classes. Let's call this class track, and it's also going to have a name, a val, it's going to be a string, and the color, also a string. And we're going to also implement the interface. So I'm going to put colon, engine, then we put curly brace. Now we need to implement, because I said there is a contract between the interface and the class. And the contract says that you need to implement the function. So we implement the function here, and we create another class called plain. And it's also going to have a val name. It's going to be a string, and a val color, also string. And here we put colon, and we're going to also implement the interface inside the plane class. And we put colon, engine, our interface, then curly braces, and now we have the underline because again, there is the contract now between the interface and the class, and that says that we need to implement this function inside our plane class. And we have those to do, and those to do are here to tell us that we need to provide some logic to the actual function. So let's delete those and let's put some code here. So let's delete this. And let's add a print line here, which is gonna output some text to the console. And we're gonna have the text, the car is starting the engine. And I'm gonna copy this because now I'm gonna put here some text. I'm gonna say the truck is starting the engine, and here it's gonna say the plane is starting the engine. Now, what we have done here, and what we did here is that we know that each class, respectively our car, our truck, and our plane, they all gonna start the engine. So they all gonna share this start engine behavior. They all gonna have this functionality. What we don't know is how each class, how each object is gonna start the engine, because they start the engine in a different way. The engine of a car is different from an engine of a truck or from a plane. So we know that each class or each object is gonna start the engine, but we don't know how they're gonna start the engine. So here inside the actual inside the function, we type the text: the car is starting the engine, the truck is starting the engine, and the plane is starting the engine. So they differed in how they start the engine, but you know that they all gonna start the engine. So this is what interfaces allows us to do. You can define an interface if you know that multiple related or unrelated classes or objects are gonna have a function shared between them, but you don't know how each particular class or object is gonna have the actual code, how it's gonna write the actual code for that behavior. So you don't care about the how, you only care about the what. So we know that in this case they all start the engine, but they start the engine in a different way. And you can have here another class. Let's say that a person which creates another class, and the class is gonna be called Tesla. And in that case, again, you can implement the interface because you know that the Tesla is also gonna start the engine. You don't know how it's gonna start the engine, but you know that it's gonna start the engine, and how it's gonna start the engine is specific to a Tesla car. So this is what interfaces allow us to do. We can define some shared behavior between unrelated or related classes, and that the actual code, you don't define any code inside the interface. You can define here a property, but usually you just define the function name, some parameters, and the actual code goes inside the class which implements that interface. And let's actually create here a class Tesla. So we put here, let's put this a little bit up. So we put here class Tesla. It's gonna have also a val name. It's gonna be a string, and a val color, and this is also gonna be a string. So now we can implement our engine interface. So we don't know how Tesla is gonna start the engine, but we know that it's gonna start the engine. So we implement our interface, put colon, the name of the interface, and now we need to implement the start engine. So we click on that, and we have not yet implemented. Let's put our print line here. I'm gonna press Ctrl V, and here is gonna say Tesla is starting the engine. So this is what interfaces are, and see you in the next video, because I'm gonna end the video now. So here it should say Tesla is starting the engine, not the Tesla. So I corrected that. So I thought that it's a good idea to show you a practical example using Android Studio where interfaces are used, because when I first learned about interfaces and abstract classes, I found them very confusing because they are very abstract, and you don't see when somebody teaches you those concepts, you don't see how, where you're gonna use those concepts, interfaces and abstract classes. And for that, I'm gonna open Android Studio to show you a practical example using interfaces. And also I'm gonna use Android Studio to show you a practical example where we're gonna use abstract classes. So I opened Android Studio. You don't need to, it looks similar to our IntelliJ IDE, because it's IntelliJ IDE, just that it's Android Studio. So we click on My Application. And here we have this thing called main activity. We don't need to worry about this, because as I said, I just want to show you where interfaces are used in Android Studio to get an idea about where they are used, because as I said, they are very abstract. And I already set up some code. So in this thing called activity.main, this is where we put our UI. This is where we put our buttons. This is where we put our list views. This is where we put generally our UI. So as you can see, we have two buttons here, and they have an ID. Again, I'm not gonna go into this, but if you click here on design, you see that we have a login button and a sign up button. So this is the UI part of our app. Now I'm gonna click on this main activity, and this is the part where we're gonna put our code. And now I'm gonna link those UI buttons. So let's go to code. So this is the code for creating those buttons. And I'm gonna link those buttons because they have this ID here, login button. So you have here Android ID. And if you come from Android Studio, you already know all of this. I'm gonna link those UI buttons with some objects buttons by typing some code. So I'm gonna define up here a latent var called the login button, and it's gonna be of type button. So this is a class button. Then I'm gonna define another latent, because I'm not gonna initialize it right there. So latent again, sign up button, and it's gonna be also of type button. So types, like we have types for our numbers or for our, just that this is a class, and this class is a button object. And now we need to link those objects that we created here with those buttons that we have here, those UI buttons. So to link those login button and sign up button. And to do that, to go down here, and I'm gonna do this in the longer way. And here we type login button. Again, you don't need to understand all of this. This is just to illustrate how interfaces work. I'm gonna put equals, and now I'm gonna type find view by ID. And this function find view by ID is gonna link our button object that we created here with our UI button that we have created here, and it's gonna be linked by its ID, by this ID that we have here, login button. So if you go here you type R. So R is this thing which again, don't need to understand all of this. R is used to get that ID, to link our button object with our button UI. So we put r.id dot, and we have our two IDs. So we choose login button. So now we have linked our UI button with our button object. So we linked the UI, in other words, with the code. Now let's link also the 𝐶𝐞𝐬 button. So we type here 𝐶𝐞𝐬 button equals find view by ID. You also type r.id dot 𝐶𝐞𝐬 button. Again, you don't need to type this code because probably you don't even have Android Studio. This is just to illustrate something. Now, to illustrate how interfaces work, let's say that I want to do something when this login button is clicked, and I want to do also something when this sign up button is clicked, and here interfaces come into action. What we can do is we can say login button dot, and there is a function called set on click listener, and this function, what is doing is basically setting a listener on our UI button, so that when you click on that button, a function called onClick is going to be executed, and the code that is going to be in that function is particular to each button. So you're gonna set the interface. So you type set on click listener, and here you type also, this illustrates the object. Also, this by this example we also illustrate how the anonymous classes work. So you type object, and now I'm gonna inherit, actually gonna implement our interface on click listener, and this on click listener interface has a function called on click, and here you put curly braces and press enter, and now here we have this underline, and if you click on it, you have this red bulb because it wants us to implement that onClick function. So we're gonna implement that, and it says to do not yet implemented. And I'm gonna do the same thing for the 𝐶𝐞𝐬 button. So I'm gonna copy this, I'm gonna paste it down here, and I'm gonna change it to 𝐶𝐞𝐬 button. So now each individual button has its own on-click listener interface, and the code which is going to be executed inside the onClick method, because this function is going to be triggered when you click on the button, is particular to each button. So this button is going to log in the user. This button, you're going to put here the code to sign up the user, but you're not going to do that. We're just we're gonna show some text on our emulator. So we type here to show the text toast dot make text. Here you need to pass the context, so don't worry about all of this. Main.activity. Here you need to pass how long this is gonna show on the screen. So we choose short, and we put that show to show this on the no, actually here you need to pass the text. So what text is going to be shown on the screen. So here we're going to say login button clicked, and now here you need to pass how long is going to show. So you type toast dot short, so it's going to be shown for a short time, and then we need to call the show function to show this on the screen. And I'm going to press Control C to copy this, and I'm gonna paste inside our onClick function in our interface that we have here for the 𝐶𝐞𝐬 button, and this is gonna say that 𝐶𝐞𝐬 button was clicked. So 𝐶𝐞𝐬 button clicked. Now in Android Studio we have what is called an emulator, and this is basically a virtual phone, and we can run our code, and we can test our code, and we're gonna see on that emulator those buttons, and when we're gonna click on those buttons, this code that we define here for those buttons, because we linked them, so we linked those two buttons that have here, the login button, the 𝐶𝐞𝐬 button. So this is their UI code, this is their XML code. We've linked them through code here, and when we click on them, the code in each particular object is going to be executed. So now if you run our code, go up here and I'm gonna create now the virtual phone to see our buttons, and I'm gonna click on them to see how it works. I'm gonna close those. Now it's connecting to the emulator, and this is our virtual phone. So this is the virtual phones, and here we have our UI that we created here. So this is what the users see. So this what the users see, and this is what we see. This is what happens under the covers. And now if I click on this login button, look what happens. It says login button click, so it executes this on click function inside the login button. If I click on the sign up button, it says sign up button click, because it's executing the on click function and the code inside the on click function for the sign up button, and they are as I said linked by the ID. So this is what happens under the covers. This is what the users see. Now this is where interfaces can be used, because if you think about, you can have multiple UIs, different UIs, text views, lists, or items, individual items in a list which can be clicked. And for all of those, you know that all of them are gonna have a on click function. All have this shared functionality to respond to a click. You don't know how that on click function is gonna execute, or what code that on click function is gonna have for each particular UI. But you know that each one is gonna have a one click function. What is gonna go inside the one click function for each particular UI, it's up to that specific UI. So it's up to a button, it's up to a text view, and so on. So this is where interfaces are used, because we know that they're going to have a shared functionality of one click, but we don't know how that functionality is going to be implemented by each particular UI. In our case, we know that a login button and a sign up button, both are going to have a one click, both are going to respond to click events, but we don't know what they're gonna do. So this is why you define the interface, and the developers who write code gonna implement that interface, and you're gonna write the actual implementation for that function, which is specific to that object. So this is our discussion, and if you find this confusing, particularly if you find confusing because I touched a little bit on Android Studio in our discussion, don't be, because I just wanted to show you a practical example where interfaces are used using Android Studio. So let's click again on login button. We get our toast, login button clicked, sign up button clicked. I can create another button which can be used for I don't know, if you forgot the password and you're gonna implement the on-click listener. You're gonna override the one-click function. You're gonna write some code to help the user to recover its password, and so on. So we can see how interfaces can be used practically in this with this example. So this is our discussion. See you in the next video. So now it's time to start a discussion about object expression, but first let's go down here and let's create a class to see why you'll need to use object expression in the first place. So we type here class, and our class is going to be called button. We put parentheses to create the primary constructor, and define some properties here. The first one is going to be text, it's going to be of type string. The second one is going to be also a val, it's going to be called ID, it's going to be an integer. And the last one is going to be called on-click listener. It's going to be of type on-click listener, so this is an interface that we're going to create. So let's go down here to create the interface. We type interface on, and while I'm typing, you see that you have this suggestion, one-click listener, to create the interface. Press enter, put curly braces, and let's define a function, fun on-click let's put parentheses. Now let's create some objects with our class button to see why you'll need to use object expression in the first place. So let's go here, and here we type val, let's call it login button, put equal, and now let's create our object, type button with parentheses. Now let's pass some values to the properties of the primary constructor, and this is gonna have the text login. For the ID we type some arbitrary numbers here, 1 2 1 3 2, and now here we need to pass the one-click listener interface, but we cannot type here one-click listener because we cannot instantiate the interface. So what can we do to solve this problem? One solution to this would be to create a separate class here. Let's put it actually above the interface. Let's call it click listener, this class click listener, and this class is gonna implement the interface. So we put here colon, and we call our on-click listener interface, put curly braces, and now we need to implement that on-click method, that on-click function that we defined actually inside our on-click listener interface. So press OK to override that on-click function, and we have that to do. We have this to do which says to do not yet implemented. So this is there to tell us that it's not implemented yet. So let's delete this. Alright, so what we could do is you can create here an instance of the click listener. So we type here val click listener equals, we create the instance, we create an object, and now we can pass here the click listener. So now the error disappeared. But if I create a second object, let's call it sign up button equals button. Let's pass the text sign up. For the ID also an arbitrary number. Now in our imaginary example that we have here, actually if you think of a real scenario with this button and with the one-click listener, what we want to achieve here is that if you have a graphical user interface, you want that you want to detect that click. So you want to detect when that specific button, let's say that this button object that we have here is linked to an graphical button on which you click. Because they are linked, when you click on that, you want to call that one-click function that is defined inside our interface, inside here, but you want to make that one-click interface, you want to make that one-click function particular to that button which was clicked. So we want to implement that one-click function to that particular button which was clicked, and the code that goes inside that particular button, so let's say that you click on the login button, is particular to that button, so that in the next when the next button is clicked, so if the user clicks on the sign up button, then you need to also have the one-click method called, but that one-click function, actually I keep saying method, but the one-click function should have its own implementation particular to the sign up button. So what can we do in that case? We cannot pass the same instance here to click listener, because even if it create here another instance of the click listener, it will still have the same code which is here. So if you put here some code, this code it will be shared among all the objects that are created. So what you can do in this case is to use an object expression, or also called anonymous classes. So what you can do here, we can type object, we put colon, and now we are inheriting from our we are actually implementing our own click listener interface. So we type object colon onClickListener, and we put curly braces, because here we declare and we also instantiate the anonymous class. So we need to implement that right there. So by doing this, now we made the onClick function particular to each object, button. So we can do the same thing here. We type object and we implement our onClickListener interface. We put curly braces. Now we need to implement for this particular object, for the sign up button object, we need to implement that function. So we type, we click on this object, we go to the red light bulb, and we press here where it says implement members. So implement the onClick function. And now what we did here is we made the onClick function particular to each object. So each object, now we can put here some code, or we can type here this sign in. Actually, let's type login the user. So now we can have code here which actually logs in, if you have a real graphical user interface, which logs in the user. And here you can add some code to sign up the user when that specific button is clicked. So by using the object expression, also called anonymous class, because you don't have a reference, you don't have a name for the class here, it's just anonymous. For this is anonymous, so we cannot it does not have a name, so we cannot call it later or do something, because it's created and also instantiated right there. So this is why you need to implement the onClick function. And now we made the onClick function particular to each button, and if you have more objects of created with the class button, they will have their own implementation of the onClick function, which comes from the interface of onClickListener. So this is why you need to use anonymous class, or also called the object expression. And it's an expression because the value that because the object is always it's created and instantiated, it's actually declared and instantiated at the same time. It's also assigned to the property that we define here. So this is why it's called an expression. So see you in the next video. Alright, so now it's time to start a discussion about delegation, but first I'm gonna add the main function here. Now, what is delegation? Delegation means giving power, given authority from one instance, from one class to another class. And delegation is usually used in scenarios where inheritance starts to break. So when inheritance starts to break, when you want, let's say, for whatever reason, to inherit from two classes, in that case you can't use inheritance, because with inheritance you can inherit just from only one class. But with delegation you can plug in multiple implementation of classes in your own class. And let's see how we can do that. So I'm going to create first an interface called A, and it's going to have a function called print. Then I'm going to create another interface called B, and it's going to have a function print too. Then I'm going to create a class. So I'm going to type here class, and it's going to be called first delegate, and it's going to implement the interface A here. And I'm going to press Ctrl O to override the function print here. And I'm going to create another class called second delegate, and it's going to implement the interface B. So I'm going to press Ctrl O to override the function print too. Now I'm going to create up here a class called up. So class up. Now let's say that I want here to inherit from the first delegate and from the second delegate, and from the second delegate. And if I type here first delegate, I put parentheses, opening parenthesis, closing parenthesis. If I put curly braces, now I have an underline because I should mark this as open. So mark this as open. and also this as open, because I want to show you that. So now, if I want to inherit from the second class called from the second delegate, because let's say that I want to use the print2 function in my class for whatever reason, I can't, because I can only inherit from one class. So if I hover over here, over this underline, it says only one class may appear in a super type list. So in other words, saying that we can only inherit from one class, and that is all. We cannot inherit from multiple classes. Now, with delegation, we can plug in multiple implementations in our own class. So what I can do here, I can say, hey, implement the interface A. So I'm going to inherit from the interface A, but you're going to say use for the interface A the implementation of the first delegate class. So this is what we're saying here. A and the keyword by first delegate, we're saying, hey, use for the interface A the implementation which is provided by the first delegate class, and that will work. Then I'm going to put a comma here, and I'm going to say use also for the class B. So I'm going to type for the interface B. So we're going to type B, and we're going to use the by keyword. So I'm going to type here by second delegate. So you're saying use for the interface B the second delegate implementation, and it's gonna use that, and it's gonna be happy with that. So you're gonna see that we get no error. And now I can override here both the print function and also the print2 function. So if I press Ctrl O, now I can override also the print2, and this is inherently very powerful because we can plug in here as many implementations as you want in your class. So this is, and if you think about in contrast with the inheritance, this is very powerful because here you can plug in as many implementations as you want, and this is very powerful. So this is how you can use delegation in Kotlin, and next we're gonna see how you can use delegation with properties. So to use delegation properties, first I'm going to paste some code here. So I'm going to paste this code here. And what we're having here is a class format delegate, which is inheriting from the read and write property. And it's overriding the get value and the set value. So we are overriding the setter and the getter inside our class, and we provide our own implementation. So whenever you use the setter to set a value or the getter to get a value, we are overriding those functions, and we provide our own implementation. Next, I'm going to create here a class, but first I'm going to delete the code and the interfaces that we have here because we don't need this code. So I'm going to delete this code, and I'm going to create another class, and this class is going to be called user. I'm going to put curly braces, and I'm going to define the properties inside the class. So I'm going to type here var first name. So what we are doing now is we're creating a property. First it's called first name, and now I'm going to use the by keyword. So I'm going to say by format delegate. So what we're saying now is we use the code which is inside the format delegate whenever you set the value or get the value of the first name. I'm going to put parentheses here. Next I'm going to type another var last name, and I'm going to type here again by, and I'm going to type format delegate. So format delegate, and we put parentheses. So now what is going to happen is that whenever you set the first name property or we get the first name property, is going to use our implementation that we provided here. This is what we're going to do, and the same it will be true for the last name because we are using the delegation here on properties. So I'm going to create here a user. So I'm going to type here val user. I'm going to type equals to user, and I'm going to type here with, and I'm going to type user. This is the scope function. I'm going to put curly braces, and I'm going to type here first name equals Alex, and the last name equals 𝐁𝐞𝐬𝐭. Now if I output those values in the console, look what happens. So if I type here print line user dot first name and print line, let's actually use again the with scope function. Type here with, let's pass here user curly braces print line first name and print line last name. Now if you run this code, you're gonna see that it's using the overriding functions that we provide in our format delegate. So we have in uppercase letters like we defined here. We're gonna whenever we set the value, it's gonna be set it with it's gonna change the value to lowercase letters. So we get Alex and 𝐁𝐞𝐬𝐭 in lowercase letters. This is how you can use delegation on properties, and see you in the next video.